All right. Okay. Good morning, everyone. Welcome to workshop. We're starting off bright and early this morning. So I'd like to just give a few opening remarks before we get into what looks to be a very nice program. I think we're going to have a very nice day today, nice conversation around this topic emerging between these two communities. Right. So just a kind of a recap. I think all of us read the call for papers and participated in many ways in the workshop, but just to recap what brought us here today. So there's, as we all know, there's increasing focus on data and many aspects of education, research, and also in society over the last decades. And consequently, there's been a renewed focus on data systems in education and data systems in education research. So we have our two communities, the data systems community, where there are folks doing research in education, mostly from within their own work, within their own practices in their departments and in their universities. Whereas on the other hand, there's the CS education research community, a very mature, long-standing fundamental part of our broader discipline, which has been studying education scientifically as a scientific study now for more than 30 years, 40 years at least. As well as adjacent communities studying topics around data education, thinking, for example, of folks in statistics and mathematics. Right? So we have all of these sort of complementary perspectives, experiences, expertise, and clearly there's much to be gained by building bridges between these communities and sharing and cross-pollinating and working more closely together, right? To share our findings coming out of our own work and our own experiences and our own work in the classroom. To cross-pollinate these perspectives and methods and to shed light on opportunities where we might make progress together around education and data systems and data more broadly. So, so the idea kind of arose organically to start with a workshop to start to build bridges between these worlds. And so the DataEd workshop, we have in mind to be a dedicated venue to start these discussions, right? For our communities to come together, to present and discuss our work in data systems education, experience, and research, and look ahead together where we might go into the future. Okay, so just very briefly, this is a lot of work by a lot of people. So I'm George Fletcher from Eindhoven University in the Netherlands, and my colleagues Fenia Aviloglu and Daphne Miedema, also from the Netherlands. We are the organizers of this workshop. We've been very fortunate to have a lot of energetic, positive support for the idea all along from the very beginning when we had the kernel of an idea to do something as crazy as start a new workshop at SIGMOD'. And so we really want to thank our advisory board, which guided us all along the way. So Michelle Hoda-Wilkerson from School of Education, University of California at Berkeley, Zach Ives here, as everyone knows, and the data community from UPenn. Sriram Krishnamurthy has been very helpful in many different ways, bringing also perspective from outside of data systems, as has Michelle from Brown University, giving us a perspective from, say, training and data roles and data in industry. We've been very grateful to have the support and encouragement of Juan Fekete from Data.world. And from within the data systems and also more broadly data science community, we've also been very thankful for the support and the encouragement of Julia Stoyanovich, who will also be one of our keynote speakers today from NYU. Okay, and then behind this work, we're very grateful for the contributions of our program committee. We tried to have a nice balance across different communities, but also kind of geographic, disciplinary, and background. So we have a very energetic and supportive program committee behind the workshop this year. Okay, so just a process, how did we come to the papers that we will present and discuss today? So we've had 19 submissions. We had a variety of formats, ranging from short papers to research proposals. Each of the papers that were submitted were reviewed by 3 PC members, so single blind, and then based on the reviews. So we have actually very constructive, very insightful and helpful reviews that were put forward by our PC members, and the discussions which ensued. Together, the PC chairs made a decision on each of the submissions. And so in the end, we selected 10 papers for presentation and discussion today, and also to appear in the proceedings. So you'll find on the website for the workshop a link to the ACM proceedings for today's workshop. Okay, so a bit more detail about our program today. We're very fortunate and very thankful to have two excellent and leading voices in our communities to give us keynote lectures. So in the morning, Kathi Fisler will talk about the work that she's doing on data-centricity in education. And in the afternoon, we'll have Julia Stoyanovich talking about the work that she's doing on rethinking data science, education, curricula, coursework, and to involve concepts of responsibility. At the end of the day, we will close with an industry panel. So we're very excited about this. We have Sarah Krasnik and Emilie Schario, where we'll have kind of an open discussion and dialogue. Also, hopefully, very much hope that you and the audience will participate in this. We don't want it to be a one-way conversation, but really a conversation within the whole workshop today around industry perspectives on education and training for emerging roles in data and what we might think as educators and how we might work together with folks from industry to think ahead in computing and research around data systems. Okay, so I think everyone's seen the program just briefly, so I'll close my remarks here shortly. We'll have our opening keynote, so Kathi will kick off the day, and we'll follow this by a short paper session, and then we'll have a coffee break at 10:30, and then a much longer paper session before the lunch break. And then after lunch, Julia will kick off the afternoon with her keynote lecture, and we'll follow this. It's a bit experimental. We'll see how it goes. So we're going to have kind of discussion sessions where we'll break out around themes. I think everyone has seen the call for say contributions or suggestions around topics that we might discuss in breakout groups together. And this goes also for the folks online. So please feel free to take a look at that Google Doc. And then so we'll kind of organize ourselves and then come back and share our findings. And so Daphne and Fenia will say briefly a bit more about our goals there and what we might do together coming out of the workshop. And then in the afternoon, we have, after the afternoon break, we'll have a regular paper session. And then after the final break, we will close the day with our industry panel and some sort of closing remarks and the discussion of what we might do together coming out of the workshop. Okay, with that, Daphne, would you like to make a few remarks about some practicalities?
I'll just take this mic. Let me turn around so also the people online can see me. So George was talking about a Google Doc. If you have not seen this, you can access it by going to our Slack. So this QR code can get you to our Slack, and you can also find it on our website. If you want to tweet about the workshop, we have this hashtag Dataed'22, and the Slack channel has, or the Slack, what do you call that, team thing, has a couple channels also dedicated, one for discussion session and one for panel. So if you have suggestions for the discussion session, you can post them there. And for the panel, if you have any questions already that you're thinking about, then you can post them on that channel. And there's a general SIGMOD channel there as well if you have questions to our speakers about their talks or any other remarks. But we'll also look at the Zoom chat, of course. And then finally, we will be writing a reflection after this workshop has finished. If you're interested in joining us on that, you can reach out to us in person if you're in person, or send us a message either on Slack or personally. And I think that's it for the introductory remarks. All right, giving back to George.
Okay, so then we'll move to our first real session. But before we do that, are there any questions from the audience here or online about the practicalities or anything? All right, so there's a chat message. Let's see, before we jump in. Okay, it was a link to the proceedings and someone answered the question already. Yeah, so that's answered. Yep, okay, everybody okay? Ready to get started? There's some more people coming in.
Hey, just one more question. Where do you look for the discussion session and the panel suggestions?
So if you join the Slack community that we've started, either through this QR code, if you go to the workshop website, you'll find a direct link you can just click on. And there we've set up these two channels, one for the discussion session after lunch, and then one for questions to pose to the industry panelists.
So they're not under the SIGMOD sections, they're separate, I think.
No, we want it to kind of persist and live beyond and kind of be a separate activity beyond this
Absolutely.
workshop. Yeah.
Absolutely, thanks.
Okay, so yeah, just let us know if you can't find those channels. Okay, then Kathi, if you would like to start setting up, I would like to introduce you. I will step down. Ooh. Yep. Yeah.
Okay.
Okay.
And
Oh, yeah.
all right.
Okay, I will briefly introduce our first keynote speaker and everyone. Can you hear me? Yeah, okay. Okay, so we're very fortunate today to have Kathi Fisler from Brown University give our opening keynote lecture. So Kathi Fisler is a professor and director of undergraduate studies in computer science at Brown University. She's very well known and very influential in the computer science education research community. For example, her work on notional machines, her leadership in the Bootstrap program, looking at issues of equity and kind of increased participation of underrepresented minorities in K-12 in computing and data science. And she's currently leading a project in data-centricity and data thinking in computing education. And I believe this is the topic of her keynote today. And so we're very excited to learn about the work that you're doing. And so thank you very much, Kathi, for joining us.
Thank you very much for the invitation. Just confirming that the folks on the chat are hearing on Zoom are hearing okay? Anybody got a problem? We're good? Okay. You know, I'm a professor, so I'm happy to take questions during the talk. So if anybody watching remotely has a question, please just put it in the chat. I don't see the chat on my screen, but I trust that the organizers will interrupt me and let me know if a question comes in, and same for those of you here in the audience. And what I'm talking about here today is joint work with Shriram Krishnamurthy. We've both contributed to this in different ways. So just to round out a little bit from the introduction that George gave, I am at Brown University. I have been teaching intro computer science for about 25 years. And about 10 years ago, I shifted my research emphasis from formal methods, which is where I had kind of academically grown up, over to computing education, because I realized that people were harder to understand than any system I ever tried to model. Yes. Oh, the small window. Let's see. Thank you. Okay. Whatever you need to do is fine. Yeah. Our new world of all needing to be hybrid Zoom experts, right?
Yes, exactly. All right, let's see how that was. Good. It's good. All right. Oh, move the bar.
Yeah.
Click on more. Yeah.
Yeah.
That's beautiful. This is the first time to speak. By the end of the week, we're all experts.
And we will all forget it by next year, which is how these things work. So I'm really excited to come join this conversation from the computing ed side, because I think there is a lot that's going on that's worth talking about here. I got into this work. Oops, let me get the focus back here. Okay, I got into this work partly looking at pressures on the computing curriculum from my perspective as director of undergrad studies of the largest major at Brown at the moment. And so if you look at computing or informatics curricula, for those of you coming from Europe, you've got the rise of data science, which many people are now talking about and thinking about where does that fit in from a computer science department perspective. There's the social societal impacts of algorithmic decision making. We have to start acknowledging that and teaching students about these issues. There are concerns about diversity in tech. And the other thing we're seeing is a strong tech economy is bringing many more students with much more diverse interest backgrounds, preparations into a computer science major. So when I started teaching 25 years ago, pretty much everybody in the room was going on to a job in software. But now you've got students who are trying to get enough computing to make sense of their own disciplines. And so this is really changing how we have to think about teaching computing at the introductory level. And what I'm saying here is introductory level, I've worked both at university and done a lot of work in K-12 for the last 20 years. So I kind of have both of those floating in my head. But the premise of the project I'm going to talk about today is how do we redesign introductory computing or informatics to support data science, diversity, and social impacts? Okay, and that's kind of the goal behind this whole effort. So if we take this question, I'm going to say there's three high-level framing ideas that I'm going to talk about today. One is centralizing data in the way we teach intro computing in a way that still leads into CS data structures, so it's still meaningful in a computer science context. Now remember, I'm saying this from somebody who's in a computer science department and trying to design courses and curricula that make sense in a computer science department. So it's not to de-emphasize any of the other programs where this might be happening, but this is just where I'm situated. We need to leverage data engineering, which is where I think a lot of the work that goes on in SIGMOD comes in, because it actually works out really well to motivate computational concepts like functions and composition and other sorts of computational ideas. And we want to embed social impacts within the traditional technical content. I think you need to do all three of these things to get to an effective integration of data in computing. And the talk is going to lay all this out and explain the argument. Everything that I'm talking about here is already embodied in an existing curriculum that has a textbook. We have been offering this new intro course at Brown, not so new anymore, in data-centric introduction to computing. We've had over 1,000 students come through the curriculum, so we've gotten a chance to see what works and what doesn't. Vassar College has also picked up the curriculum, and they've now taught it twice. So this is in a form that we can disseminate to other people, and if anybody's interested, feel free to talk to me during the day. All right, so first point, what does it mean to centralize data in introductory computing? And I want to go at this by thinking about how intro computer science curricula are often structured. So some folks take an intro that's focused on imperative programming, right? These are the modernized holdovers from the C and C++ intro generation, where you start with numbers and variables and assignments, conditionals, loops, arrays. There's a group that starts with object-oriented and maybe a bit of algorithms, where the first things you do are classes and objects. You still need conditionals and loops and arrays, but you get into some sorting, some graphic algorithms. I understand from my colleagues based in Europe that this is a common model in many European computing programs. And then there's also folks who talk about teaching programming with a functional programming perspective. So you don't start with the assignment statements and the variables, but you start off with functions, conditionals, lists, and you get to recursion quickly and so on. So these are all kind of different models of doing this. And what I want to point out about them is none of them really suits our purposes for putting data front and center. The first one emphasizes control, not data. The second one is putting data structures before data. And we're going to talk about why I think that's problematic. And then the functional intro emphasizes traversing data structures, but again, is not really thinking about data as much as data structures. And you kind of see this in what's the first data structure that you see in these curricula, right? You get some variant of linear sequential data. Here's the question I want to pose. What if two-dimensional tables were the first data structure that we showed to students in their programming class? Before they see lists, before they see arrays, let's start with two-dimensional tables. An example of this is the kind of thing that would be on a spreadsheet. Okay, so we've got here a table. This is an example of a table that I use in my course that's just capturing ticket purchases to an event. Okay, so how many tickets are there? What discount codes? What delivery method got used? Something like this. Now, why do I think this is a great place to start in a data-oriented version of computing? First of all, there's an authenticity perspective, which is important for students who are coming in not identifying as math CS people. It's rich data. It's structured. It's a format that's familiar to students. So we as instructors have a lot to work with. The students have something to latch on to. You can work with data from many different domains. Okay, the curriculum I'm talking about here, there's any number of domains you could draw your data sets from. And you can be using computation to answer meaningful questions, right? Instead of saying, hey, here's the towers of Hanoi. Isn't this exciting, everybody? You can actually start with a question that the students in the room care about. Again, even if they don't see themselves as CS people. The first time I taught this course, I had students walk into the classroom and the class was being held in the computer science building. And there was this one kind of wide-eyed student sitting in the front of the room. And, you know, I asked her if she was okay. And she said, this is a scary building and I'm in it. This is the perception that many students have, at least in the schools I've taught in, of computer science. It's scary, it's intimidating. And the more we can do to make it look approachable while they get off the ground, the better we are going to serve this more heterogeneous, diverse population of students trying to come into these disciplines. Another perspective I think the 2D does really well is the data science perspective. You can get into basic data science ideas of analyzing data, statistics, visualizations. So if you're trying to bring data science solidly in, the two-dimensional tables give you what you need for that. The data engineering perspective is where this all wins big, in my opinion, because you can do tasks such as identifying errors in data, normalizing or transforming data, writing some scripts or functions to repeat the same prep processes on similar data sets. These are all natural uses of functions, conditionals, loops, all the things that we want to teach normally in an intro CS, but framed in a way that makes sense to students who kind of their world of data is sort of framed around a two-dimensional table. And finally, the social impacts perspective comes in here because you can explore questions of representation, bias, correlation, how they impact people, both in the problems you give students to do and in the data sets you choose to talk about. Okay, so there's a lot of fertile ground here. So this is why I'm going to put forth that two-dimensional tables are the right starting point for making data centric in computing education. So the overall goals, design goals of the course that I'm going to be talking about, is as I've been talking about, being welcoming and supportive of students who don't see themselves as CS people, covering sufficient skills to still be viable as an introductory computing course. And I think this is really important if we're talking about impact and thinking about university policy and whatnot. You can say we're going to make just an intro data science course, which many places are starting to do. But then what happens for course 2 for a student who gets interested, right? So by having a course that does the data science, but is also viable as intro computing, you're also now supporting students who do get interested enough to continue. Other thing you also want to support are the students who are going to stop with this course. So a lot of the students who've come through this course at Brown are really aiming to be able to be assistants to faculty across campus on research projects. So they want to work with a public health professor, an education professor, an econ professor. So they need to come out of this course with enough skills to be able to do something useful in practice out of this whole part. All right, so oftentimes, I also grew up partly in the programming languages community. So when you talk about this stuff, the next question is utterly obvious if you are in programming languages, and also actually, unfortunately for many people in computing education, what language do we use? Right? Do we start with R? Do we start with Julia? Do we start with Python? Let the religious wars and arguments begin. Stop. Totally the wrong question. Okay. We're designing a curriculum. We're designing an approach. What are we trying to teach? Let the content drive the language choices. Okay. Okay. So let's talk about the high level flow of what a course like this might look like. So if we're going to have a data-centric computing, the way I like to start it is actually by looking at images. Okay, because what images do, images, again, they're familiar to students, but images have subimages and structure. So it's a way of conveying the idea to students that both code and information have structure, and that matters to us in a computing context. Now we introduce tables. Okay, so tables really is the first data structure. And we do computations that can transform and summarize data and data sets. Now we get to lists, because sometimes we want to aggregate information across data points, and lists are kind of the data structure that gets used in computing to do that. We then go into data types, whether those are, tuples, records, whatever phrase you like to use for these, but that attributes within a data set sometimes have structure. Think timestamps, for example. Now we're going to do trees, because data points might have relationships among themselves. And now the computer science part is really coming in strongly in this. Now we'll get to state, because sometimes we need programs to be able to update our data and our data sets. And then we'll come into hash tables, talking a little bit about efficiency and how do you work efficiently with associative data, if that's your context. Okay. And again, this is a 1 semester college level intro course. So this is the flow of it. The point is that every topic here is motivated by something that a student might recognize they might want to do with a data set. And I think that's essential for having this speak to the broader audience of students who might be interested in this content. This sequence also gives us opportunities to bring in a lot of other issues. So socially responsible computing comes up naturally in any of these spots. We bring it in with tables and data types and trees. I'll talk a little more about the specific exercises as we go. You can also talk about things that come in from computing education, such as how do you plan a program? How do you take a problem statement, break it into tasks, put it back together again? That's what's called plan composition and planning. And there's a lot of literature about how hard this is and how you do it effectively in computing education. Those two, I'm biased because these are the 2 areas I've worked on, just admitting that, but, and also notional machines is the CS Ed word for semantics, okay, of understanding how a program is running and what it's doing. All right, so that's the high level design, the points we're trying to get across. Let's dig into the details a little bit. So, easing students into computing with image composition. My first homework is to have students compose images to make flags. Okay, so if I look at the structure of this flag, well, it's 3 colored rectangles stacked upon one another. Below it is the code that we write to do that. So you'll see that we're making 3 rectangles, an orange one, a blue one, and a red one. And our language has these constructs, this construct of above, which takes 2 images and stacks them one on top of the other. Okay, so we make 3 basic rectangle shapes. The above operator composes into a larger image. We compose again. We take another operation called frame, which draws the border around the outside. This is a sample of the kind of algebra of images, okay, that you can use to introduce students to this idea that there's structure in our data and our information, and that structure gets mirrored in the programs that we write. So it kind of helps students build this up, like draw out your image and how you're going to build it out on paper, migrate that over to code. Okay, so this is how we start. Now we're going to bring in tables. So this is the same sample table I showed you earlier. Sometimes the simple ones, students just type in the programming environment. You can also import it from Google Drive. And then we're writing functions like shown on the bottom. So there's a compute fee function, which is going to multiply the number of tickets, say by $10 a ticket. So there's a basic function you can write. And then there are operations to add a new column to this table that says apply the compute fee function to every row in the table and make a new column named fee. Okay, so this is an example of the kind of programming we're talking about having students doing. Notice that it's tight, it's kind of lightweight, it's not heavy with loops and assignment statements and the things that we often think as the bread and butter of intro computing. That's not where we're going with this. In here with this sample table, we talk about issues of normalization. So the fact that sometimes student is capitalized, sometimes it's not, none versus blank spaces. So we actually write small programs that go through and normalize everything to uppercase. And if you notice that none shouldn't be there, you run through and weed that out. So it's showing them the interplay of human inspection and writing code to help them manage data. There's a fun exercise I do with this, where I'm trying to teach students that if you're going to do responsible work with data sets, you need to spend some time checking that those data sets actually are clean and well prepared. So I have them make a histogram, a bar chart to show what are the common delivery models. And when they do that, what they end up noticing is that email has 2 columns in this bar chart. Well, actually, this cell here, the third cell up from the bottom, says email, not email, right? You don't spot it, they don't spot it, but it's showing them the importance of actually using visualizations to make sure your data makes sense, because you can't do trustworthy computations on untrustworthy data. So that can come up here. We can do things that filter out the table to isolate all the pickup rows and then maybe do some computations. So again, it's showing students why computation is important for actually working with data. Now, round about this point where we have functions and operations and code flying around, there's a moment in class where they're just kind of staring at me. And I'll say, how many of you are asking yourself why we aren't just using Excel for all this instead of all this painful coding stuff? And this nervous Twitter runs through the room. It's like, good, it's a good question. Why are we doing all of this? I will argue that this is where data engineering is critical. Because if all we're going to do is ask them to produce plots and maybe isolate part of a table, yeah, they can just do it all in Excel and sheets. But the idea that we will have processes for managing and maintaining data, and we may need to repeat those. If you have a different spreadsheet for every month in a company or every academic year in a school system, we want repeatable processes. And this is what computing and programming lets you do. So we spend a lot of time trying to emphasize also these other tasks that say going beyond spreadsheets is going to give you real power. I'm sorry, you're just going beyond spreadsheet tools. Okay, so that's part of this. Okay, let's talk about social impacts. What kinds of things would we do with social impacts? So here is a, say a table that's showing a survey that maybe somebody collected. And there's this other information that's been collected on the back end about what browser you're using and what location you're in and things like that. This opens up to talk to them what information gets collected about you. There is a lovely article that one of my teaching assistants found that talks about the information that your car collects about you while you're driving. And it's like 200 variables that your car collects about you, including your weight. That freaks them out. Like, what do you mean my car is collecting information about me? So we talk about what are the ways in which we move through the world just as consumers, where the tools we use and the automated things in our life are collecting data about us. And now what's the responsibility? What can happen with that data? What can get inferred about you from this data that you didn't even know was being collected? What decisions get made based on inferences? So we will get in now to some of the things about either bias or how just reducing somebody to an age range, an occupation, and a weight, what does this miss that is important information to have before you're going to make a decision or a recommendation on somebody? So all of these issues come up, and we do this through a variety of activities. There's readings, there's role plays. We do some code inspection activities to try to explore how all of this surfaces. What I would say in terms of bringing social impact, kind of the big lessons or the big guiding posts that I have in doing this, is to connect social impact content to how data gets created, handled, and processed. It's not enough to do a disconnected discussion of ethics. I have colleagues who will say, everybody should read the ACM Code of Ethics. And you know what happens if students read the ACM Code of Ethics? They skim it, they finish the homework, and they don't really think about it again because they think it doesn't apply to them. They are first-year programming students, and everybody knows that ethics is the responsibility of the executive suite of the company. If I achieve nothing more in teaching students about social impacts than that they make decisions as low-end programmers that can have implications and ramifications, I will be content that we're making some headway, right? It's obviously they need more than that, but they need to start there. And so I think tying it to the coding exercises is really important. I want students to understand the data lifecycle that affects them as consumers. Again, I'm working with a population of students who don't identify them as CS geeks. They haven't thought about this stuff. They need to understand, just as citizens, what can happen here. But it is equally important that they understand how they can introduce these problems by not being aware of them. And so that's kind of what we are working on here. Just a call out to Brown, this is part of a larger program at Brown. We are creating a social responsible computing curriculum that weaves into all 4 years of the major. Right? So we have these modules that go into courses, they're interconnected and developed. So I'm also in a department that is very interested in having this groundwork be laid early on, and that is a factor in why it works. But while we're talking about responsibility, let's talk about testing and validation, right? I'm going to prepare students who are going to go off and potentially work with a professor in another discipline and help write some code for their data sets. And the professor's going to publish research. Darn, those data sets better make sense. And that those processing scripts better be accurate, right? So we've talked about the data making sense when we did the normalization work. But we also have to think about how we check their code. And it raises a question, how should they validate that the programs are doing what they want them to do? Now, as computer science folks, we know the answer to that. It's called testing, right? We're supposed to test our programs. And we get to that, second, third year of computing, because testing is a hard topic. We'll get there. No, it's got to start at the beginning. And in this course, we have students create small predictable testing tables. So if we give them a big data set and say, show us what's going on in this big data set, part of their assignment is to say, what were the small tables you created with, say, 5 or 6 rows that you used to make sure that you were getting the answers you wanted before you put this on the big data set? I think if we're going to take this idea of data science and responsibility seriously, we have to also say that program testing is not an advanced topic. for upper level CS students. We, as the faculty or the leaders, have a responsibility to train students to check that their analyses and processes are correct, because we are preparing them to go out and wreak havoc on the rest of the world with the small bit of coding they know. And they're not good at knowing what they do and don't know. Nobody is, right? It's not a comment on students. So we really have a responsibility to include technical software testing as part of having an impact on society. All of this happens in the tables unit, right? So this is a whole lot that's going on in the first, say, 6 weeks. This is the first 6 weeks of the course that I'm teaching. We still have to get into some of the rest of it that bridges it into the things that make it look like a regular computer science class. We do lists by talking about summary statistics on columns, right? So there's an operator that says extract a column into a list, and now we do things like summary statistics. We do some recursion, like we just show them how to work with processing lists. For data types, there's a great exercise when I say, now we're going to add timestamps. How do you want to put timestamps into this table? And they work in groups and debate between, do you make different columns for each of hours, minutes, seconds? Do you put a table in there? Like, what do you do? And we get to the idea that, well, if you put a small tuple data structure inside a column, you get the benefits of a column that you can break apart. You also see now why programming environments give you more than spreadsheets, because this nesting, this hierarchical nesting, is something that we can do in a programming context. This is another place for impacts, because when they start designing data structures and schemas for different things, they're going to run into topics that bring up inclusivity. For example, what data structure do you use for names? Do you make a Western assumption of people largely having first names and last names, where the first name is first and the last name is second? What do you do with people with one name? What do you do with Indian names, where the family name comes before, China, where the family name, all these other kinds of issues? There's a beautiful article. It's not a real article, it's just a blog post. Falsehoods programmers believe about names, dates. These are great. They'll list like 60 different things, real world situations that come up on data schemas for each of these topics. So we give that out as a reading. With all of this, real world data scripting tasks are now within reach for them. And what do I mean by real world data scripting techniques? You're given a CSV file and you have to parse it out and put it in a table. You have to take a table and write it out to CSV. These are now it's routine things of running down all the rows of a table and doing some manipulation on columns. So we do those tasks in class, because these are the kinds of techniques that some of them may have to program in, again, if they're going off to work with another faculty. Now we put up medical ancestry. And we say, okay, we have to track all of somebody's ancestors to look for hereditary disease analysis. So here's your table. How are you going to do it? And they tear their hair out trying to figure out how to write a program to get all of the ancestors. And why? Well, because a table really isn't the right data structure for this, right? In a computer science setting, we know that you would put a tree in here, right, and capture it that way. So problems like this highlight why data structures have to be richer than just tables. So we'll spend some time talking about that. Now, after all this, they've gotten some facility with data and how to write programs. Well, now let's think about programs that have to update their data instead of just take a data set and chew on it and present analysis results. So now the tables are part of the state of the program that we're trying to maintain. And as I mentioned earlier, we then get to hash tables with an eye towards some performance. It's actually just an excuse to get them to also understand hash tables. We talk a little bit about JSON and file formats and things like that. This is the narrative that I have found works with the students and I think makes sense for the goals we've been trying to put forth. Now we can have the which language conversation. Okay, so we have the which language conversation, and at least in places where I've been, the answer tends to come up Python, right? That Python's a good place to end up, especially if you are preparing students to go into a computer science curriculum. Like R doesn't really get used in upper level computer science courses, Python does. So let's just agree that, you know, we're going to teach this course in Python. Toss out a question. Okay, we want to end up in Python. Let's take that. Does that mean we have to start there? Right? What if we started someplace else and then got to Python? And I think there's some perspective here that I've really enjoyed from reading Hadley Wickham's Advanced R. So, you know, Hadley's the developer of RStudio, and his book starts off saying R at its heart is a functional language. And what do we mean by that? It means that we are working with operators like maps and filters and fold, like those kinds of constructs are what you see in code like R. It's what you see in Python systems like pandas, right? So if our goal is to get to having students able to use data science languages and tools, why not start by getting them comfortable with functions? Because that's ultimately where they're going to have to get to. So what we're going to talk about is using functional programming as the lead-in to build up to Python. Okay, now the hackles go up among the faculty listening to all this. What do you mean start in functional programming? Functional programming is hard, it's obtuse, it's like not mainstream, nobody knows how to use it. From an education researcher perspective, we need to understand that Python is not easy for CS novices. We've told ourselves this. Many people say the conventional wisdom is, oh, well, Python is easy and beginner friendly. I think it's easy and beginner friendly if you're not a beginner, from what I've seen, right? What goes wrong with Python? Well, let's start at white space semantics. For white space semantics to make sense, you have to appreciate that programs have internal structure. This takes a couple of weeks at least for even the strong students to actually internalize. And until you understand structure inside code, that it's not just a sequence of lines that you read from top to bottom, right? But there's actually a hierarchy and a structure in the way that those code lines are organized. Why would white space semantics make sense? It doesn't. Okay, so right there, that's a headache. For all the talk about Python being a great beginner language, there is no beginner Python IDE that supports software testing, that supports understanding semantics of languages. It doesn't give you the views of like the debuggers and the tracers. You get some of this in professional grade Python environments, but professional grade Python environments were not designed for beginners, right? And the beginning friendly Python environments weren't designed for teaching functional programming and testing. So there's just nothing good in this space right now. Python doesn't give you any notion of abstract data types. Everything's a dictionary. And while that might make sense for professional programmers, for teaching concepts early on, it's a bit of a rough spot. The error messages are for professionals, right? And if you've never tried explaining to a beginning student what a Python error message is telling them, try it out. Okay, it doesn't work. And the list functions all do mutation by default, which makes it hard to do testing, and it screws up all kinds of things, because the reality of students is they're going to go online to look for help when they get stuck on homework, and online is going to teach them all imperative Python. But that's what they're going to find most of the time. So you also have to kind of plan curriculum defensively around what Stack Overflow will tell your students, because that is the game you're playing. I like it when a student comes in and is like, this wasn't a very good program. Oh, well, Stack Overflow said it was fine. Well, yes, but I'm the professor of this course and that Stack Overflow developer was working on something, like that's not how this all works. What we have been doing at Brown, based on all of the research we have done into programming languages and computing education, we've been building a programming language called Pirate. The name is intentional. Okay, pirates steal things. Pirate steals a good bit of the Python syntax, not the white space part, but it makes it look familiar. Okay, so it's functional programming with proper data types, built-in support for software testing. A lot of research has gone into the design of the error message, all beginner oriented. Now, this same group that's worked on this, we used to do a lot of work teaching functional programming in Scheme, Racket, whatnot, and the parentheses bitch you every time. Fine, we'll give you your syntax. We'll keep the semantics. Well, this is great. This doesn't look anything like that function. Okay. So we've been developing this language. It has built-in support for images and tables. The code snippets I was showing you earlier were from Pirate. And again, it embraces a richer way of thinking about testing and what testing all means. Around that, we've got a series of tools that we've been building for helping students learn to write good test cases. So you can write a set of small unit tests for a program. And if the instructor has uploaded some buggy solutions, you actually get to test the quality of your tests. And this is a side-on tool that we've built in here. So this is just an example. When I say that the curriculum and the work we're doing here are built on a lot of research, there's a whole line of computing education research papers that we've done over the last 8 years to figure out how to effectively teach students about testing. Okay, now we finally get to answer the which language slide. Okay. We do Pirate up for the first 2 months of the course, all the way up through trees. So it's all functional programming, heavy emphasis on testing up through there. And then when we're going to get to state and updating tables, we make the switch to Python. You could make the switch to Python at different points. This is we found this is a kind of clean way to switch over. So we still end up in Python. We add a segment at the end, which is to teach them pandas. So now we take all the functional higher order table programming they learned in Pirate, and we say, look, it's all there in pandas. The notation's a little different. The setup's a little different, but we bring it back around. We do a lab on how to use Stack Overflow responsibly in order to set all this up. All of this gets followed on by later courses. We'll do things like objects, more data structures, algorithms. So that's kind of what this is leading into. All right, let's step back. Okay, that was kind of the deep dive. Let's pull it all together at a high level. The first message is that if you're thinking about how we go about this from an educational perspective, content has to come first and language second. Okay, even if you don't come down on the same language decisions we did, don't make this about language, because that's just not going to lead to good outcomes from an education standpoint. Effective computing and programming education comes from the sequence of content and skills we're teaching with an eye towards what students need and appreciate. How the language and the tools actually support the content and don't get in the way. And your IDE needs to reinforce those skills from a learning perspective. This is what it means to do good, responsible curriculum design, whichever choices you make around those. I argue that functional first benefits from having a lightweight computational semantics, good support for testing. It just cleans out the stuff that professional programmers love and novices trip up on, because those languages weren't designed for novices, which is fine, but then maybe shouldn't be using them for novices. And the other big point I want to leave you with here is that teaching socially responsible computing has to include teaching socially responsible computing practices, such as testing, right? Limiting it to testing is by no means sufficient, right? We need to teach the social impact sides of just the decisions we make and how we go about it. But these two things go hand in hand. And if we embrace teaching about ethics, but don't embrace teaching about testing, I think there's a conversation that needs to happen. sorry, I have a little slide coming in wrong time. Let's go back to diversity. This was one of the goals at the beginning. How does all this fit around engaging diverse students? Well, our objectives are, we've got to support a range of student goals. We have to help students believe that they can succeed in this, because that is a significant barrier to students who might otherwise not consider going into computing or data. And part of that is helping students see the content as personally relevant. There's been ample research showing that this is a big part of what this looks like. Wait a minute. This one about the upgrading high school, I don't know how that got on that slide, but it shouldn't have been there. I'm pretty sure it wasn't on the original. Okay, we copied this over. Anyway, ignore that one. Data management and analysis is relevant across disciplines. So that's going to support those goals. Images and tables, comfortable places to start. And when we get to personal and culturally relevant, I think 10 years ago, we used to think that letting students choose their own data sets or own examples or own code assignments was how we were going to get cultural relevance, right? The students had choice. I think more modern understandings of what it means to reflect cultural relevance in curricula, that's a piece of it, but it is nowhere near sufficient. You have to get to richer kinds of ways of making the content relevant to students' lives. Social responsibility is really good for that, because it lets students who have concerns about impacts of tech on different parts of their lives actually bring that in to the questions we ask in the projects that we do. Yeah, and this is just resharing from earlier that we've had 1,100 students go through this. The course evaluations are through the roof, of students saying, I never thought I could do this. I love the social impact stuff. And our enrollment numbers, at least for women students, are very strong. For the URMs, we're at 10% of the population, but this is one of 4 intro courses in our department. So it's not that we only have 10% of students taking intro, it's we have 10% taking this particular one. Okay, I want to close out with a couple of policy discussions. Several years ago at Brown, the idea arose of having a data science major. And this is a conversation that I understand goes on at many universities. Let's have a data science major. And now you have to decide, how does the data science major and the computer science major work together? So the data science major is going to start with intrastats, some data scripting. I mean, this is what I hear from people who put these programs together. And then later on, they're going to get to more stats, they're going to get to big data, they're going to get to data management. So left isolated, that's what data science would do. Left isolated, a CS major often does intro programming, data structures, they all weave together in the first couple of years. And then later on, you get to databases, data science, and machine learning. What happens to the student who does that first data science course and says, programming is great, I want to switch to CS? What happens to the CS major who gets to data science in the upper levels and said, oh, wow, this data stuff is cool, I wish I were doing data science? We can't pretend that these don't interact substantially for real world practice. Right? The student who gets all the way through the data science major says, oh, I really need to take databases. Well, databases is several levels down in this other curriculum. I think what we're seeing is that there's little content alignment. So students end up having to start over or do these hodgepodge things, or we replicate courses. And I think we're being naive if we think that students are going to go into college knowing which of these things they want to do. Novices don't understand these fields well enough to decide. What they know is that computer science and data science get a lot of press, and their parents are telling them they need to major in one of them. Right? But they don't actually understand the differences. So what I'm putting forth with this, and what we've achieved at Brown, is this course I'm describing is now the intro course for both the data science program and the computer science program. So students who take this course, now they've had experience with both. And they say, okay, I'm going to go into the computer science major, I'm going to go into the data science program. So from a policy perspective, I think we really need to think about how the design of these courses lets student interests evolve and merge over time. that's the university level policy perspective. I saw that K-12 came up on the potential list of discussion topics. So I'm just going to say a couple of quick things about K-12, and then I'm happy to talk about this more. I've been doing K-12 computer science outreach for 25 years and data science outreach for 6. So, and I do a lot of this work at the national level with standards and things like that. So I can talk about those perspectives to anybody who's interested. And this is going to be US centric. I imagine some of these issues are coming up in other countries, but I don't know the policy discussions in other countries. So just as a in the US, we have a significant national level discussion underway about data science. Now, this is following on to the 6 years ago national level discussion about computer science, which is now just working its way through the system so that several states in the US now mandate CS be taught in all schools. No, not to all students, but offered in all schools. And there's a significant difference there. Now, luckily, data collection and visualization is part of most states' standards for K-12 computer science. So there's an opening there for data science. But there are a lot of debates about how to do it. So there's a group of folks coming out of the math and statistics world that say, let's just upgrade upper high school math and we'll put data science and more statistics in there. There are people who say, well, let's include it in those CS courses. There are folks who say, well, if we're going to have people do this early, we got to get data science concepts into Scratch or block-based program. Each one of these has a flaw. For doing this in upper grade high school, many students start checking out of math in the 7th grade in middle school. So if you wait to get the data science in upper level high school, you've lost a lot of the students we might otherwise want to be bringing in. Including in CS courses in K-12 doesn't provide that opportunity to all students. It provides the opportunity to all students who opt into K-12 CS. And we know what the diversity numbers there look like, and they're not good. Block-based programming is not authentic in other subjects. Other teachers in other disciplines are not looking forward to teaching Scratch. They really could care less. So if we want to think about bringing data science in richly to K-12, we have to think about going to where the students and where the teachers are and making a path to bring data science in meaningful ways. You do this by integrating data science into courses across the curriculum. So Bootstrap is a program that's been, so this is an outreach program that's been running for a dozen years now. And we specialize in making data science and computing materials that can integrate into existing subjects. We provide curricula, we provide professional development, and we do a lot of research, ed research on how all this is working. Right now, we have modules that put data science content into middle school math, into high school math, into pre-high school science, and into middle grade social studies. And the social studies angle is really fun and cool to think about how you bring some of this in to a context that doesn't even look like science, math, and engineering. We've got a position paper that we have put out on the ingredients of data science education, because basically we're in a turf war right now between departments and funding. And the argument is responsible data science education has to include math stats, computing, civic responsibility, and domains of study. And so that's there. All right, last slide. The whole argument here is that data-facing issues come up in 3 disciplines. There's data science, there's computer science, there's data engineering. We each have a piece of the data puzzle. Data engineering is often getting overlooked in these conversations, right? So I think it's great that you are having this workshop and starting to build a community to talk about the role of really working with and managing data, because I think it's essential to make all this work. Data science is appealing to students across campus because it makes sense to them. Data engineering needs non-trivial computer science, though. So you have to figure out how to build up to that. Students in computer science increasingly need data and statistics. That's what the discipline has become. So we owe it to them to figure out how to put it in. And we've got all these increasing calls for taking social responsibility seriously in computer science. The intersection of these 3 areas is a sweet spot for talking about all of these. I've focused on it here for introductory courses. You can extend this up to upper level courses. We have a position paper that we published in CACM in July 2020 which outlines this whole vision in short article form. I mentioned we have the curriculum with the textbook and the course web pages. I don't put my stuff behind, course management systems, the homework assignments, the labs, everything, the notes, it's all there. Go at it. Let me know if you use it. And that's where I wanted to go. If anybody has any questions or comments, I'd happy to have some discussion. Thanks.
All right, we have good time for discussion.
Thank you for the really nice talk. So one problem that we are facing at my university is that the other departments say they need to have their own introductory programming course because the politicians need different examples and the sociologists and so on, and that we from CS are not doing it right, and we cannot reach out to those students. So I wonder how to bridge the gap, because it's also not economic to have like 5 different introductory Python courses there.
Right.
And yeah, and everybody doing their own thing.
Right, right. So the way we have been trying to think about this, and we have some of this going on as well. One thing is we ask them, well, what happens for the students who get interested and want more? Like there's part of it, which is that very practical discussion that if your students wanted something else and your department's not going to offer it, and they try to come to our department, they're going to have to start over. So we have to figure out how to bridge that. But I think more seriously, one of the things that we are talking about in the next round of significant revisions to all of this is figuring out ways to modularize the exercises and the labs so that we could get, for example, the sociology faculty to say, what is a problem that you would really like your students to have done? What kind of questions, what kind of data sets? Okay, we can put them into this lab by making some alternative proposals, right? So we're going to try to do it that way by getting some of that modularity in place in the course design. I think the other thing that, and this argument doesn't always work, but sometimes it registers for somebody, is that intro computing is not easy to teach, and there is a body of knowledge about how to teach this effectively. And just because you know how to program does not mean you know how to teach programming well. And so, if we really want to take advantage of what's known about effective introductory programming instruction, are we getting there by having every department on campus say, well, here's the stuff I needed to know how to do. So those are some of the ways that we have gone at that conversation. I think the modular design of assignments to let different departments plug in something is probably going to be the most practical solution in the long term. We're not quite at that yet. We've still been recovering from teaching under COVID. But I would think in the next couple of years, we're going to try to head that way with this.
Cool, thanks.
Thank you. So if you currently cannot use or do not use Pirate in your introductory courses, how much of this table-centric curriculum could be realized in, well, we're using REC, for example. How much could I realize that? How much would carry over into a world where I can only have lists of records or something? Would all be lost, or can I simulate or emulate the stuff that you've been talking about in these languages?
Once we get to data types and lists, we've got lists of records, right? The problem you're going to have with lists of records, if you think about it from a programming perspective, when we're doing this starting with tables natively built in, we have table-based analogs of the higher order functions on lists. So we have a filter row, we have a transform column. Now, could you write a library for that works with the list of structures and provides that kind of table level version of those higher order functions?
Yes, I can.
Right. So maybe that would be a way to do it.
Okay, yeah.
So I think you could adapt a fair bit of it. You said you're working in Racket?
Yes.
Yeah, so Racket already gives you the images, right? I mean, Pirate took this all from Racket. So the main thing Racket doesn't have is the tables, but you could potentially put a library of list of structures, higher order functions on top of it, and have students start with that, and you'd get a decent bit of it. I mean, you'd have to work with the CVS loaders and all that stuff. So I think you could do a decent bit of it, but one of the things Racket does not have is they have some support for testing. It's not quite integrated in quite the same way as it is here. But again, I think that's a surmountable question. I know that the Racket team is also authors on this, so,
Yeah, sorry. So first of all, if you do that, please let us know, because we also use Racket. First Racket and then Python, first functional, then object oriented. So thank you very much. There was a lot of interesting stuff in there. I was wondering if you had any spontaneous thoughts on how to integrate the ideas of this into a CS program that doesn't have the classic like intro to CS course, because for us, people don't come to university to study and then they start trying out computer science, but they come with the idea of doing full-time computer science for 3+ years, because we don't have like general college, we just have studying computer science.
Yep.
So we have like a full semester worth of courses happening all at once, each focused on, like, one is doing programming, one is doing security, one is doing I don't know what, and then second semester in theory they have data structures and algorithms. And I'm wondering how to adapt.
So I mean, I see the course I teach as very much an intro computer science course that acknowledges that data has just become a part of computer science and we just need to orient that in. So you can downplay how much of the data visualization part of it you do and go a little harder and stronger, kind of maybe skip the parts about data visualization and still use this as a topic sequence, maybe spending more time in some of the trees, data types material later on. So I think it actually carries over fairly well if you have a curriculum that's thinking about, that's fundamentally trying to get people to the point of being able to program with these kinds of data types, with a mix of recursion and iteration. I think that actually probably adapts decently well. And then I'm happy to have a Racket convening. I was a Racket-based instructor for many years before I started doing this. So I'm confident we could get a version of this that works there.
That would be really cool. Thank you. So I'm mainly worried because I think these are split over 2 semesters fast, over 2 different courses, the contents
Well, this
I
is
think-
one course.
Yeah, I know.
Yeah.
That's why I think
Oh,
if I
you're saying
talk
these
to my
topics are
faculty, they
Oh,
won't
okay.
be very convinced, but
Okay.
I'll see. So thank you very much.
Okay, I think we have time for one quick question.
Yeah, thank you very much. So my question is twofold. The first part is how much do students actually program? Because if students should be able to program at the end, we need to do it a lot to practice. And the second question is, if data sets getting bigger, also performance is always getting a bigger and bigger constraint. And for that, students need a deep understanding of the data processing stack, also with low-level aspects. So how does this course relate with these aspects? Or is this entirely delegated to a follow-up course? Thank you very much.
Serious discussion of performance does not happen in this course. We do performance to the extent of talking about hash tables and the idea that if you have your data in hash tables, you get constant time lookup instead of searching through tables. I think that's as far as I'm comfortable taking my students in an intro course. I do want them to be able to set up and do a basic data analysis with pandas, which includes sanity checking the data, writing some tests and things like that. So that's the extent to which I try to get them ready to do things. I said, we do have labs on how to use Stack Overflow, how to search for more information. I think there's only so much we can expect students to do with one course if they really are coming from no prior programming. So I make them aware that those issues exist, but I don't try to plow through them in this course. Okay.
All right, thank you again very much.
Thanks very much,
Kathi.
everybody.
I think there are still many more questions. I actually have quite a few of my own. And there were a few
I'm
that.
here for the whole day.
Yeah, okay,
so-
we'll catch you in the break during lunch. And also I think we can continue some of this through Slack. So some of the online participants also had last minute questions. So thank you very much again for a very stimulating talk. So our next speaker on the program is Karen, but I don't see Karen online, and I thought she was here in person.
I am actually online.
Oh, okay.
Good
Okay, very
morning.
nice. Somehow I didn't see your name. I kept looking for you.
Sorry, I've been here. Would you like me to go ahead and share my screen?
Yeah, let me stop sharing from our side, and then you can take over. What's happening here?
Okay. It's been a while since I taught online, so let's bring up this screen and put it into presentation
All right,
mode.
Karen, the floor is yours.
Okay, is it in presentation mode? Can you see it?
Yes.
Okay, so I hadn't planned to attend in person. I was really looking forward to being part of the community and the discussion, but I got COVID, so I'm at home, and I'm thankful that the conference is organized in a hybrid format, so I'll be participating remotely today. So I'm a professor at Miami University in Ohio in computer science and software engineering, and I'll be talking about an experience teaching relational query optimization. So the setting for my course is it's a second course in a database sequence. Neither course is required, so the material can be pretty flexible. The downside of the material being flexible in the first course is that I never really know what students have seen unless they took the course with me, and I can't guarantee that that's going to be the case. So I have to assume that the common background is SQL. That's what everybody has seen. Some students may have seen some file structures and performance material, but some haven't. Some have seen relational algebra and some haven't. So what I have to start with, though, is that they have seen SQL, so I can build on that. Some of the topics are NoSQL databases, and I spend some time discussing MongoDB, graph databases, Neo4j. The students do a project with a multi-model database. We also talk about data warehousing, and we use MySQL and Google's BigQuery for that. And then this year, in the spring of 2022, I decided to teach relational query optimization. So it's a really big topic. And there are entire textbooks, many of them, and you can spend a semester or 2 semesters talking about relational query optimization. So I had to think pretty hard about what kind of scope would be appropriate for an undergraduate class where I can only assume SQL as background. And I wanted to be able to bring everyone up to the same point so that we could launch into more sophisticated topics. So figuring out how to scaffold what they know and bring them into a new topic was a challenge. Assessing learning is also a challenge. And I'd like to be able to use software tools where possible to reinforce learning and use active learning techniques. And I have a little plug for a book that I really enjoyed here that if you are new to active learning or want to polish your active learning game, this book by Robert Talbert is very, very good. Has a lot of computer science examples in it. So here's the big picture for the topic. This is how I think about relational query optimization. And so inside the box for query optimization, there's 2 major modules: logical query optimization, where you're rewriting queries, representing them in an internal form, and then transforming them to more efficient form. And then physical query optimization, where you take into account file structures and index structures, access paths, essentially, and think about the cost of different execution plans. So my students start with SQL background. This is how I onboard them. I have them practice SQL so that everybody's at the same level of proficiency. And then I say, okay, this is what you know, and now we're going to mutate that into a different study. So thinking about the process of instructional design, I'm influenced by the book I'm showing up here in the upper right corner, Blueprint for Learning. And it essentially lays out course planning in a matrix where you establish your learning outcomes, what you would like the students to be able to do, and then you design the activities so that they can learn how to do those things. And also design your assessments, and there should be a pretty tight mapping so that you're preparing the students for how they're going to be assessed. And I'll point out here that if you design learning activities as low stakes practice, that's an inclusive teaching practice, so that you are bringing underrepresented students up to speed in a good way, and also challenging the students who have a lot of background in an area. And then I put a note here under designing assessments that you want them to be appropriate, challenging, fair. But in the era of COVID, we know that flexibility is also important. So I chose to make the course a project-based course because I thought that would be more appropriate for the students who are challenged by illness or other issues. So here's some of the selected learning outcomes. In the paper, it's broken into modules, and there are 6 to 10 learning outcomes associated with each module. Here, I've just picked a few of them. So they're sort of the background objective is that they can write SQL queries. I have them practice with an online tutorial, a free tool called SQL Zoo. So that they can test themselves and they can practice writing queries. And that's just low stakes practice to get up to speed with SQL. Then we start writing relational algebra queries, and I use an online tool. All of these tools are free to use. That's a relational algebra interpreter. And you can upload your own data set with this, or they have a couple of built-in data sets. So students get practice writing relational algebra, and it also displays it in a tree form, which leads us into being able to transform query trees using heuristics. And so that's kind of the first module, is writing relational algebra and talking about transforming trees using relational transformations. Then the physical query part of this, the physical optimization, they have to understand physical layout of databases. So they need to understand file structures and access methods and how much it costs in a given scenario to do those things. So I teach them B+ trees using some animations that are online. And that's really the only index that we cover. I had to scope things back to fit that into the course. So computing the size and access costs for different file and index structures. And then lastly, giving them execution plans that are when you fill in the operators in a query tree with an actual algorithm. So there are different selection algorithms, different join algorithms, and they all have different costs. And those costs in turn depend on the database statistics. So we just use spreadsheets for doing those computations, but I have them set that up. So those are some of the learning outcomes in the course, and some of the activities I designed to support the outcomes. Here are the findings. So I did 2 kinds of examination of what the students achieved. One was I looked at, did they achieve the learning outcomes? And the second one was, how did they feel about what they learned? Did they feel that they mastered the learning outcomes? So on the left are the perceptions. So I gave them the outcomes in a Likert scale, where 5 is a strongly agree that I am confident that I can do certain activities. So here are some of the selected representative outcomes. I am confident I can create an optimized relational algebra tree and relax. I am confident I can perform computations for retrieval costs. So that one is database statistics. And then the third one is, it has to do with execution plans. I can determine the cost of an algorithm, which goes into the execution plan. So on a scale where 5 is strongly agree, they felt very confident on average with logical query optimization, less so with the computing database statistics and the physical query optimization parts. Over on the right of the screen, you can see the my grading essentially for the projects that were associated with each of the phases. So the scores are pretty good. I mean, overall 86% is a pretty strong achievement, but the strongest area was logical query optimization. And then physical query optimization was where they scored the least well. And then computing database statistics is in the middle. So I feel like they achieved some learning goals, but the open-ended comments that they gave me were very valuable to think about how to improve the assignments and the module, the learning experience. So here's my last slide. I was told to just take a few minutes to talk. So my last slide is the lessons learned. And the first one is the lesson I learned as the instructor was that I wanted to do an end-to-end project where they would start with some SQL queries and they would take it all the way through to execution plans. The problem is that if they didn't compute the database statistics correctly in the second phase, then their answers are not going to be correct for the final phase. And you just have to grade based on what they did in the second phase. How did they do in the third phase? So here's my advice. If anybody wants to do something like this, make sure that you decouple the statistics computation from the query cost estimation. You can give them statistics to work with for the final phase. Excuse me. And that makes the grading a little bit easier. Some things that I decided and students also gave me feedback on is that they would like more examples and more practice. And as you know, teaching a course, doing it the second time is easier because the first project can become your second practice. And this is the second time you're teaching it. So more examples and more practice is something that the students would like to have. They also recommended more intermediate checkpoints. I had some small quizzes because, again, I like low stakes practice, but they would like to know how they are doing on the project instead of getting the project graded all at once. So intermediate checkpoints on the projects would be helpful. And then they wanted to see some actual execution plans. They thought that that might help them to understand why they are doing this activity. And so here are some of the execution plans that I showed them later in the semester. When we did data warehousing, I showed them doing queries over a relational database versus doing it over a data warehouse, how the query plans would be different. So I showed them some actual query plans and I had them work that out. And then in the middle is a MongoDB execution plan, and on the right is a Neo4j execution plan. So you can incorporate that throughout the semester. You can also give a preview of it to the students to motivate the study that they're doing. So that's what I have. If you have any questions, we have some time for discussion, I believe.
Thank you, Karen.
How many people are in the room?
How many people? We peaked at 19, but people are coming and going. 19 plus the 3 organizers.
Okay.
I think we're at 15-ish right now. And then another 12 or 13 online, on and off. Okay, questions from the audience or questions from online for Karen's presentation? Yes. Joan, you have your hand raised. Please go ahead and take the floor.
Oh, okay, thanks. I just wanted to say that decoupling message is extremely important. I made the mistake last term of giving my students a database project that involved data integration and then querying the resulting database. And I had the same problem. If they got the integration wrong, the answers were not helpful to me at all in grading them. So I think that's across the board.
Yeah.
It's an
I
important
think it sounds like such a great idea in your mind when you're thinking, oh, they'll get this end-to-end experience and they'll get to see how the queries they started with ended up being cost plans, but then it just diverges because they didn't necessarily get the middle point, right? I guess intermediate checkpoints might also help with that.
Right. And I know a faculty member who would give them phase 1 and they would do it and he would grade it, but then he would give them the software to continue from for phase 2. And here I could have given them the database, but I didn't. Yeah.
It also was hard, at least for my situation, with the trying to maintain flexibility for students, because then I had a variety of deadlines. I had stragglers who were ill and couldn't get the project finished. So then I felt like I couldn't give solutions or talk about it because I still had students who were not up with the class. So that's a problem I haven't quite figured out how to work with. But I guess if you decouple it, then they're not getting the solution to phase 2, but they're getting the shape of the solution for phase 3. So maybe that is the solution, is to decouple everything so that you can have students who have extended deadlines because of their extenuating circumstances.
Good idea. Yeah, thanks.
Yeah, if anybody has any advice on how to deal with the modern disruption because of the pandemic and other issues, I'd love to hear those kinds of suggestions.
Okay, I think in the interest of time, we can, there are other questions. We can move these to the Slack channel. Thank you again, Karen, for the very nice presentation. Thank you. Okay, next up we have Naaz. She's going to talk about the use of prompts and course design. And so Naaz is a little bit worried about her connection, so she sent us a video, but she's here online with us.
Yep.
Is that it there? Yeah. Yep. Yeah. How? The little yellow. All right, perfect. Oh, that's. Which one was it? Hide floating. Perfect.
So, hi, I'm Naaz, an incoming graduate student at the University of Toronto, interested in computing education. Today, I'll be presenting some of the work that I did with Professor Michael Ute last year. I'm super excited to be here and to be presenting this work with all of you. So I'd like to start this talk with a question. You might have been attending talks all week or have attended some today. How many of those talks do you remember? Do you think that having to explain what you saw to someone would increase the likelihood of you remembering the talk or understanding it more? Like, what if I just asked you to explain what you saw in this talk to me after I finish it? So this is what motivated the work that we'll be presenting today. Students have reported an inability to focus when learning online and generally show resistance to working on prep components in flipped classrooms, including doing readings and watching videos. There have also been studies which show that students try to game homework systems when they don't understand the material that they read or saw. So what we tried to do is add a pause after students watched prep videos and ask them to explain the concept that they just saw. Why? Again, we wanted to combat resistance, add structure and focus to their conceptual understanding, and add a level of self-regulation for them to understand any weaknesses in their conceptual understanding before they worked on questions. So in prior work, we've had some research on reflecting about concepts, though we mostly talk about reflection on experience. There's also been a growing body of research on teachable concepts and self-explanations. Now, a lot of this work has been done in engineering and nursing, though mostly experiential in engineering. And the closest work that we saw in the computer science space was done by Chen et al. On security concepts, where they prompted students to reflect on concepts in security and then surveyed students to see what their reactions were. Now, the research questions that we had were, firstly, and most importantly, does requiring students to reflect on concepts have positive effects on their performance immediately. So really, can we prevent gaming and encourage thinking about a concept more after they watch a video? And secondly, in the long term, does reflecting have a positive effect on their performance? And for this, our measure was looking at their grades on subsequent assessments. For our design, we added reflective prompts to a flipped classroom environment in an Introduction to Databases course, which is generally taken by 3rd and 4th year students majoring in computer science. In the prep component of the course, students watched a video that explained a concept like base operators. They were then prompted to reflect on the concept and explain it. And lastly, they answered a few multiple choice questions on the concept. To see the impact of reflection, we divided the class into 2 groups. Group 1 reflected on a certain set of concepts like aggregation, and Group 2 reflected on a different set of concepts like join operations. And then there were topics that neither group reflected on. We had 220 students in total, and we divided it so that we had around 110 students in each group. Both groups watched the same videos, reflected on a concept in each week, the different concepts, and then answered the same questions after reflecting so that everyone had the same amount of work. This was done as the instructor did not want to risk certain students being a lot more advantaged than other students or having a lot more work to do than other students. And they answered the same question so we could assess the impact of reflecting versus not reflecting. For labs, we checked student performance on labs 3 and 4, which they worked on after they reflected on concepts covered by the lab. Labs did not have a control group, but we compared the performance of students who submitted reflections with those who did not submit reflections or were marked as students who did not submit a meaningful reflection. We described this more in the paper, but an example is people who just thrashed the keyboard or submitted song lyrics. Because these weren't really reflections that we were looking for. Now, it should also be noted that Lab 4 covered additional topics that the students did not reflect on. For our first research question, we looked at how students performed on follow-up questions right after they reflected on a topic and checked the number of submissions that they needed to get an answer right. We should mention here that the homework system used gave them feedback immediately, so they knew if their answer was right or wrong as soon as they submitted. They could also submit as many times as they wanted to until they got the answer right before the deadline. Now, for our second research question, which wasn't our primary focus because we didn't have a control group, we checked student grades on subsequent assessments. In this case, the students had labs, which were essentially assignments for the course, and a lot greater in difficulty than the homework questions. So in our results, when we checked the number of submissions that students needed to get an answer right, we noticed that students who reflected on a topic took fewer submissions than students who did not reflect on a topic. It is worth mentioning here that the x-axis is the number of final submissions that we looked at, not the number of students, as we were looking at how many submissions a student took to get the answer right to each follow-up question. To look for significance, we performed the Mann-Whitney U-test, as we did not want to make assumptions about the underlying distributions. Finally, our key takeaways were that people who reflected needed fewer submissions to get the right answer on questions that assessed the topic that they reflected on. And people who reflected and reflected meaningfully by following the instructions we gave them appeared to get a better grade on subsequent assessments that checked the topic that they reflected on. I'd like to go back a few steps. Earlier in the presentation, I talked about how we wanted to combat resistance by adding reflections, but we saw that there were students who either did not reflect or submitted song lyrics or thrashed their keyboard. And there were quite a few students who did that. We had 41 students who submitted Lab 3 but did not submit a meaningful reflection, and 31 who submitted Lab 4 but did not submit a meaningful reflection. So while combating one form of resistance, we did find another form of resistance. Students may not want to engage in reflecting. Now, we do have some threats that we identify. Firstly, fewer submissions does not mean that students got an answer faster, but it does mean that they didn't try to submit many times and game the system. It may indicate that they took some time to understand the topic before submitting. But for all we know, they could have been checking on Google. Secondly, people who reflected and followed instructions could very likely just be high-performing students. So having an effective control group and seeing whether reflection has long-term effects is really still an area that can use future work. What we are currently working on is testing if providing students with different mediums to reflect has an impact on their performance. So we decided to repeat a similar experiment, but test using voice input for reflections and compare that with reflections done using text. We also want to examine student perspectives on reflection in this setting and see whether they report finding these useful. So here's a sneak peek of our analysis this year, where we tried to look at long-term retention using check-in topics after a few weeks, but we did this across condition groups. Again, this also goes on to show how many people don't reflect, despite the fact that we gave them another option to reflect. Finally, we'd like to end with a call to consider adding reflective prompts in an online learning environment to help students pause and understand a topic. There is scope for future work in retention and seeing whether there are specific topics that adding reflection can be more impactful for, because it is a time-consuming task. There is also scope to see when a pause can be added, as prior work suggests that adding a pause too early may not be best for self-regulating, as it is too early to identify weaknesses. We welcome any other ideas or systems to help with this area of study. Thank you.
Thank you very much, Naaz. Okay, are there questions from the audience or the folks online? Oh, yes. And we need to, yeah, center her. Perfect. All right, Karen, do you have a question?
I'm curious how you detect gaming. Can you detect the gaming if you think they're gaming the system? Because I really do think that's an issue, because I know when I have to do online training, I try to get to the quiz as fast as possible and get it over with. But so I'm expecting that students probably do the same, and I don't want them to, but can you detect the gaming and maybe try to prevent it?
So the way our current system works is we record the number of submissions that students make and what they do for each submission. So, what options they're choosing for each submission. So one way to that we use in this analysis is just comparing the number of submissions that they took to see if they were submitting many times to see what the answer is. And we're not completely sure if, the students who submitted many times were actually trying to game the system, but we would think that people who are submitting fewer times are less likely to be gaming the system. But I think one of the ways is to just see the difference between their answers. Like some people are brute forcing, so you can definitely see that they're trying all the options instead of, trying to pause and recognize that something is wrong. Another way is we record the submission time, so seeing whether there's a difference between when they submitted, instead of just pausing and thinking about it. If they're submitting immediately, then they might be trying to game the system and they may need a reminder to pause and think about an idea.
It's a question
Thank
from
you.
the audience.
Hi, it's Kathi Fisler from Brown, since you can't see us. So are you including as a variable in here the kinds of content that you are having students try to reflect on? Because I would imagine there is a difference between content where it's, say, a structural feature that would lend itself to a spatial diagram versus, something that's more of a cost analysis. So is that something that's being planned?
That's a really good question. So we didn't exactly do that for this work. For this work, we just did, did students reflect on this topic, and we mapped the questions that they answered after reflecting on that topic to see how they performed. But we didn't do much of a detailed analysis that was based on the topic. But I think that space is really interesting because I was seeing some work recently, which was done with entity relation diagrams specifically, because they're such abstract concepts. And there was this work that another group did where they made students reflect and create models of entity relation diagrams, and they argued that that's a good space to try to make students reflect and make a model. So I think doing that analysis in future is something we definitely want to do.
You may want to quickly look up the research that's being done on spatial skills and how spatial skills ties into learning. So Cheryl Sorby is a good place to start for some of that.
Thank you so much. I'm just going to note that down.
Okay, well, thank you again, Naaz. I think we will continue the discussion online on Slack. So let's thank the speaker again.
Thank you so much.
Thank you. And now we go to our coffee break, and we'll start again at the top of the hour.
Teaching and innovative teaching methods, education methods, and especially learning games. Almost 10 years ago, I developed SQL Island when I was a PhD student at the University of Kaiserslautern. SQL Island is a game to learn the language SQL. It is played by university and school students all over the world. And 2 years ago, on a conference about entity relationship diagrams on conceptual modeling, I presented my work Monster Park, a learning game to learn how to create ER diagrams. And these games can be played without prior knowledge in these topics. That's the main focus there. For the SQL Insekten game, the name is German. Insekten means insects, so like bees and bugs. The name is chosen because of its phonetic similarity to SQL injections. So you learn what SQL injections are, how hackers work, and yeah, in the end, you should not become a hacker. You should not learn how to hack websites and services. You should learn how to make your applications more secure. Yeah, SQL injections can be applied almost everywhere where user-generated input is sent to a database. So this is a login form. You write an email address and a password in, and then an SQL query is sent to the database, which contains the data. So it contains this string Jane here. So with an adequate input with apostrophe, semicolons, minus for comments and so on, it can be possible to log in without knowing a password, or to log in as a different user or an unknown user, and that's what the game is about. Other levels contain a search box. So what you write in this search box is also eventually sent to the database within this query here. And then you will see in the game that you can inject parts of SQL, like this union query here, to list in the table, which should normally show search results, usernames of the shopping website. And these here are the hashes of passwords. So you can simply use a rainbow table to get the original password here, to decrypt it. There are already games which have the same goal or a similar goal, injection game, hex planning, or the juice shop. These are games where you have the task to hack a website, for example, this juice shop there. But the big problem on these games is they don't teach you how to do it. So you already have to know what SQL injections are and how to hack, and then you can show it or prove it to yourself or try it out that you know it. And SQL injection starts from the very scratch. So no prior knowledge is required except SQL, and you should understand how a programming language works. It also shows code fragments in Python, in PHP, and in Java. So this is good when you understand these concepts before. So it's not for beginners like SQL Island or Monster Park. And this game is not suitable for played in schools usually. It's for university students at the end of the database course, when you learn how to use JDBC or learn how to interact with the database. You should typically know what SQL injections are. But my experience was that people learn, okay, there is something dangerous called SQL injections, but this is too high level, too complex for me. And whenever I ask the question in an exam, people simply write apostrophe minus something. So they have in mind that it is somehow possible to hack, but they distantiate from that topic. So they don't feel themselves okay to do it. And SQL injection changed this a lot. So after having tried out this game, the question about SQL injections in the exam was correctly answered by nearly everybody afterwards. And another focus of SQL injection is that it contains of game elements. So it is a learning game and not an application or a toolbox or a sandbox. It contains of levels, it has a story. This B tells the story. You finally want to reach a goal or different goals. You have points, and you can use one of your 3 light bulbs to buy hints and so on. So elements which makes games fun and makes people motivate and keeps them motivated are all in the game. So let's switch to the game now to show it to you. It can be played in English and or German. By default, it opens in English, but for me, it would open in German because my browser language is German. So I had to set this in the settings to change the language. This is an introduction where you can see what you need to do.
Oh, sorry, Johannes, we cannot see your screen. Maybe should you share the other screen that you are working on? Because now we can only see the last slide. Yes, now here it is.
Oh, yes, sorry. Okay, I didn't start yet. So this is the game. I just skipped the introduction. This was simply this welcome, blah blah blah, and every level consists of a task. So here, try to log in and try to guess the password. And of course, this does not work, but you know how the login form works. And you can also see the query that is sent to the database. So you see here that the hash differs when we type into the password field, that this part is part of the query of username equals and so on. You can also take a look at the program code, but basically the game is playable without looking at the background details, looking at the code and the query, but it makes it easier. And yeah, so if you don't know what to do, this helps a lot. So now try to log in as Jane without knowing the password. And the idea is, yeah, we see here the query and we need to comment out this and password equals something. And this should work. So SQL injection level 1 or level 2 is completed. And actually, this is where most of other learning games about SQL injections stop. Because now we understood the concept, but 10 more levels follow here. So levels about getting the data from tables and querying system tables to inspect the database metadata, because people always say, yeah, I can write drop table students, but how do I know that the table is called students? And this is also part of the game to inspect metadata and query metadata tables. Other game elements, I think I showed almost everything. One thing I missed was this hint. So the hints are very, yeah, they are actually almost complete solutions. That's why a hint costs 1 light bulb. So with a hint, it should be possible to solve the exercise for everybody. Yeah, that's it. And now it's time for your questions.
Yes. Oh, thank you, Johannes. So yeah, questions. Yes. Do you mind if I turn this around so that also Johannes can see who is asking? Yeah.
Hi, thanks for your talk. Patrick Hansert from TU Kaiserslautern. You may remember me, I was a student of yours.
Yes,
I guess my question is, how would you integrate that into a normal university course? Or is that something you wouldn't do, or you would rather do that for like special events outside regular courses?
Yeah, good question. Of course, it's integrated in the course. So for SQL Island and for Monster Park, in the end, people get a certificate with a unique certificate ID. And then in an online course where people usually submit their solutions, they can submit the certificate ID to get points for the exercise. Here for SQL Injection, there is not yet something like a certificate, but I add this game to an exercise sheet. So exercise 1, play the game SQL Injection, and then I ask 1 or 2 questions about the end of the game to prove that it was played. But of course, these questions can also be, you can also ask a colleague what the answer is, but it is integrated, of course.
Thanks. Any other questions? Oh, yes, coming. Oh, yes. Yeah, thanks.
Hi, Kathi Fisler from Brown. It looks
Hi.
to me that this is something that makes sense for someone to play through once, but not that it's something that's built in for people to play repeatedly. Is that right? Or were there aspects of this that you didn't get to show us?
Exactly. You play it once and that's it. So then it's finished. So, and you cannot save it in the middle and continue, and you cannot start in the middle. It's there for, okay, now I play the game SQL Injecten, and 1 hour later, then you know it. Then you know the concept.
So as someone who's just from your experience having tried to teach this material, are there things that you do need people to go back and revisit before they really get it? Or do you think this kind of one-time through tutorial is sufficient for what you're trying to get them to do?
In my opinion, this works best when you simply write, play the game, SQL Injecten, period. And then the people play it at home. I saw that other teachers show the game like I did now on the presenter, and then ask questions. So what should we write into this field here and so on? But I don't like this, because then 2 or 3 students are very active and they are thinking and they are looking onto the query and saying, yeah, we need to write an apostrophe, and 90% of the other students are simply sleeping and still think, oh, this is too complex for me. So for me, it works best to simply say, do it at home, alone, it works.
Yeah, thank you. Thank you, Johannes. And I think let's thank our speaker one more time.
Thank you.
Well, let me see. Our next speaker is Marco Zappatore. He will be talking to us about using Datathons in data education. So Marco, can you try? Yeah, let's see if we can hear you, see your screen.
Nice to meet you.
Oh, hello.
Thank you. I hope that can you hear me?
Yes.
Okay, so I'm going to share my screen.
Yes.
Just let me know when you can see the screen so I can start.
Yes, we can see the screen. It's not in present mode.
Now it should be in
yes, now
presentation mode. Okay.
Yes.
Okay, so thank you again. I'm from University of Salento, which is in the very southern part of Italy, and I'm going to jump right into the contents of this presentation. I will have a very quick introduction, and I will also mention the aims. Let me switch my camera off so my connection bandwidth should improve. Okay. Then I will introduce very shortly what Datathons are and how they can be leveraged in the educational perspective. And then I will describe our case study in terms of participants, reference contents, and the dataset we have actually used. And I will also provide you with some insights about the enrollment strategies we have adopted and the evaluation outcomes we achieved. And also there will be room for discussion. So okay, so what Datathons are? They are a recent variant of coding peer competition, and they are based on previously agreed data analysis or management set of tasks. They should last for a predefined time window, and they should address a real-world data-driven problem by requiring the participants to present the outcomes to a specific audience. We decided to propose the design and implementation of a datathon involving students from 3 different data-oriented Master of Science degree courses at our university. And in the paper this presentation refers to, we also proposed a guideline to design and deploy these events in other universities. The term Datathon popped up, I would say, in 2000 in order to identify the collaborative coding event where programmers develop software prototypes. And it was originated just 1 year before, when the first official coding event was held in Canada. And there were just 10 members, 10 volunteering participants that joined a 1 week long meeting in order to perform collaborative software development on the OpenBSD operating system. But actually we have at least 3 different typologies of competitions, which are not synonyms. We have the, I would say, the most widely known hackathon, which is not primarily software driven because it focuses on other skills. Then we have the coding hackathons, which actually focused on competitive development of software prototypes. And then we have the data hackathons, or the so-called, for shortening their names, Datathons, which are data-driven coding hackathons, and which are aimed at examining data sets, apply data science approaches, and so on. There should be, according to the current literature on this topic, several benefits by bringing Datathons into a data education curricula. First of all, enriching and updating traditional curricula by allowing students to practice on real data engineering challenges, I would say referring to all different STEM disciplines, fostering students' data-oriented skills and activating also soft skills. Datathons are more and more enabled by a series of elements, such as the ever-growing number of open datasets that are available, and that can be used as potential case studies, and also the availability of several free platforms to perform data science and data engineering activities, and the majority of them are normally based on Python. But there are also several challenges, such as, for instance, the presence of a significant diversity and variety in format and scope of open data, scarcity of metadata, heterogeneity of metadata, and so on. So what our motivations were essentially based on 2 documents. The first one is the Italian National Recovery and Resilience Plan, which is aimed at fostering improvements in the ecological transition. And the second one was the 2030 Agenda for Sustainable Development by the United Nations. And we designed this data hackathon, which was named Data for Ecological Transition, using open data to access European renewable energy context, that lasted 5 weeks. And this is the brochure, an excerpt from the brochure we distributed for the final event. This event was configured as an elective extension of 3 Master of Sciences courses, all related to data education. Students enrolled voluntarily, and they were rewarded by supplying them with a score bonus in their respective courses, depending, of course, on their achievements during the hackathon. But we decided to use a non-zero baseline score so that we can incentivize their participation. We adopted a hybrid designing methodology based on 2 different papers, one from Trainer and one from Rethinking. We had 7 phases. The first 5 ones are collaborative, and the last 2 ones are much more oriented to the competition. So the first one is launching, when the Datathon is described, and we devoted to this phase 2 separate presentation during 1 hour. Then we have forming and storming, when teams are created, possibly named, and the different roles of the participants are defined. Then we have norming, for providing the participants with the data sets, the tasks and the workflow and the definition of their workflow. And all these events and phases were performed in online meetings. And actually the project activities are performed during the performing phase, and they lasted for 5 weeks, and they were performed remotely. Scaffolding work was provided during 2 one-hour online events, one in the first, one in the third week, by selected teachers who provide mentoring. And the last 2 steps were staging and selecting. During the staging, the project pitching to the evaluation committee was performed 1 week before the final event, and during selecting, the teamwork presentation was performed, and followed by the voting and the awarding. This is the breakdown of participants and teams. We had the majority of the participants coming from computer engineering. Then we had 4 students coming from management engineering and 2 students coming from business management. All the corresponding courses were related to data education. At start, we had these balances: a gender balance skewed by male participants, a provenance balance biased toward students coming from Italy, and more than the 62% of participants came from computer engineering. At conclusion, we had this situation. We experienced a 100% dropout of one of the 4 teams, which was made up of foreign students only from data management, which experienced several visa issues because they were hosted here in Italy, and they had to go back to their countries. So they decided to drop their participation. And so that's why the provenance balance at the conclusion of this experience was so biased towards the Italian participants. As for the dataset, we used an open dataset, of course, which was retrieved from the Open Power System data, whose size was nearly 750 megabytes. It was actually an SQLite dump containing 22 files, providing a list of renewable energy plants of a subset of European countries, and along with the yearly power production per plant in almost all countries, daily time series of accumulated installed capacity per energy source, but it was provided without any data dictionary or metadata dictionary, and the data quality had to be assessed by students. We assigned 2 blocks of tasks. The first one was data analysis, and the second one was data wrangling. In the first one, the participants had to analyze the dataset. So dataset retrieval, preliminary examination, exploratory data analysis, and they had to implement a minimum set of queries. During the second task, there was the role-playing component. Each team personifies the staff of the European Community's Chief Energy Officer, who must support the European Renewable Energy Commission to define the next strategic plan by leveraging evidences from the dataset. So they had to develop a goal stakeholder model of a suitable set of use case diagrams. They had to model conceptually in order to trigger a multidimensional analysis, and they had to refer to the dimensional fact modeling approach, which was explained to them during their curricular activities in all of those 3 courses that I was mentioning some moments ago. And finally, they had to create a data visualization dashboard to report on the identified measures defined according to the DFM approach. We established a 7-member evaluation committee, 1 professor from each of the involved courses, 1 external expert on open data and coding, 1 lawmaker, which was from the address domain by the dataset, and 2 graduated students from the same university who had won 2 international Datathons in the previous year. We defined a five category set of 32 criteria, ranked according to a 10-point Likert scale by each committee member. These criteria range from data analysis to methodology to data quality analysis, data visualization, and of course, the quality of their presentation. And this was the actually the guideline that was provided to all the members of the evaluation committee, so that they were already able to go through all these criteria before evaluating the participants. And these are some excerpts from the reports that the students produced. The majority of them worked in Python, so they produced their achievements via Jupyter notebooks. So we can see here a goal stakeholder diagram from one team, the time series from team 3, a correlate map from, again, team 3, and a very small DFM from team 1, just in order to fit this remaining space. And this was the final ranking matrix, where we have reported the maximum achievable score for each one of the available evaluation criteria, and the actual score reached by the 3 different teams. And so we can see that actually all the 3 teams performed quite similarly as for their overall score, but there were several significant differences if we look at the evaluation breakdown depending on the criteria. So for the conceptual modeling, the second team was clearly underperforming. And as for data analysis, all the teams performed correctly, but they followed different approaches because they were not required to apply one single approach. It was left to their initiative. So
Marco, in the interest of time, can you start rounding up the presentation?
Yes, yes. This is we have just 2 slides remaining. The 5-week format is valid, by, I would say that 1 additional week is advisable. Final presentation was largely appreciated, and interacting with peers from other courses was significantly valued by students. So we are now in the framework of defining a new datathon, which will be organized in the next semester from October to February of the next year. And we are evaluating 2 different approaches: international teams or competition among different national teams. So anyone who is interested in joining this activity and participating to our next hackathon can contact me on Slack or by email. And that's all. Thank you for your attention.
Thank you. Okay, maybe we have time for one quick question. And
okay,
for Marco. No. Okay, so for me, I was very interested to see about the setup of the groups. You said about selection of the groups. Did you select the groups or did you let them self-organize?
You mean when they decided to participate, or?
Yes, so the teams that were in the hackathons, how did they team up?
When? Yes, they were allowed to self-organize. And indeed, this was one of the very interesting points. When they decided the different roles that they had to perform, we spot some specific behaviors. For instance, Italian students was scared by the presentation because the presentation was required to be held in English, and so they tried to assign the presenting role to the foreign students. And for instance, computer engineering students decided to go much more on modeling and writing SQL queries, while business management and management engineering students decided to use Python because they were much more skilled in Python rather than writing directly SQL queries. But actually the team organization was self-made.
No, thank you. Okay, further questions on Slack, and thank you very much again.
Okay.
I think we can proceed to the next presentation, which is by Daniele Traversaro, and he will be talking to us about applying collaborative learning techniques in a database course. So let's see, Daniele, can you try if the setup works?
Yes, I try to.
Yes, Marco, can you stop sharing your screen?
Thank you.
I'm not sharing anymore.
Oh, yes, now you're not. Yes, good.
Okay. Okay, can you see my slides?
Yes, we can see everything. You can start.
Okay, thank you very much. So, hi everyone. Let me introduce myself. My name is Daniele Traversaro. I am a PhD student in computer science at the University of Genova, Northwest Italy. My research interests are didactics in computer science and innovative teaching applied to computer science. With Professor Barbara Catania and Giovanna Guerrini, we experimented with collaborative learning in our Introduction to Database course. So our course, and more generally, introductory database courses, are characterized by quite broad learning outcomes. They range from data modeling skills, mainly related to domain understanding and abstraction capabilities, to query specification skills, both in SQL and relational algebra. Traditional course design usually consists of frontal lessons for the theory part, lab activities for practice with the DBMS, in our case PostgreSQL, and often project-based learning, which is the most commonly used active learning approach in database education. But we have noticed in our course that this didactic organization does not always ensure satisfactory achievement of all the different target learning outcomes. Furthermore, we found a gap in the literature on the use of collaborative learning specifically for data modeling and query specification skills. So our research question is whether if collaborative learning is effective in terms of learning outcomes for the different skills to be acquired in introductory database course. So we have applied this approach. We have experimented with two collaborative learning strategies, namely Think Per Share, TPS, and Team Peer Review. In TPS, students begin to think individually about the solution of a given task. Then they pair up and discuss with a classmate or in small groups. And finally, they share their ideas with the entire class in plenary. Whereas team peer review is a peer review with collaborative dimension, where teams send and receive peer review from other teams. We have applied this kind of approach throughout the course. We aim at extending the benefit of the Think Per Share approach to diverse learning goals for both application exercises and hands-on laboratory activities. In this slide, you can see two different short TPS and weekly TPS. This means that short TPS is the TPS activities is self-contained within a single lesson, more or less 2 hours. While weekly TPS means that the entire TPS session has a time frame of 1 week. In particular, 2 days for the first phase, 3 days for the pair phase, and the last day for the discussion. And team peer review, again, as a time frame of 1 week. In particular, here is a general overview of our intervention. So more details about these activities. We designed 6 TPS weekly activities, so 6 laboratory sections, 6 weeks, each one dedicated to several topics, from data definition language to query language. We designed 2 short TPS activities. Each activity was about a particular case study, and each short TPS activity was composed of 5 topics or 5 subtasks in this case, each one designed in a TPS fashion. So each subtask more or less took about 30 minutes. And finally, the team peer review, that it was applied to the final team project, and it was about the ER conceptual model review. In this case, the evaluation grid was provided in advance by the instructor. In addition, sorry, we performed also 2 peer evaluation sessions, one intermediate and one at the end of the course, with only formative value in order to understand the behavior of the student teams. So let me introduce some details about the experimental setting and our population. The study sample consisted of students enrolled in our course and who passed the exam. Students were enrolled at the Bachelor Science of Computer Science or in Statistics. In total, we have 72 computer science students and 23 statistics students. It was a non-randomized control trial, which meant that students were free to decide whether to participate or not in the activities. In particular, 50 students of our study sample decided to participate in collaborative activities, and they were the experimental group, while 45 students decided to not participate in the collaborative activities, and they were the control group. The approach was, all the course was held online in distance learning due to COVID-19 pandemic in the 2020-21 academic year. So during the activities, we collected several data about student engagement, such as attendance list, submissions, and so on. At the end of the course, we collected student feedback in form of anonymous questionnaire of the course. And during the exams, we collected the assessments. In particular, to pass the exam, students have to pass the written test, that it was composed by 2 main parts. Each part was composed of 2 parts, so in total 4 parts about data modeling and query specification, plus the final project. Our main hypothesis is that our approach could lead to a sort of homogeneity in the partial assessments of the written test. So in this slide, you can see the results of the unpaired 2-sample t-test that we performed between the 2 groups to check whether the deviations between exam results in the 2 student groups were significantly different. And the results of the test shows that students who participate in collaborative activities is significantly less, the average variance of the students is significantly less than that of the other group. So the partial evaluations on the different artifacts are significantly more homogeneous, and this seems to lead to a sort of more balanced learning effort among all the different topic learning outcome. We noticed that this approach is usefulness in team peer review, in mitigating the impact of missing reviews, increasing the general quality of feedback of our undergraduate students. Finally, the techniques also demonstrate quite engaging and appreciated by the students, with team discussion as the most useful source of learning. And providing a review is deemed more effective than receiving it. But we are also aware of some limitation of our work. First of all, the non-random assignment of participants to the control and experimental group, and this could lead to a sort of bias in our results. Then the team formation design, both criteria and algorithm, and our results that are not easily generalizable to a face-to-face edition of the course, such as the current edition of the course. So let me sum up some conclusions. Differential techniques are being applied to database education in introductory database course. Collaborative learning seems to be effective in terms of learning goals for the data modeling and querying skills, measure in terms of exam results, and the techniques also demonstrated quite engaging and appreciated by the students. Thank you. Thank you.
Well, thank you too. So yeah, time for questions. Oh, yes, sorry.
Hi, Kathi Fisler from Brown. There's another technique called peer instruction, which sometimes gets talked about in the computing education literature. And the difference between peer instruction and think, pair, share, partly there's something like a clicker or something that gathers the students' views on a question before they start working in pairs, and then has them re-answer the question again afterwards. So it's a more granular way of measuring the impact of the discussion on how students are understanding a question. Was that a kind of design you considered in this? Would that make sense in your setting? There's just a lot of research on that in computing education.
Okay, if I understand well the question, we at the end of the course we give to students an anonymous questionnaire where there are several questions about the quality of the course, but also some particular question about the collaborative intervention. And there are several questions about, for instance, how is important for them the tutor support during the activity or the team the discussion within the team and other aspects. So we analyzed this questionnaire at the end of the course.
The peer instruction gets kind of used in the moment when you're giving the questions during the lecture activities. So I think it's a different model where you're not just measuring at the end of the course, but you're measuring impact on a per activity level.
Yes. During the activities, we collected this, for instance, the attendance list, the submissions, and through instructors and tutors, we try to analyze the team dynamics in Microsoft Teams, in the breakout rooms. Teams usually worked in breakout rooms. And yes.
Yeah, okay, it was just a different model. I was curious whether it was something you had thought about, but thanks.
Thank you.
Okay, yeah, thank you, Daniele. I think we have to move on to the next presentation. So further questions on the Slack. And so thanks again.
Thank you. Thank you.
And now our last presentation is by Abdussalam Alawini, and he will be talking about another cool tool, TriQL. So let's see, can you try? Yes, I think we can see already the slides, but we cannot hear or see you yet.
Yes, you can.
Yes,
you should hear me. Not sure if you can see me.
Perfect. Yes, you can begin.
Fantastic. I'm glad to be here, kind of fielding on the question that was asked earlier about peer instruction. This is not related to my talk, but I've seen quite an impact on peer instruction because we use in-class group activities. We've built systems in which students can work in class on, say, a number of database-related in-class group activities. And I can't tell you how much impactful it is when you see a student is actually open up their lecture notes and teach another students the concept so that they can both work on the question together. So there's a lot of impact, there's a lot of work. We're still working on trying to publish results related to how collaborative learning have transferred the way we teach databases. But this is not about that. I'm so excited to talk today about teaching data models with TriQL. This work has been done before that. I should stop and introduce myself. This is Alawini. I'm a teaching assistant professor at the University of Illinois, Urbana-Champaign. Before that, I was actually in the University of Illinois. Come on now, I can't forget University of Pennsylvania. My brain is not functioning. I was a postdoc at University of Pennsylvania. I miss UPenn a lot. Unfortunately, right now I'm in Tripoli, Libya, North Africa, so I'm traveling. Otherwise, I would be enjoying SIGMOD in person. I wanted to say something. When I taught databases back, even when I was a PhD student, a lot of courses that introduces databases. So I've taught databases in Portland State with David Meyer. I've taught a database course with Susan Davidson and using like Zach Ives material and Sue Davidson material. And I am teaching databases right now at the University of Illinois, right? And I've noticed that even though some introductory courses try to introduce students to different models, but the majority of intro database courses still focus on the relational model, of course, for a very convincing reason. I mean, still the relational model kind of conveys a lot of the concepts that we would like to address when we talk about databases. But the motive here, the motive of my work is to actually expose students not just to a particular implementation of a database model. I want them to be aware that databases are basically built on top of data models. And we're all aware that a data model consists of three things, right? You got the structure of the data, you got operations on the data, and you got constraints on the data. So once the students understand that a relational model, for instance, has a relation as a data model, has, select, project, a join as operations, we have like a foreign keys and primary key as a constraint, then I want them to kind of project that to other data models. So some other database courses, including the one at UPenn and the U of I, started to introduce other data models into the introductory database course. So these classes teaches MongoDB as an example of a document-oriented database. And we also teach Neo4j as an example of a graph-oriented, graph-based database, as an example of two other data models. Okay, so even with that, I noticed that my students still struggle to understand the trade-offs between the two different data models. Back in the days when I taught, databases, I was asking students to actually, force students in a way, to use two different data models, the relational database, and then augment that with a non-relational database, NoSQL database, either MongoDB or Neo4j. And I've noticed that even though we give them some hints to what types of data fits which data model, they're still not understanding very well the trade-offs between the data models and which data would fit better. So I thought that I need to figure out a way to better teach them the differences in the two main things, like the query language, which kind of emphasizes operations on the data model, and also the structure, the schema of different data models. So with that, this idea of building this tool called TriQL, it's basically a tool that helps novices learn the structure, it's a schema of a database, and also the query language of three major database systems. In future, we're hoping to basically even incorporate more database systems. So the idea is you have this user interface that you can see here on which students select a database from a set of pre-populated databases at this point, in which they're simply using a GUI to select which tables and which attribute they would like to project and which type of selection they would like to apply. And then they hit generate. I'm actually going to walk you through a quick demo very soon. And then they can see the result of their query in data log, which is something we don't teach in introductory database, but I just want them to know that this is a very strong modeling language in which I can use data log to convert a particular query into SQL, Mongo, and Neo4j. And let me actually go ahead and quickly demo how this tool works, just to give you an idea. So as you can see here, I have a set of pre-populated databases, and then a user can select which table they would like to query. So for instance, here I'm querying this Pokemon table where I'm selecting the Pokemon name and type and level. As you can see here, I have these attribute fields populated here. So I would say, I'd like to select basically the Pokemon name and type. And I don't want to project this, but I'm going to use it for selection. So I'd like to have Pokemons with level that is greater than 1. And when I hit generate, nothing happens because the server is not running. So I have to try. No, actually something happened. My internet was slow. So I need to be a bit patient. Again, name, level, and then I'm going to show these two. And I'm going to say I would like to select level in which the level is greater than 1, hit generate and wait for a sec. As you can see here, we got the query populated first in data log. And then as you can see here, the user now can see the query in 3 different query languages, SQL, MongoDB, and Neo4j. And more than that, the user can actually see the data coming from the native database. So here I can see the query output, and I can also have the users, the students, actually see the structure of the table. I hope that this view is visible from your side. The colors, I'm not sure if it's a best choice ever, but this is actually an output of a describe command that describes each table in the database so that the student can understand the structure of the data as well as the query. We can also see things in the native MongoDB format. So this is basically the output coming from MongoDB. And also we could do the same and see the query here in Neo4j and see the output. I'm actually aware of a fact that my JCP account ran out of credit, so I can't unfortunately visualize the graph, but this is actually a cool part in which the students can visualize the graph and interact with it coming off from Neo4j. All right, so as you can see, you don't need to know any particular query language. You just need to know how to interact with the user interface. And with that, you will be able to try quite few queries and understand how the systems work. You need to take a look at the time to make sure that I'm not eating up your lunchtime. All right, so as I mentioned, we have a query builder interface in which we basically, the user submits the query, we take that query and we basically generate the equivalent data log query. We have something that we've developed that I've described in the paper called the generalized schema, and the generalized schema is a JSON schema format that tries to encapsulate all the properties and information of the 3 database languages that we have, SQL, Mongo, and Neo4j. And then from the generalized schema, we produce the database, we auto-populate the database, and then run the generated query in each of these databases and show the results of the query, to the student. Okay? So this is an example of what the Neo4j, for instance, part would look like. So what I'm doing this semester, I'm actually teaching CS411 over the summer, and I'm gonna actually try this over. So we're gonna use the tool after we fix few of the issues that you just observed, and try to use it in 2 different labs. In the first lab, we're gonna just have the students explore the different schemas, different query languages, giving them some open-ended questions and have them see the differences. For instance, I can give them an example of a query in which the data is highly connected and then see how basically concise the Neo4j query would be compared to a relational one, which would require a lot of joins. I'm also we'll deploy a second lab in which emphasize the trade-offs between these 3 models. So the students will use TriQL to basically view, generalize the schema and the database design in form of a UML of each database, and also the native structure so that they understand basically the trade-offs, the variations, and how these databases differ in a hope that this would help them better understand the differences. Right now, we're big fans of PraileLAN. We've been using a lot of tools and implementing a lot of infrastructure under PraileLAN, which is an online assessment tool developed here at U of I. So we try to integrate it because everything I have in my class in PraileLAN, so we would like to be able to use it as part of the course ecosystem. We would like to also enable the DB import functionality. We've been able to deploy, at least if you have a SQL file with a SQL database, we can import that, but that still needs to be tested. I'd also like to go beyond the native or novice users, right? I want the users to be able to type in their query in SQL and maybe see if we can translate that into Mongo and Neo and hopefully other database languages. Most importantly, and this is why I'm going to actually use these 2 labs this semester, that I have not evaluated the learning effectiveness of a TriQL. So I'm hoping that this would be very helpful to students because it showcased 3 different database models in the same place, but I yet have to basically run some experiments and collect data to be able to evaluate that. All right, so I'm gonna leave a couple of minutes, guys, for you to ask any questions. So excited to be here. And before I go, I'd like to point people to Illinois Teaching workshop. We are accepting abstracts. This is gonna happen this August. Sorry for the organizing, come jump in. I've also posted some information about that workshop on the Slack and happy to answer any questions before lunch.
Thank you very much. So yes, time for questions. Yes, okay. Okay, I'm going first. Oh, okay. Here.
So a big part of the trade-off in a lot of real scenarios is the performance. Do you have any part to show like how they perform differently, like, you know, time for running 100 queries, something like that?
That's a wonderful idea. As we teach database internals, we only focus on relational database. We don't have enough time to go over, say, Neo4j or MongoDB, but it actually would be great to even try to see if you can run something like describe or describe analyze, query and see if there's an equivalent query that you can run on Neo4j. I'm not aware of that, but we'll see, or even do what you just mentioned, try to compute some basically data profiling to be able to say, look at the difference in time in performance. And I think that would be wonderful component to add to this tool, because now you're not only observing the differences in the structure and the query, you're also observing differences in performance, which is very important when students are making choices and trying to understand the differences among these data models.
Let me see another question.
Hi, Kathi Fisler from Brown. This is less a question and more a comment that I wish you were here in person, because I see a lot of the things that you are potentially asking as being similar to things that we've asked, looking at how students formulate questions differently in different programming languages and how they understand cost models. So if this is something you're interested in talking about and sharing research designs on, be happy to continue this over email, because I think there are potentially some nice synergies between the questions that would be asked in both settings.
I would be honored. I've enjoyed your talk, and I guess I've learned a lot today from what you had to say. It's like you've read my mind. You're already out there, and I would definitely be happy to exchange idea and potentially collaborate. I'd be honored.
Okay, let's thank our speaker once again.
Thank you so much.
And I think it is time for our lunch break. We have a lunch break of 1.5 hours, and then we will come back with many nice energizing activities for after lunch. I just wanted to say, for the people I'm here, I just realized that I did not wear my mask. I forgot to wear it again, but I have been tested this morning and I'm negative. So sorry for that. I will wear it now and be more careful. So see you in 1.5 hours, yes?
Okay, all good. Right, so as I was saying, I'm affiliated with 2 units at NYU primarily. One of them is a computer science department, computer science and engineering, we call it, because at NYU we have 2 computer science departments, actually, each with its own set of programs. And my second affiliation is with the Center for Data Science. And this is a center at NYU that has an undergraduate degree in data science, a master's, and a PhD. And it's actually, I believe, the first or among the first PhD programs in data science that has been established. And also, as you can see here, I direct the Center for Responsible AI. This is a small unit that is focused specifically on ethics and responsibility and on embedding essentially societal impacts of technology into the way that we do research and teach, And also it has a portfolio of public engagement activities that I will discuss briefly at the end of my talk. Right, and this research is, and work and teaching is generously supported by the National Science Foundation. So I will be using, just as a warning, AI and data science interchangeably here. I fought with myself, I had this conversation with myself for a long time, denying that AI is the term that we should be using. But unfortunately, the world has converged on calling everything AI, including data management. So if you can beat them, join them. So we'll be doing responsible AI and responsible data science as essentially, synonymous at the moment. So I don't have to convince you that AI is all the rage. We see lots of opportunities in its use, convenience and science and commercial. And we even hope that AI will help us figure out how to run our societies better. For example, how to govern better, right? So there's really lots of promise in this technology and a lot of magical thinking also that is associated with AI, because what's not to like? Artificial and intelligence, right? So unfortunately, of course, but not unexpectedly, machines make mistakes. And here I'm showing one, innocuous sort of a mistake where an AI at your favorite online shoe store misunderstands your order and the wrong pair of shoes gets shipped to you. And this is annoying, but the consequences of such a mistake are not severe and reversible. You return the shoes, you get your money back. And then at the other extreme here, you have mistakes that can lead to catastrophic, irreversible harms, even to the loss of human life. So here I'm showing the quintessential example, and that is an autonomous car that miscalculates the trajectory of a pedestrian who is crossing an intersection in a wheelchair going backwards, as wheelchair-bound individuals often do, as I'm told. And then it would just miscalculate and it would proceed through the intersection and potentially run the person over. So between these kinds of mistakes that are, really not very important and can be reversed, and those that are catastrophic, there are also lots of mistakes that an AI system can make that have cumulative consequences and cumulative harms. Each one of these may be not very, very important or very tragic, but when you take all of these together, you're going to end up with situations where societies get destabilized and our equity goals remain as elusive as ever before. So as an example of such a system, I'm showing you here, and this is my favorite domain these days, algorithmic hiring systems. They are depicted as a funnel here, following a very nice metaphor by Bogan and Enrique, where they say there's a funnel, we all apply for jobs at some point in our life, and then we enter this funnel when ads are shown to us for jobs, and then we know to which jobs to apply. And if an ad is not shown to us, we won't know to apply. And if you see that ads for specific jobs are shown disproportionately to, say, men versus women, then you can see how this would lead to exclusion. And then all the way through the tunnels, through screening, through interviewing, through determining how much money somebody should make if they were to be made an offer, AI tools are used very, very broadly, right? And here I'm showing an example of an AI system that is interviewing job applicants. And so the students who graduate from our programs, computer science programs and data science and data engineering programs, will go into the industry largely, and they will work on developing and deploying and overseeing and testing tools such as, these algorithmic hiring devices, but also perhaps autonomous vehicles, right? And so the reason that I became very interested in developing and teaching curricula on responsible data science is because I understood that we talk a lot about the need to teach technical students these concepts, but that there is an utter lack of teaching materials and methodologies that would allow us to make this material engaging and relatable to them. And so as a computer scientist myself, I remember taking my philosophy class. I never took an ethics class in college. And essentially you read, and if you're an avid reader like me, you enjoy the course, but it has absolutely no relevance to what you do. And most technical students are going to resist reading. They will come in, fall asleep, and wake up at the end of the semester, basically, in these courses, right? So that's kind of on the one hand. On the other hand, yes, they are very well versed in technical materials and methodologies, and they really are eager to develop software. So my point really here is to try and define an education agenda in responsible data science that would navigate essentially between these various extremes, right? So one of these is, do we offer this material through teaching and reflection and discussions and debates, or do we also enable technical students to then take these concepts and start coding with them, right? So we need to find a balance between research and practice, reading and implementation. And then also a particular kind of balance that we seek, and I will speak about this some more, is specifically when we talk about responsible AI, it's a balance between these two harmful extremes that are depicted here. On the left, you see techno-optimism, and on the right is techno-bashing, which is an extreme kind of techno-criticism. So techno-optimism says, give me a problem, I will give you a technical solution to that problem. You have bias in hiring, no issues at all. I'll debias your data set, all done. History of historical discrimination in hiring, fixed and erased, right? So we don't want to be in that corner of the world, but we also don't want to be in this corner that came in some sense as a reaction to techno-solutionism, and that says any attempt to embed ethics, to embed legal compliance into technical systems is going to be reduced by technologists to things like model debiasing, data debiasing, and so this is harmful. And therefore, any attempt to outfit technology with our values and beliefs essentially is bound to fail. There's this term that folks have come up with here that's called fair washing. It's an analogy to whitewashing, right? So we need to be somewhere in the middle, right here, around the nose of this person depicted here. So what is that balance that we seek, and how do I try to achieve that through my course? And in my presentation today, I will tell you specifically about these courses that I have been developing and teaching at NYU, New York University, for 4 years now. I just finished the 4th installment of this course. And here I just recalled how many students enrolled in each one of these. So I offer these courses every spring. I started in 2019. It was a special topics course the first 2 years. And then the last 2 years, this is a permanent course that is now offered both to undergraduate and graduate data science students, majors and minors at NYU. Computer science students also take this course. It's an elective for them. So any computer science or information technology student, even at NYU, can enroll, provided that there are seats. And I started out with a graduate version only as special topics. And like I said, in the last 2 years, it's undergrad as well. So we have 2 courses that we run. And the undergraduate course, called Responsible Data Science, is a requirement for our undergraduate data science majors and minors. I had 20 students in 2019, then 50, then 120. And this year we had 215 across the undergraduate and the graduate listing. So you see that the number almost doubles, or more than doubles. And in fact, it's capped by the availability of seats. Our waiting lists are as long, essentially, as there are seats in the courses. So there is tremendous interest in this material. And the level of conversation, the level of understanding and awareness of the issues that I discuss in the course has changed notably from the time that I was offering it in 2019 until today. Students come in really primed and eager to learn about these topics. All course materials, and I will give you some highlights today, are available publicly online at this website. Please take a look, please reuse. There are lots of people already teaching courses using these materials. Instructor materials, you can reach out to me and I can send you homework assignments and solutions, and also instructors' versions of labs, etc. And then there's another course that is listed here that I hope to have time to tell you about maybe in 3 or 4 minutes at the end, called We Are AI. This is a public education course that I have developed together with colleagues and that we have been offering to people finally in person at the Queen's Public Library in New York City. So we just had our first in-person offering following a couple of pilots that we did online, and we will continue to scale up this course and offer it more broadly. And so who's the audience for my Responsible Data Science, or RDS, courses at NYU? Undergraduate and graduate students in data science and computer science. The course has prerequisites, but few prerequisites. We essentially need introduction to data science or computer science, and that's all. And some programming familiarity. So usually the students who take this class are first-year graduate students and sophomores or juniors in the undergraduate cohort. I am not requiring machine learning as a prerequisite for this course. And this makes things a little bit more difficult because I do need to go back and explain essentially what is a classifier, you know, and how do particular types of classifiers work, but we don't go into those details deeply. On the other hand, by placing this course earlier in the curriculum, I'm able to get people to start thinking about ethics and responsibility before they are fully indoctrinated into how great AI is, right? And so I think that this is really important here to achieve. And it takes more work to teach people who know less. We all know this, right? And so the challenge, as I already alluded to a bit, is to reconcile technical training and the methodological toolkit that we all have, and we are computer scientists in this room, right? And that our students have with the interdisciplinary ethical concerns and methodologies, right? So one way to visualize this is that we are, by definition, reductionist. We try to decompose problems into smaller subproblems that we can solve in isolation, and then we combine these individual solutions into a combined solution, right? And the analogy is always the, you open the hood of your car, right? And I don't actually know what any of those boxes are, but there are a bunch of boxes and you want as few wires between them as possible, right? And this is a good design. But things don't work that way in society. We have to look at these problems holistically. And this is something that defies our understanding and that challenges us as people, as engineers, as researchers, right? So one thing I want to say is that we need to keep this mindset, this really carefully navigating between reductionist so that we can solve and holistic so that we don't lose a view of the forest for the trees, also in the way that we define research problems in data management, but in particular in responsible data management and responsible data science. The last 2 years, I have been teaching RDS with a co-instructor because there are 2 courses to offer, right? And so we do need to scale, but also because I found it very important to have expertise and input from a person who is different from me, who is not a computer scientist. So the co-instructor is George Wood. He is a Moore Sloan Faculty Fellow at the Center for Data Science. In fact, he's actually finished his appointment this year, and his background is in sociology. And he works on the quantitative side of sociology, where he analyzes inequalities in public health and criminal justice domains. And you can see that his degrees are both in sociology. So this is another person who has been very helpful. She's been our guinea pig, so to say, in having the course materials taken by somebody else and teaching in their own environment that is different from ours. This is Debbie Euster. She teaches data science and computer science at Ramapo College in New Jersey. To graduate students mostly. The admissions are far less competitive at Ramapo College than at NYU. Students come in with a lot less of a technical background and mathematical maturity. So she has had to adjust her course quite significantly, but most importantly, she herself, when she started teaching, and she's taught this for 2 years now, she did not have any background in these topics herself, right? She understands computer science, math, she comes from math really, but she hadn't spent the time reading sociology and philosophy and all of these other concepts and law, right? And so she actually needed help, and she was a person that we saw very eagerly adopting, right, some of these instructional methodologies that we were developing, and together with her, we were iterating also on how to scale, how to disseminate these materials. This is a quote from her that I won't read, but she basically says that, yeah, well, we need this stuff and we don't know where to get it, and yeah. I will also point to an article that we published last year together with the very talented Armanda Lewis. Armanda was at the time a master's student at NYU, and she is now a PhD student doing educational research. And so she had a lot of, and she took my course when it was first offered. She has a lot of background in educational research herself. And so we actually decided to write up some of these insights about the approach to teaching RDS and some of the instructional methodologies. And so this appeared last year in the International Journal of AI in Education in their special issue on FATE, Fairness, Accountability, Transparency, and Ethics in AI Education. Right. So what does the course actually look like, right? When a student is deciding whether to take a course, they want to see how they will be graded, right? So let me tell you this first, and then I'll tell you what the content is, and that will give you a sense of how technical the course is, actually, right? So we have weekly lectures and labs. Undergrads have 2 lectures, 1 lab. Grads have 1 longer lecture and 1 lab. Labs are hands-on. We use Python. We have switched to Google Colab to make it easy for people to just enter without, the need to install anything. And so this is all essentially plug and play. And there are 3 homework assignments. They are substantial. I'll show you next what homework 1 looks like, just to give you a sense of what kinds of questions they get to think about. There is a course project that's done in teams of 2, where students develop what we call nutritional label for an automated decision system of their choice. You can think of this as a kind of an audit that they do. They take a Kaggle competition usually, or they take another project that someone else or they have implemented in the past. They look at the requirements. What was the goal of this system? What is the data? How good is the data? They analyze the data. What is the performance of a system that somebody else has built? Is this performance sort of good overall? What about particular subgroups? And then they exercise all of the other things that they learn in this course, having to do with fairness interventions, having to do with transparency and explainability methods, etc. And we'll talk about those. And then they write a report reflecting on whether they would in fact be comfortable deploying a system, this system that they just audited, in production. Why and why not? And then there are also these programming labs that are 10% of the grade. Participation essentially is that component. And there's a final exam. It's a written exam where they solve problems. Right. And like I said, everything is in the open source. Labs, slides, readings are on the course website. I'll show you what that looks like. And we use Python. We use various open source libraries and Google Colab for simplicity. So let me now show you, and I hope that this works, what the homework looks like actually. Can people see this on Zoom? Yeah, okay. So this is my homework 1, right? And this is on algorithmic fairness. So it's like introduction and algorithmic fairness. It's 1/3 of the homeworks. They start by thinking about some setups in which fairness concerns may arise. They think about who the stakeholders are, who are individuals or groups impacted by these systems. And they think about what are some appropriate ways to make these systems fair or to measure fairness or unfairness in them. Which of the metrics even apply, for example, in a particular situation. So this is what they write a written response to with a justification. They do an analysis of specific requirements that you may have for a fairness enhancing intervention, mapping that intervention to an equality of opportunity doctrine from political philosophy. So we teach them this. We have a comic book, I'll tell you about our reading in a little bit, that is focused on this explicitly. So here they take a college admissions process and they say, according to the Locke egalitarian conception of equality of opportunity, here's how you would make it fair, right? And this again is a discussion. This is a math derivation. They show an impossibility result. They prove an impossibility result for a pair of fairness metrics. This is a programming portion of the assignment where they work with open source libraries and they experiment with data sets that we specifically direct them to use. These are benchmark data sets to look at how particular models perform, not just once, but once you've tuned their hyperparameters with 10 runs, 10 random seeds, right? You see how performance changes. There's a lot of experimental work here. Then they try to apply fairness enhancing interventions from the literature to see and whether they work, how well they work. And the message here is things don't work as advertised usually. Yeah. And then, and this is a part that I also want to stress, we use some existing materials that others have developed or that we have co-developed, also to allow students to look more broadly at these topics and to reflect on them. So the third problem here is where they watch a lecture that they choose from among some lectures that I propose from an online course called AI Ethics Global Perspectives. And this is a course that I had the pleasure of co-developing with my colleague, Stefan Verhulst at NYU. It's online, open source. There are lectures from very many prominent figures in responsible AI and AI ethics, and students watch one that is interesting to them. There's one here, for example, on AI and disabilities, and another on Alexa versus Alice, cultural perspectives on the impact of AI, just to give you a sense kind of the breadth. I think there are more than 30 lectures there now. And then they write a memo, a 500-word memo that gives the basic kind of description of what they just watched and reflects on how that lecture fits within the context of this particular course module, and this is fairness, right? Any questions or comments so far? Please. I have excellent TAs. Some parts are easier to grade than others. Yeah, the final exam I grade myself end to end. So the final is not going to be any coding, but we will have some reflection there based on what they've read already in the course. I mean, some pieces are harder to grade than others, sure, but yeah. Homework individually and projects in pairs. Yeah. Yeah, they just pair up. I mean, yeah, sometimes they know somebody else in the course. And then for the project, they choose the system that they want to audit. That's important also. Most students get an A or an A minus, really. I mean, very few students don't do well. And generally in the US, this is the case, that we don't fail our students. This is somehow not expected at all. And so it's more like in high school, right? You do your homeworks, you do well, and you improve over time, and then you get a good grade. And the final exam is 30% of the credit overall, but I don't try to fail people, right? I mean, actually, if they did their work, they'll do well. Background of the students themselves, you mean? Yeah, so I've had actually some feedback, and by the way, this course is very well liked, and I'm sorry to be making this self-serving sort of a comment, but I have, of all the courses that I've ever taught, I have the most fun teaching this course because it's the most diverse in terms of people's backgrounds, it's the most engaged. So this is actually a good segue into this picture here. That says more than 1,000 words, right? We all say that we want to improve diversity in STEM. This is a technical course, as you already saw, right? And just look at look at the people in the room, right? In the US, I've never, ever had this many people who are not white and not white male. I teach databases, big data usually, right? All the stuff that we all teach. So students are very engaged. One concern that I got this year, and I'll incorporate next year, is that many students are from China, and many of the questions really required them to understand complex, English language concepts and write. Now, I'm not asking them to write the War and Peace, but still you need some, some finesse there. So maybe I should prepare them a little bit better for that. So one student in particular said that the exam was tedious for this reason, that it was just hard for her with her English level. Yeah.
So maybe you're going to get to this and then find and kick this question down the road.
Right.
The homework you just showed us was all on fairness. And one of the things I want to understand from your talk is the breadth of social impact issues that you're going to get to.
That's
okay,
coming next.
Good. Then we'll.
Yeah. Thanks. So now we're just playing a student who is deciding whether to take the course, right? So they ask, what are the assignments? And then this is what they learn. Yeah.
Maybe this is a good point to ask this question. You mentioned a few minutes ago that over these 4 years, you find that the students are increasingly primed and very enthusiastic. Why is this? What's the simple explanation for what's happened in these 4 years?
Society is changing, right? I mean, we're seeing lots of negative impacts of technology being covered by the press. There's lots of stuff that people read just in newspapers and hear about, from information bubbles and elections being destabilized to privacy breaches to discriminatory behavior of various tools to facial recognition doing things that we shouldn't be asking it to do, right? So I just think that the society today is such that people are just much more socially aware. And I can also tell you from PhD students that I'm able to recruit, there are absolutely amazing people who apply and who come in with background already in these topics. And I did not see this 4 years ago at all, right? Yeah.
So we saw a lot of technical CS stuff that they have to do. Is there any technical work that's not in CS, like reading political science stuff and that kind of thing?
Yeah, there's lots of reading that is not in CS. Many of the concepts and of the papers that we read are written already kind of in this field of socio-technical, right, systems. Now, I don't expect people to be reading roles on their own, for example. So we summarize political philosophy concepts for them. But I do include articles from the popular press. I'll show you in just a second. So Fala is my wonderful PhD student, and she took my class, and she and I make comic books. So our dream is actually to have a textbook that incorporates comics very, very heavily, and that summarizes some of these less technical concepts for people as well. And we already have a couple of volumes that are part of compulsory reading for the course. Right, so now I'll walk through the course modules. There are 4 modules. The first one is Introduction and Fairness. So the second is Data Science Lifecycle, Data Protection, and Transparency and Interpretability. Each module is offered over a number of weeks. Most of them are 4 weeks. Some are 3, some are 5. And so this is what a typical week looks like. We have a lecture with slides. Slides are posted, you can look at them, the topics that will be covered, and then there is a reader for each module that consists of papers that George and I have compiled, even excerpts sometimes of papers that are relevant to this particular topic. And so you can take a look, just go to the website now if you like, and take a look at the reader. I won't go through it in detail, but it contains a variety of material. One comment that I got was that I should tell people how to read the reader because it can be a little long. So I should maybe tell them that this you really need to read in detail and this you can skim. So this is something that we'll do next year. And then there is a Collab notebook. This is the student version of the Collab notebook for every week that they're going to work through. And then they submit it filled out. During the lab, they do this. And then we also have an instructor version that we keep ourselves with the answers filled in. Right, so the reader I already mentioned. And the notebook I already mentioned. And now I'll give you a couple of vignettes for each one of the modules, and we'll walk through modules one by one. There are 4 of them. I'll spend maybe, I don't know, 5 minutes or 3 minutes per module to give you a sense of how I speak about this material, actually, right? So this is my piece where we discuss what it means to do AI or data science responsibly. What's responsible AI? Try to define it for me. What are the components, right? And the reason that I start with a positive example, with an example where we actually are seeing something beneficial, is that if we can't convince ourselves that there's something positive, then we are technocritics, when we just have to dismiss technology, really, right? But that's not the point. Certainly, there are good examples of where AI is useful and used. And so the example that I give here, also to rub in that Facebook is not all bad, because we criticize Facebook a lot throughout the course, is this collaboration between the NYU Langone Health Medical School and Facebook AI, where they developed fast MRI. I'm not going to dwell on this. It's essentially a way to augment your data to generate somehow a synthetically augmented MRI that a patient has to spend less time in the actual MRI machine. So they extrapolate, and then they show that these are diagnostically interchangeable with a traditional MRI. And this is a big deal because if MRI machines are in short supply, or if a patient is claustrophobic, you actually want to limit the amount of time that they spend in the machine, right? So why am I discussing this? It's because it's clear here what the positive factors are. And I think that these are the hallmarks of responsible AI, that there is a need to improve on the status quo. There's an actual problem that we want to solve. That when we propose a solution, we can check whether that solution works, right? Is it a self-fulfilling prophecy? No, because there actually can be, another modality here. You can go and get a traditional MRI. You can go and get a real clinician to look at it, look at the one that you simulated with this fast MRI technology and tell you whether they're able to diagnose, right? So here there's a chance to actually figure out whether the thing works. This is not true in many domains. Algorithmic hiring is one such domain where you actually don't have a ground truth somehow by definition almost. The third reason here that this is potentially a responsible AI example is that we actually, with the current technology, can solve this problem, right? This is not a pie in the sky kind of a thing. We have the methods and the data to really achieve these goals. or move towards achieving them. And the final thing here that is extremely important is that the people who are going to be using this technology, these clinicians here to make diagnoses, they know how to use it. Not only because they have been appropriately trained to read MRIs, and they also, the people who use this and evaluate this, have been trained on data science methods. They actually know, what's variance and what's a feature, things like that. But most importantly, they know that the responsibility for issuing a diagnosis, correct or incorrect, is with them. They are doctors. They'll get sued, right? And this decision maker readiness is something that lacks very often in domains, right? Like predictive policing. A cop does not meet like any of these criteria. Neither does the problem that we're trying to solve, right? It's a self-fulfilling prophecy. Automated hiring systems are a negative example where we talk about kind of which of these components lack, right? And when we talk about all of this, and I'll just skip through, we always have a discussion with the following themes that run through the entire course: fairness and data protection and transparency and explainability. And these threads are, what is this AI system trying to do? What are its goals? And most importantly, who are the stakeholders? Who benefits when the machine works? In what way do they benefit? Who is harmed when the machine makes a mistake? And what kinds of harms are these, right? Also discussing that being withheld benefits is a kind of harm, right? So this all focuses not on what is the technical problem you're trying to solve, but rather, why is this system here? Should it even be here, right? Because one of the things we study in responsible AI is being able to evaluate whether the system should exist in the first place, right? Should you agree to build such a thing as a responsible data scientist? Any points on this? Let me finish this module actually, and then I'll maybe discuss some more. So here's another vignette from the fairness module. Everybody talks about bias, so we discuss bias. What's bias? Lots of people, lots of opinions. The point of view we will take in this course is one that is based on this taxonomy by Batya Friedman and Helen Nissenbaum back from 1996, from their paper called Bias in Computer Systems, where they speak about 3 types of bias. Pre-existing is from society into data. Technical, this is when your system breaks things even worse, and we'll talk about this some more. And then emergent, and this is when you start using a system and it starts messing with the world even more. Feedback loops are emergent bias. All my slides, I'm happy to make publicly available, and most of them are already, so I'll just share a link with everyone. Right, and this is our illustration here, a dragon with 3 heads, pre-existing, technical, and emergent. And so then we talk about pre-existing bias, right? So how do you think about bias in the data? There's a lot of confusion on this. And this is one of my favorite metaphors that together with Fala, we've developed into a CRISPR metaphor, I think. So I actually have another slide deck where I show a progression of how I talked about this through like 4 different visuals from more to less clunky. So when we think about pre-existing bias in the data, we use the mirror reflection metaphor. Data is a mirror reflection of the world, right? And so this bias is distortions in this mirror, essentially, right? So when we think about bias in the data, we interrogate this reflection. And the reflection may be distorted because the measurement process is biased. We are undersampling or oversampling particular parts of the world, or we're otherwise distorting the readings. Somehow we amplify an effect or we diminish an effect. So that's one interpretation of bias in the data, is that the mirror skews. But another interpretation is that even if you just do this mental experiment, you have a perfect mirror. Your data is a perfect reflection of the world. Well, guess what? It's still the world such as it is today, and not how it could or should be, right? And then this makes us immediately realize that negotiating what the world should be like is not up to machines, and it's not up to data. You can't ask an algorithm to go and debias your data set to make the world different, because even among us people, we don't have consensus about how the world should be. This is the hard work of democracy, right? And this is this intersection between data analysis and responsibility and impacts, ultimately, right? So this is how we talk about bias, and we go through examples and people talk about their own examples of systems that they've encountered. And then only once we've talked about things conceptually, once we've talked about values, only then do we start discussing technical interventions. with the understanding that sometimes a technical intervention is inappropriate. You should just scrap the system altogether, right? Other times, the right intervention is to go get more data or ask more people to explain to you how that data was collected and what it lacks, to try and understand the properties of the mirror. And then this is the kind of the last piece here on the mirror reflection metaphor, is that when you do decide to apply a technical intervention, be careful, because it may be the case, and very often it's the case, that all you are doing is brushing up the reflection. You're not actually propagating the changes back into the world, right? So the next time you take your picture, the next data set that comes in, it's going to have all the same biases, right? So just be very careful in terms of what you can and cannot expect of technical solutions. You can't expect technical solutions to dictate what you do with the world that you have before you. And you can't expect technical solutions alone to solve the whole problem, right? Once you've decided to admit a diverse class of students, for example, just admitting them is not enough. Because if people didn't go to really good high schools, they're going to fail at college. You have to do supportive remedial interventions for them, right? It doesn't stop at the admissions process. So all of this is a responsible AI discussion. And we have these discussions. We don't rush through them to dive into the latest method from the AIF 360 toolkit, because anybody can learn how to use a library function, right? And this is just a quick snippet here from our comic book that also tells you how fresh this field is and this material, right? So Fala and I made a comic book called Fairness and Friends with our collaborator Eleni Manis, who is a political philosopher, where we do a mapping between equality of opportunity doctrines from political philosophy and algorithmic fairness, because people who have been building algorithmic fairness methods sadly didn't bother to do this. And so when we started out, we started with a paper that was kind of the only paper that anyone knew by Haidari and co-authors that was cited by everybody that said, oh yeah, there is a link between algorithmic fairness and political philosophy. So we drew these 4 corners here of a EO empire. Libertarians live there, and Formalville is where formal equality of opportunity people live. And these are the lucky egalitarians, and these are the Rawlsians. Rawlsians are the bouncy castles of social security. It's a very funny book. You should look at it. And then at some point, we realized that libertarians are actually not at all equality of opportunity. So now I just had to build a fence here. And we're working on a new iteration of the comic book for next spring, because they don't equalize anything. There's really no notion of it. It does not qualify essentially as such. Yeah, well, that was the best I could do, right? So it's a new field, right? I mean, understanding lacks, materials lack, but we cannot wait until we build this out. We have to intervene now, and we learn in the process. Right, second module. Data science lifecycle. This is going to be something that we relate to most in data management. And this has been my kind of agenda in the data management community, is to try and build out this piece. But at the moment, this is actually the shortest module that I have. It only has 3 lectures, and that's because we've just not done enough work yet. So we need to do a lot more work in this community to try and fill in this piece. So here I'll give you a vignette, and there's a reader there as well. And that vignette is fair machine learning is where all the action has been really on this. And their worldview is as follows. You get the data set, nice, rectangular, and clean, and given by God. And you process it through your neural network, and out comes the results. This is a multi-class classification. And then you somehow discover that, you know, people from historically disadvantaged or underrepresented groups all end up in a less desirable outcome group. Like they don't get jobs, for example, or they get worse jobs. So in the fair machine learning view, what can you do? You can try to fudge something with the data, with the input data, that's the pre-processing. You can add a regularizer to the model, try to somehow squeeze in fairness there, or you can reassign outcomes, right? But this is a limited view. It's like we depict this as fighting a paper dragon in training. That might be useful in training, but the real dragon is not that dragon, right? So we need to ask what happens inside the box, how results are used. This relates to emergent bias. And then where did the data come from? And this is where kind of all of data management feeds in, right? So this is a better view, we think. And this is just one way to depict the data life cycle. You know, every one of us has given a talk in which we have a rendering of the data lifecycle. So this is mine. Says starts with sharing annotation of the data, and then somebody acquires it and curates it, and then there is a bunch of pre-processing here, like data imputation and data integration and taking subsets, querying, ranking, and only then do you feed it to your predictive analytic, right? So we need to actually look at all of these stages. And this is a huge opportunity for all of us to contribute to this work. But again, not being fixated on the technical solutions, because they have to follow from what we're trying to do and where this is going then later, right? So one of the things that I think is, and I guess this is part of my rant here usually, is in data management, we pride ourselves on building these general purpose database systems. Like, you give me your data, I'll keep it for you. You can do with it whatever you want. This does not work in responsible AI. We have to be aware of the task, because what is going to be done with the data immediately maps to who are the stakeholders, who benefits, and who is harmed. And we have to know this when we decide on the technical interventions, because, you know, even just thinking about error rates, right? What kind of an error do I care to minimize? Because I can't minimize all errors, right? So if I have a trade-off, for example, between false positives and false negatives, maybe a false positive in my domain is okay, more people get loans. And a false negative is a problem, right? But if you look at a different domain, like, I don't know, criminal justice, where I don't think you should use these tools at all, but that's just what comes to mind, a false positive is bad because you get incarcerated, right? So you actually need to think about what is this for, and therefore, how do you optimize this? The task has to come in. Right, so this is my example. This is based on joint work with Sebastian and his group, where we look at the impacts of pre-processing interventions on some properties of the result. So in this case, we talk about a particular kind of fairness, and that is, you have data coming in from different people, you pre-process it, you interpolate missing values, you do the model selection, training, validation, and then you determine, once you've looked at the results, that predictions are such that their accuracy is lower for older women. And the setup here is that this is a predictive analytic that is being developed so that you can decide what salary to offer to an individual being hired. And so when you have more mistakes for a particular demographic group, that's a problem. But in particular here, what we say in this constructed example, that the mistakes are such that older women are getting offered lower salaries. And this reinforces the gender wage gap if somebody were to follow these predictions, right? So you have to always kind of take it to the end and say, why is this a bad thing? And now this data scientist, her name is Anne, is thinking what could be going wrong here. And she looks at one particular component of her data manipulation pipeline, and that was missing value imputation. And this is a very recent picture that I really love that Paula just made. So she has some data in which values for the number of years of experience on the job is missing. And she looks at her pipeline, and she took the default in scikit-learn that said, let's impute missing values with the mean value for the population. This works fine under the assumption that data is missing at random, which means that whether or not a value is missing doesn't depend on what the value is. But in my example, values are missing not at random. Guess what? People who are older, and especially older women, don't tell you how many years of experience they have, because they worry, and rightfully so, about age-based discrimination, ageism in hiring, right? And we see these effects everywhere. So what is that I'm describing? This is pre-existing bias in the data. Because of discrimination, older people and older women won't tell you how old they are or how many years of experience they have, because that's a strong proxy for age, right? Now, you can't use age to make these decisions, that's illegal, but you can use the years of experience. And so then your system, by making an incorrect assumption about how values are missing at random or not, it's amplifying this pre-existing bias with technical bias. This is a classic case of technical bias. And so these are missing values. If you interpolate using the mean, you get this. Now watch, if the ground truth is actually like this. You see how the distributions shift? Right, so you imputed these people younger and with less experience. And that's why you're offering them a lower salary. Now, if you figure out that this is going on, you, the data scientist, and then you can intervene. You can go and take a different data imputation method. But what it takes is for you to be aware that this may be happening, right? And so then we talk some more about models and assumptions, and about how these models, incorrect models and incorrect assumptions, not only can they impact performance badly in terms of, I don't know, running time and overall accuracy, but they can also have discriminatory effects of the kind that I just described. And we go through many such cases with joins and with filtering, et cetera, et cetera. And then we have a hands-on lab that uses ML Inspect. And this is a tool that Stefan Grafberger, who was just here, and Sebastian Schelter and I developed together. It takes a pipeline in Python, and it extracts a DAG of operations, and it allows you to instrument it to trace what happens to data distributions so that you can catch data distribution bugs, as we call them, and some other issues with the data. So this is the methodology here. I think I'm running out of time. The third module I'll skip, it's data protection. Here we talk about data protection kind of generally. Why is that a thing? We talk about differential privacy. I teach through randomized response. I ask people to flip a coin in the classroom and tell me whether they went out drinking over the weekend. And then we estimate the true proportion. And then we read some articles, and then we use some tools, actually tools that we have built and that others have built to exercise, to give people a sense of these trade-offs between privacy and utility, epsilon, and utility accuracy. And then we also, in this module, and honestly throughout, but in this module in particular, we talk about laws and regulations that are relevant here. So we talk about some local laws. This is a New York City regulatory effort that I was part of. And so I talk from my own experience quite a bit about how important it is for people, technologists, to get involved with regulatory approaches, because regulators don't know what the heck AI is, honestly, right? So they need us at the table. And then we have some cool images here too. Anti-Elon Musk, who says regulation rocks, and how you should go about it. And we talk about the GDPR, and I actually point people to the GDPR, the primary text, to read it. And the Canadian Directive on Automated Decision Making I like very much because it takes an impact assessment based approach. So we talk about that. I'll skip that. And then transparency and interpretability wraps everything up. I think appropriately, really, because ultimately what we want to do with responsible AI is we want to expose the knobs of responsibility to people. And this we can do with the help of explainability mechanisms. And here by people, I mean everybody. Technical people, surely, but also regulators, also people being impacted by this technology. And this is why there is a variety of transparency and explainability methods. Some are for the more technical people, others are for the more lay users or just the public at large. And this is what we talk about here. You know, what are the different kinds of terminology that people have used? And that ultimately what the goals are is kind of to move away from a place where we are just people interrogating machines, and machines have this responsibility property or transparency property, and into a world where we control them. We turn the knobs, right? So placing a human at the center rather than saying it's responsible AI, it's unbiased data, right? It's not about data, it's not about AI, it's about us. All right, so this is just, here again, we get back to stakeholders, and we take this angle of what is interpretability for. It's too large of an umbrella term to be talking about meaningfully. You need to think about what do you plan to explain to whom, and what do you expect them to do with that information, and how do you actually measure a material change in action based on the information that is presented to people. And we covered the classic sort of auditing black box models. This was QII, quantitative input influence. We cover SHAP and LIME, and then we should cover SAGE next year as well. And then we talk about my favorite thing, one of my favorite things, and that's nutritional labels. And here we get back to the hiring and employment domain that I've been very interested in. This is an article that I recently wrote in the Wall Street Journal that argues for disclosure to job seekers before they apply, that machines will be used to screen them, and telling them specifically how, what features are going to be used. And this is an example of a nutritional label that we might have for an accountant. And I'll give you another version of this. In New York, we just passed a law that in fact compels companies will compel them starting January of next year to do just this, to give bias audits, but also to disclose to job seekers before they apply how they will be screened. Right, and so this is another sort of this I wanted to show you. So this is the anatomy of a job posting label, this label that accompanies a job ad. You start with telling what qualifications will be required. This is for an accountant position. So you need to understand the financial system, have a bachelor's in accounting, have good grades, and be a team player. We can somehow tell this from your resume. And then what data will we use? Your resume, your LinkedIn profile, your credit score, and maybe other social media, but you can opt out of that. It says optional here, right? But the other ones you can't opt out of. And then we will assess you with the help of AI-assisted personality prediction. And I can talk to you for an hour about this, or 3 hours, and you can't opt out either. And also we can do a personal interview with you, and you can request accommodations if you need to. So when somebody sees this, they can withhold their informed consent. They can say, no, I'm not okay with this. I don't want you to be figuring out how dominant and conscientious I am using an AI tool. And so they won't apply. Or they won't apply because they don't have the right qualifications, right? But right now, people have no idea at all how they're screened. So although for you to be able to actually do this effectively, right, to show information to job seekers that they need to have access to, and to have them understand this information, they need to understand the meaning of the proverbial calorie, right? So nutritional labels for food, you have to know what a calorie is. Here, you have to know what features are, and several other things. So very quickly, in summary, I think it's important that we also teach just regular people stuff. And I don't have time to talk about it because I do want to take some questions. These are our comics. These are the more technical responsible data science comics. This one is the first volume. It exists in English, of course, but also in Spanish and French. The French was translated by Serge Abitboul with a few others. Many of you know Serge. And this is the equality of opportunity one that we're going to redo now that we need to build a fence for the libertarians. And I've also been active in public education because I have realized very quickly that we don't need more algorithms necessarily, but rather we need a more informed public to be able to move the needle on this whole conversation. And this is a course we offer. It's called We Are AI. Everything is public online. Please take a look. This is what it looks like. There are some videos there to watch. It's a similar structure as my NYU course. This is one of my favorite segments that I don't have time to get into, but it's the problem with the trolley problem, we call this, why utilitarianism doesn't work. We have a Bentham here, and so this is the trolley problem opens a can of worms, is this depiction. And it has a name, it's algorithmic morality. So I'll just leave it at that. There are 5 comics, 5-volume comic book rather, to go along with the course. And it's also just been translated and printed in Spanish. So that's that. So let's all understand that we all are responsible for this and think carefully about how we develop tech. I guess for this audience is my main question, that it won't solve all the problems that we got. And then this is my favorite quote from Serge. I'll really end on this. And he's featured in the comic as well. So he and Schildgen wrote a book called The Age of Algorithms. It's been translated into English. Creations of the human spirit, algorithms, and AI, I added, and AI, are what we make them, and they will be what we want them to be. It's up to us to choose the world we want to live in. Thank you very much.
All right, thank you so much, Julia. Are there any questions? I figured there probably are. Yes, Kathi.
About 12.
Yeah, good.
So I've also been trying to do a bunch of work on teaching students how to identify social threats in systems. And one thing I'm noticing about what you've presented here and the way I've been trying to think about it is that yours is very centrally grounded in AI as the frame in which to talk about these issues. And I'm curious, do you think that's sufficient for the education that students can reasonably get in the context of, say, a computer science degree before they're in a specific context and a job? Or are there other areas that you think don't quite fit into the AI umbrella that are also critical for students to get exposed to?
So I deleted the second slide that I had here because I knew I'd run out of time, but I have the slide where I define AI actually, because I think I I'm entitled to just as much as anybody else, right? I have a PhD in computer science. So there, my definition of AI is AI is a system or systems that use data to make decisions that impact people. And they either make these decisions autonomously or they help us humans make decisions. That's my definition. Not everybody's going to agree with that definition, right? So really what I mean here is sort of automated decision systems rather than AI, only it's a mouthful, right? I want data, some algorithmic processing, impact, something that matters, and the context of use.
Okay, so reframe the question around automatic decision systems. What are the big things that you've seen in the work you've done that get left out if that is the scope that we center this around for students?
No,
Or
I
not really?
think it's pretty expensive. I'm not really interested personally in AI systems, but that's just me, that don't have a material impact on society. I understand that we as engineers have a professional responsibility to build systems, even if they don't have a social angle. I don't know, maybe we detect what stars where, right? That actually work, right? And that's something that I am talking about explicitly here. Also, I have a whole rant on the scientific method and how we all seem to have forgotten about it. But I specifically focus on systems where it's data about people or that impacts people and that changes the world on Earth in our society. Not an automatic telescope, let's say.
All right, I see. Sorry, it was first.
Hi, so thanks for this great talk. I was wondering, I mean, it's clear given the community here that you teach responsible data science, but then actually, if you think about your definition of what artificial intelligence is, that applies one-on-one to, say, safety critical systems, which is the total opposite of AI and data. So what I'm wondering, or not, that's exactly part of my question. So what I'm wondering is, should we be teaching these important subjects with a special focus on data science, or wouldn't it make more sense to actually go into responsible computer science and just broaden up the course a little bit? What would be your opinion on that? So what would you say is required to extend it that way, or doesn't make sense? Doesn't that make sense?
Yeah, so I don't even feel strongly about kind of algorithms being part of the picture, really. I live in the US, so I cannot have a narrative that is centered on data protection. But really, I personally am more interested in the impacts on people, on data subjects, whether or not these impacts are achieved with algorithmic means at all. So I think that anything that is in scope of the GDPR, let's say, and many more things, should be what we think about. So if it's a human looking at a data set that was collected and using Excel to decide who gets into college and who doesn't, that to me is in scope. Right? But again, in the US, given the political climate here and that we see ourselves as different from the EU, I cannot be selling the GDPR here explicitly. Plus, I think that it lacks many of these components here that have to do with an explicit focus on interpretability and transparency, although that is also coming in now in the European Union. Whether we should be calling this responsible computer science or safety critical systems, I think that we should be calling it whatever people will respond to more. Because our goal is not to call it precisely what we think it is. I don't think we can define what it is, frankly. And this is why I ultimately went with the AI keywords, is because this is what people will read, right? Our goal here is to reach people, not to stay true to our principles and, no, I don't do AI. So I'm just calling this for really utilitarian reasons. I'm calling this responsible AI. But I think safety critical systems surely are in scope. I don't work on them myself, but yeah.
I think we can have one more question while you set up for the discussion session. There's also a question online. Yeah, I saw that. We can also just take more questions. Yeah, okay.
So the engineer here has a lot of power, and some of that power is regulated, like Data Protection Act, age discrimination. There are just certain things you cannot do. I wonder whether you're aware of work where this is looked at from the legal domain, insofar as to how even this power inherent in building such a system is regulated and where the power ends. And not from an ethical point of view, but really like from a legal point of view.
From the legal point of view, treating whether engineers should be held responsible for these types of decisions. Yeah, I don't know that there is such regulation. I don't know. I don't believe there is. But this is my answer to you, and that is that we all are responsible. And it's also important for us engineers to not take too much responsibility upon ourselves, right? Because this is actually not our job. We should not, it's kind of on the one extreme, it's hubris, us thinking that we are God and we're able to adjudicate through algorithmic decisions what interpretation of, I don't know, equality of opportunity the system should be taking, right? On the other hand, and then you mentioned, Kathi, the ACM Code of Ethics. I was actually one of the contributors to the revision, delegated by SIGMOD'. People have also a professional responsibility to not take upon themselves things that they don't know how to do, right? So I think that a responsible engineer is certainly not going to be comfortable with making such decisions alone, right, in front of their computer. Now, laws are one, regulation is another mechanism, right? Codes of ethics is another mechanism. Having your own conscience is yet another. We're not going to be relying or able to rely on just one way to oversee these systems, right? So we have to use all of the tools in our toolkit.
Yes. Yeah, Joe. Do you want to ask your question yourself, Joe?
I can also zoom out, right, and see people. I don't know how to do this. Stop sharing. Right?
Hello, Julia. Can you hear me?
Yes, I can hear you. Hi, Joe.
Hi. Thanks for such a great talk. Thanks for keynoting for us. I'm curious about how your material is kind of composting down into other courses in the department. I have a hunger to take some of what you've talked about and put it in my class, and there's always a question of how to fit things in and whether you've thought about integrating this into some of the other coursework.
I have done a lot of guest lectures and a lot of kind of modular installments in other courses. In introductory computer science courses, Intro to Machine Learning is a really good course to take this. And my course is designed explicitly in modules. So what you can do is you can take a module and you can use just the first part of it, for example, if that suits your needs better. If there was a particular ask that you had, I'd be more than happy to work with you to actually try and figure out how to make this fit the needs of a particular course. And in general, I didn't say this, but I'm very interested in understanding how to both scale this up, but also cover more breadths. So I already mentioned that I'm doing public education. I think that we need to do more modularized education, and we need to also be teaching people on the job now, right? We don't have access to them in colleges anymore. So educating professionals is another thing that I'm working on quite closely, and I'll talk about it next time, I guess, or some other time. But yeah, let me know if you want to talk offline.
Question to Joe's question. So you mentioned you also teach the standard database course.
Yeah.
Have you propagated this into your other courses?
Yeah, so I teach really mostly databases and this, and I teach one course a semester. In both in databases and in big data that I teach occasionally, I incorporate some components of this, usually just the introductory module, a tiny bit of fairness, and a tiny bit of interpretability. That's sort of my, you know, if you had 2 lectures, this is what I do.
All right. Oh, there's more questions. Yeah, we can do it, right, Fenya? Yeah, so yeah.
So the EU last year actually passed a new regulation policy for how to regulate AI systems, and they essentially mandate now that high-risk AI systems follow a code of conduct, and non-high-risk can voluntarily follow this code of conduct. Would you have a definition of high-risk AI systems, or where would you delineate those kinds of?
Yeah, so this is also something that I teach as part of my course. This is based on algorithmic impact assessment. And it's not a binary kind of a high risk, low risk. There are multiple risk levels. And when we think about risk, we need to always instantiate this domain by domain. So there's some general guidelines. The Canadian directive does this quite well. They have a very nice appendix where they discuss, in fact, how you would instantiate risk levels. So it essentially is based on how many people are adversely impacted and what is the nature of the adverse impact. Is it permanent or reversible, right? So this essentially is the argument that you make, but then the devil is always in the detail and the devil is always in the application. And this is why I personally also kind of changed a little bit from being involved in regulatory efforts that are like, let's figure out how the city should use AI responsibly, to what do we do in hiring? because to really understand how to negotiate and spell out these risk levels and oversight requirements, you need to have a lot of experience domain by domain and then go bottom up. So like use a data science style approach here. There's some schema here, but we need more data.
Any final questions? Kathi, want to ask more of your 12 questions?
No, I actually had a follow-up comment on Joe's question about integrating this kind of content into other courses. So I mentioned in my talk that at Brown, we've been trying to do this integration across most of the courses in the department. And one of the things we discovered the first time we did it, when we asked different courses to think about what could you put in, everybody came up with AI and fairness. So students were complaining that I'm seeing the same thing over and over and over again. So I think for those who are thinking about putting content into multiple courses in a curriculum, you really need to think about the coordination, because I think we've made enough progress that people associate AI fairness and responsible computing, even if they don't teach it. That's kind of the quick association. And I don't know if you have any
Yeah, I
thoughts
have
on
a
it.
response to that, and
Yeah.
that is that it actually, I think, is harmful to only talk about fairness.
Right.
Because this is one of these angles that people have taken first on this, and that has given rise to lots of these just monsters, techno-solutionist monsters. Fairness is not all there is. I think that if you teach fairness, you have to teach interpretability also, because it's fairness for whom? You're only as fair as you are able to actually, there's always trade-offs. You cannot resolve them, right? You need input from people at every level. So teaching fairness, but not mentioning interpretability, I think is actually a problem. So that's just my reaction.
Yeah, I think that's all kind of warnings to people thinking about doing this in multiple courses, that you do have to pay attention to the coordination. Otherwise you end up in.
Or not. I mean, so I'm from NYU, which is very representative of New York City. And that is, we are extremely distributed. We have 2 computer science departments, a Center for Data Science. We all offer different courses. There's always enough demand. I think if you trust your people to have expertise, that they can teach whichever way they like to. So I don't think we should overly coordinate. Maybe at smaller schools where you have somehow more standard pathways towards degrees, but the real world is messy. You know, real cities are messy. Life is messy. I think it's okay to just have more and then coordinate later, because we just don't have enough of this right now.
All right, lovely. Let's thank Julia once more. And I'll give the floor to Fenya for a discussion.
Okay, good. It is, I think, yes, time for our discussion. Let me see. So it is a short one. So we only have a bit less than an hour for that. So I will also make a short introduction to it. First of all, I wanted to say why we are doing this session. So we really just wanted to give everyone the opportunity to just, talk maybe for the first time in SIGMOD about how we teach databases and other similar subjects, what problems students maybe face. It should be here. And other common experiences that we have. So we thought, let's just have a session where we allow everyone to just talk to each other. And also there is another reason. We thought that maybe through this discussion, there might be some ideas for some research topics that might emerge. There might be some problems that we might find that we are worth researching, and we might see solutions in the next DataEd, next year maybe. So we tried a little bit interactively in collaboration with you to find some discussion topics, some topics that you think are worth discussing in the workshop. And let me see, I think that if I find a USB, where the USB goes in this, I'm a Windows person. Okay, there is a file here.
No name. Click on open no name.
Yes.
Double click. I'm doing this upside down. Right.
Okay, and then we have to share this too. And how do I share this now on Zoom? I really don't never ever use Apple products. Sorry. In this community, maybe. Other than Windows products. Okay, so the format of the discussion, we thought that we can have about half of the session where we can just discuss the topic, one of the topics that we choose. And then we found some topics that have to do with curriculum, with assessment, with the database topics that we have found to be challenging for students, and with K-12 education. And there were also some topics that were suggested, wonderful ones that have to do with career prospects, and we left those for the panel discussion. So yes, we're not too many, I see. So I think that you can see that there are 4 topics. There are also 4 flip charts there. And just to combat the after lunch tendency to nap, we thought it would be a good idea for everyone to just be standing while discussing this, and then you can split using those flip charts. So there are 9 people online, and then yes, immediately afterwards, I will just go to the people online after I mute this to see how we'll organize the online session. So for those of you that are here, there are 4 flip charts, 1, 2, 3, 4, each for the 4 discussion topics that are here. So you can just go to the one that you find most interesting to discuss with the others. And then in about half an hour, we can just resume to discuss about common findings. Since we are not too many, I don't know if it makes sense to do that, or if we can just start a discussion that's interactive between us. We can just chat. And those of you who are online, and I think that it would be nicer if we can have a view of everyone. So I will just stop sharing. Yes, yes, exactly. Let's not break up. Yes, that is the same in Windows. So we have a chat. So initially, I think, sorry. Yes, so the 4 topics that we're thinking about discussing were about curriculum topics. So it is about what do you teach in your data system courses, when is your first database course in the curriculum, and also what topics should be included in there. And then we can talk about assessment and also about different assessment types, about maybe database topics that are challenging. So what do you find really hard to explain to students? What do they really struggle with? And then about K-12. So what data-related topics do you think that we should include in K-12 education? And this is very related to what, of course, we had in the first keynote. So do you have any preferences about what we should start with? Yes, I think that those of you who are online can just unmute yourselves because we are not too many. Oh, thank you. Okay,
Okay,
hello.
Marcos here. I would just say that I can't hear the words from the audience there, so we just can't hear them.
Yes, this will be a bit hard to set up, but what we can do is whoever wants to talk, I can just transfer the microphone, maybe. So if you have no other preferences about which topic to start with, I think we can start from the beginning.
Yes, I think that we can start from the beginning.
So do you know what is happening then in a university where you are teaching? Where is the first database course position in the curriculum?
So I could start. I teach in the Rutgers Business School. So our program is called Business Analytics and Information Technology. And In the first 2 years, the students take a management information systems course that introduces them to how the data is used in business, and they learn to manipulate spreadsheets. They learn a little SQL. And then I teach in the 3rd and 4th year, their choice, a standard database system course. And the rest of the curriculum is analytics, R programming, things of that sort.
So I have a 3rd-year computer science database course, and that's the first time they get exposure to really any type of SQL. I mean, they have a little bit of exposure in the web programming course when they build their backend, but otherwise it's pretty much an intro to like entity relationship diagrams, relational databases. They learn about normalization. We talk about indexes, and we sort of get into the ACID properties. So that's really their entire experience in one course, and it's quite heavy.
I can go next. So in the Netherlands, we have a 3-year bachelor's program, so we don't have this concept of general education as much as those of us who did our studies in the US or North America have. And so consequently, the bachelor's database course in both of our computer science and data science programs falls in the beginning of the 2nd year. And the way we teach it is to delay the discussion of some of the topics you mentioned, Michael. So the systems topics to a 2nd course, which is more on the systems engineering. And so the first and then mandatory exposure that they have is to query languages, data models, conceptual modeling, constraints, quite a heavy study of constraints, so things like foreign keys, equality generating dependencies, multi-value dependencies, tuple generating dependencies. And so it's really on the conceptual logical level that's mandatory in both of these degree programs. And so we view the systems aspects as being an upper level elective. So they'll take that in the 3rd year if they wish, and particularly the students who do that, or those that will continue into a master's in computer science and not our master's in data science. The question is, what do you teach in your introduction to databases course in your unit?
Hi, I'm Ria Bormeo from the Philippines. I teach in the University of the Philippines Open University. And for the Introduction to Database course, I haven't actually taught this in a long time, maybe in years, but I'm going to teach it again this coming 1st semester, which is in September. And I'm allowed to change the course outline and introduce some new things. But what I remember, just the basics, relational databases, SQL normalization, and some query optimization at the end. I think just like a generic and undergraduate degree. But I went here actually to get ideas on what to include in the special topics section of the class for the 1st semester. Thanks.
I don't think just a moment. I was just curious while you were all saying about that. So I hear about many universities then teaching databases quite late at the 3rd year. But then doesn't this mean that the students have many less opportunities to actually do any repetition of what they are learning? Because when they do learn databases in the 1st year, then they will also use it in the group projects, in the projects that they have in the next 2 years. So, yeah, I don't know. When do you teach, Michael?
So it normally happens in the 3rd year, either the 1st or the 2nd semester, so the fall or the winter. It's usually strategically placed with the web programming course. That way they can sort of piggyback off of us teaching them the back end and them using it. Funny enough, our curriculum built it in a way that I actually cover some part of indexes. So I cover hash tables and B+ trees, and the operating systems course actually piggybacks off of the fact that I teach them about B+ trees, because they can sort of leverage that in their courses. But in terms of repetition, aside from the advanced database course, which happens in the 4th year, usually 2nd semester, most students only see this course as their only exposure to databases, and it's not really continued.
Can I ask a question?
Yes, of course.
I found that my book didn't talk about database security at all. And so I added a module on database security. And I was just wondering, what kinds of things that seem to fall a little outside the normal list of SQL, normalization, et cetera, do people teach? And do other people find the need to include security?
I don't include security, but I teach data log because I like to teach data log, and they love it or they hate it. And we teach normalization, and no one likes to teach it anymore because they really don't follow it. But then you discontinue, and they say, oh, but they ask us at job interviews about normalization, so you have to keep teaching. Which I like teaching it, but they just don't connect.
So are there any other topics then, except from security, that you think should be covered and they're usually not covered?
I think it really depends on the degree program, right? So in Eindhoven, it wouldn't make sense for us to teach anything about security because there's a mandatory course on security that all bachelor students in the program take. And those guys do a proper job of it. I think there's even 2 courses over in that space. So I think it depends, right? So you could also just as well teach, for example, visualization of data, but in our programs, we have a separate module on that in a 1st year course. So yeah. I don't know if that answers your question, John.
Just to sort of add to your point, one of the things my institution's been pushing recently is a connection to our security specialist program. So they want more connections. Now, usually the web programming course covers a little bit of SQL injection attacks, but I've been incorporating that more. And there was a talk earlier today using that game, the SQL insects, that I full well intend to use this upcoming year when I teach the course. So that's a module that they'll be using too. I see you pointing, you're going to use it too, which is awesome.
Yep.
Yes, I also played with it already yesterday. It was so much fun. You also get to see the things that you don't know in SQL. It was very interesting. And so I understand that you are teaching many different subjects, but what about assessment? I just wanted to check if you have like a common idea about, or some commonalities about how you assess them. Do you have any group projects, any other assignments, any other types of formative, summative assessments, something that goes very well, something that doesn't go well?
So one thing I discovered was that when I used to teach at a small liberal arts college, and in the beginning, the students were horrible in their exams with SQL. And so what I did there, and what I do in a different version where I am now, is I introduced a mini project all about using SQL on a data set. And then I had a lab exam where they had to do that as the exam. They had to write queries and whatnot. I found it easier to grade, and I found that their understanding and performance went up. So now I always incorporate something with a ramp up to have them use SQL, and then something I evaluate, a project or an exam that where they have to do SQL and hand it in.
Oh, that is very nice to hear. Anyone else doing something similar? Yes, please tell us, Michael.
Sorry, I feel like I'm just speaking a lot. So I have something similar, and I've sort of lined up. In the past, it was 3 assignments, and then I moved it to 5 labs. That way it was more manageable in chunks. So they were bi-weekly assessments. And they basically start off with a large chunk of text. And by large chunk of text, I mean like 2 pages of English text where they're required to put together an ER diagram. And that's difficult because I don't talk about normalization. I don't talk about good design at all at that point. It's just like, here's how you put together an entity relationship diagram. Here's how it works. Here's a bunch of text, put the requirements together with a partner. So they work in a group to do this. And that leads into them constructing an ERD and then them being required to convert that ERD into tables. So they have a schema they develop and they build the DDL. The second sort of step to that is I give them the correct or normalized DDL and I give them data, which by the way, takes a long time to generate. So there was a talk on Sunday that gave us an idea of how to generate data for like universal use cases, which is another thing I full well intend to use because it takes a lot of time to figure that out. But once we have that, they're basically required to do 2 things. One is load the data into the DDL and then answer a whole bunch of questions in the form of queries. So they create queries based on a certain set of requirements I ask for. After that, I have them translated into relational algebra. And then the next lab is, okay, take the original schema you started with, your ERD, and now that you've learned good design or proper design, how would you change it to better, like to reduce redundancies, but improve the schema in general? This takes a lot of teaching assistant hours. And I've realized as my course scales in size, because it originally started at about 50, 60 students, I'm at about 300 now, and it's impossible to manage. So I don't know what to do. If anybody has any good ideas, I'm happy to chat. Or if you think like scrapping ERDs altogether is the way to go. But that's sort of an open question I had.
May I intervene on this?
Yes, please.
Okay, so sorry for maybe I have interrupted Joanne.
I just
Okay.
wanted to say, I don't know who you are, who was speaking, but I'd love to talk about that. I have 300 as well.
Okay, I have a similar, we have a similar experience here in Lecce, Southern Italy, because normally our assessment is done via an exam, and the students are provided with a 1 or 2 pages of English text, so they have to elicit the requirements from the text, which mimics a use case, a potential use case. Then they have to model an ERD, and then also they have to sketch the logical modeling, and they are required to try to write a couple of queries of SQL queries on that specific ERD they have created. And the last part of the exam is related to dimensional fact modeling. So they have to move from one type of conceptual modeling to another type. And this is very demanding from both from our side and from their sides, because they are required to do several modeling activities, and they found several difficulties in understanding the text if it is provided in English. And so because it is mandatory that we have teaching in English, at least in the master classes, and so we had to provide them with Italian translations, and so they are provided with 2 texts essentially. And the other difficulties they find is obviously in the conceptual modeling. And so we are trying to cope with this sort of extreme exam by simplifying it into different shrink the exam. So they are required to do something after a certain number of weeks, and then they are requested to do a different kind of exam on the following weeks, which is actually the prosecution of their initial modeling, obviously on the same activity. But it is quite an interesting topic because they found this way of assessment very difficult, and so I'm sure that the students would like much more different types of exam. But we experienced that their modeling ability, if they succeed in passing these exams, is definitely way better than whether they are assessed with multiple multiple choice exams.
Yes, George.
If someone actually wants to continue on the assessment topic, please do. But I want to kind of come back to something that both Julia and Michael touched on. So, Julia, you said we teach data log in the intro, and I said, yes, we teach data log too. And then a little bit later, Michael was saying, like, I don't know, should we drop conceptual modeling if it's too difficult? And yeah, and Julia, you're shaking your head no. I would shake my head no too. So is there some sense of what are the basic data topics that should be covered, not necessarily in a first course, but somewhere in the curriculum, say computer science curriculum or data science curriculum, that students must learn? Or is there some canon, or is this question ill-formed? Maybe there's no such thing as a canon.
My opinion is that we need to teach them declarativeness, and we are the only ones to do this, right? I mean, this is the main thing about our toolkit and about our worldview. And then also the fact that there's schema and then there's data, and that you know, maybe you want to derive your schema, but really schema is first. Yeah, I just think that that's such a beautiful set of topics. I think we need to tell them that it's beautiful, and data log that's why I teach it. It's because it's just such beauty. Yeah.
I have a question.
Yeah, so we actually do a hands-on exercise with data log now that there is logic blocks. This thing still runs. Do you use it? Yeah, I have an assignment even for them. The web-based UI of logic blocks runs, so it's for now. Yeah, sorry, not very profound, but I think we need to convey to them, and also the how we think about performance, right? It's very different in our class compared to everywhere else. That it's the number of IOs. So that's why we should always teach at least a little bit on indexing and random access, sequential, all of that, because they don't get that anywhere else.
I often think that data systems is kind of like one of the quintessential faces of applied logic. Essentially, that's what we're doing. It's like logic in the world, all the way through to the things that both you and Kathi talked about this morning and this afternoon. So it's almost like a branch or a form of applied logic, but applied logic that's really changing the world around us.
And I'd say some of the movement you see for teaching formal methods is in some of that similar space. I mean, I think we are seeing a little more uptake and interest in some places as industry starts to use formal methods more, of students understanding logical specification and things that connect to what you're talking about.
On this is that we also, I think, are a really good example of a successful field that hopefully embodies Occam's razor, right? And then when we need to stress this always, that you should not be, for every bit you add to the complexity, you really have to have a good reason for that. You really need to limit your expressive power. And, you know, we don't live up to that ourselves, right? We always overcomplicate solutions to be able to get a paper in because it's too simple otherwise. But yeah, that's another bit. I think that I don't think any other field can show quite as clearly as us. Yeah.
But also I get that also for learners. It's a bit different, the databases course, learning about database programming in comparison to normal programming, traditional programming. Because there, when you think about, I mean, everything in computing education until now is about, okay, the program and the output. But now with databases, we also have the schema the data schema that is always also a third component in their mental models. So this on its own creates new challenges. So I don't know if we want to go there, but have you seen students finding it difficult to understand some specific concepts that you're teaching them about SQL or about data schemata, or what is it, which week is the one that you say, oh, it is this week again, that I will find it hard to make them get it? Please, Michael, I see you're laughing.
Keys. For whatever reason, they can't, I see nodding of heads on the screen. Yeah, for whatever reason, they can't seem to wrap their head around a super key or a candidate key or a primary key. I mean, they understand the general purpose of it, but they don't actually understand the difference a lot of the times. Do a comic? I've tried numerous examples and I walk through solutions and it doesn't matter. It always comes back to the same sort of series of questions. So if anybody has any good ideas, I'm happy, like I'm all ears.
Okay, anyone successful in repeating keys? I have it here. Oh yeah, maybe from yeah, if you're online. Or is there?
You were shaking your head in agreement with mine.
You don't hear the microphone, George.
I was just saying, Giovanna, you are also really in agreement, it seems, with what Michael was saying about keys. Do you have the same experience?
Yes, they love to have just this surrogate ID, and they are, at least my students don't like to reason about constraints in terms of uniqueness and understanding the impact, the semantic of identifiers. They mainly would like just to put an ID and that's it. And this is something that is not easy for me to convince them about. The importance of recognizing how entities, how objects are identified in the real world. This is something I had troubles with. I don't know. There are suggestions on that?
For me, it sounds like students are okay with understanding the data as in a spreadsheet. But then when we try to teach them something that goes a little bit deeper than that into structuring it, then it's problematic. Or is that it?
Well, I think keys is a good example of what you're saying, Fania.
Joins?
Joins would be, so actually I was thinking you were going to say foreign keys, Michael, but even just keys on a table already, keys in general, yeah.
Yeah, curious. Sorry, not to pick on you, Kathi, but like you teach that in your data-centric sort of first year course, the idea of like tables and how like spreadsheets sort of differ from databases in general, like how data is stored and how you need to like continuously use different data structures. Have you ever come across that idea or thought of how you, or might have an idea of how you might solve that problem in terms of different types of keys?
So I'll preface this with a disclaimer that I have never taken a database course nor taught a database course. So I think when you say keys, you probably have a much richer understanding of it than I do. I think the extent to which I get into some key related content in my class is we do exercises where their data exists in two tables. And for that, since we're all focused around practical motivations, we talk about, well, you're going to get some data from over this place, and this other organization is going to give you this other data table, and that we want these two data tables to come from different places, whether it's for who can manage that data or who owns the data. So we come at it from the practical standpoint of you've got data that comes from two places, and somehow we have to draw data from both of them together. I do not try to actually join the tables. I think that's too much for the group that I'm working with. Instead, we do exercises where they have to they basically go to one table, look up the key, and then go to the other table and pull something out. So we don't physically construct the join, but we do compose results across tables. And I'm using that as the starting point. And I assume that those who then later take a databases class would get that richer introduction to keys. But I do break it down to not get on the joins and just focus on how do we connect information across tables.
Microphone.
Okay, so George asked whether they have difficulty with this concept. They have difficulty around that part of the project, but my sense is that difficulty is in the coding, not in the conceptual. Like when we ask them, one of the things we do in my course is they have to write out what we call a task plan. So like, here's your overall problem, break it down into sub-problems, and they have to tell us things like, I'm going to look through the table and find this row. I'm going to grab the value out of this column. I'm going to use the value from that column. So they do all that in prose, and those they do fine on. It's when they turn that into code and they actually have to pull the value out and compose it with the other operator. That's where that's where I think mine run into some challenges. And we're working on linguistic solutions to that as well as pedagogic ones.
So I stumbled on a problem in the book I use that I have found very illuminating in trying to teach people about keys. It was a word problem. It was something like, here's a table, there's a flight number, a passenger ID, and a seat number, and maybe some other stuff. What key can you define that guarantees that each person will only have one seat on a flight? And the number of people who put flight number, passenger ID, and seat together in that key are amazing. So I would suggest some questions like that might help get at it. I certainly do them all the time now because I think it helps clear some things up.
It seems a bit strange because students coming into a database class have already done some set theory in mathematics. So how is it that they cannot understand this?
Actually, to generalize this point, I think students, this is a data course is the first time they're confronted kind of with the ramifications of not thinking clearly, right? So in particular, as you're saying, Julia, maybe declarative thinking is kind of a core part of our contribution to the curriculum. Students, I think here in this course for the first time are confronted with what goes wrong if you don't actually express yourself correctly. And as the database system is not going to fill in the blanks. It's not going to read your mind. You have to say exactly what you want and only what you want. So this kind of more generic skill of I guess it's logical specification or something like this is a challenge that my students always have.
Two comments, one to this point about they've had set theory and whatnot. One of the hardest problems in education from a research perspective is what's called transfer. And the fact that students struggle to apply something they have seen in one context into another, it's not that we're we could be teaching it better, but what you find from that literature and education is you have to teach for transfer directly. It's the rare student who's just going to see it. So I think they do need to see it in the context of courses. I have a colleague who gives the students the halting problem in the context of a programming languages course, and none of them recognize it as the halting problem. And he gives them this question and he just says, come up with a solution. And it usually takes them several days to say, but I don't think this can be solved. And he said, oh, have you ever heard of this before? Oh, no. Did you take the theory of computation course. Oh, yes. So I think we have to be aware of that aspect of it. I think to George's question about teaching precision, I think this is something where if we did more with teaching about testing and thinking about specification and not just code earlier, that would potentially help here. I have colleagues who teach property-based testing, which is basically they give students programs where there are multiple plausible correct answers. Okay, so something like if you're just going to insert into a balanced tree and it could go one way or the other way. Well, now you could get multiple answers out. How do you write a test case for that? And that comes down to thinking about properties, thinking about specifications. And those are kinds of things that we're starting in either the first or the second year, depending on where students are in the curriculum. So I think we as a general rule, we often don't give them enough practice with declarative things and non-implementation ways of thinking. And there are huge opportunities for that from intro, even if you're not doing databases in intro. And so I'm curious whether more of those approaches would help with some of these issues.
But here are all the subtle ways in which your actual query can fail. So it's like the reverse, right? I'm sorry.
For me, I'm just now just what you said about transferring knowledge from mathematics, that you're very right, it has to be made explicit. And you have to explain that this is what you already know, and this is how we're going to build on this. So does anyone start when teaching databases with what they already know?
Yeah, sense. We always do sense, no? Don't you? Yeah, I do a whole class.
I would say you've seen this before. And we're actually going to use the same syntax for it in the relational algebra, for example. Yeah, a Cartesian product. Yeah.
On the topic of relational algebra, I was debating whether or not I was going to eliminate it from the course this year. And I see people saying no, but the reason for that is because students find other things a little bit more applicable. For example, knowing about security around databases. So introducing topics like, for example, SQL injection attacks or things of that nature. I guess just a general open question, is that something you would consider replacing? If so, like, if not, why not?
Yes, Julia, you said no.
Yeah, no, I think you have to keep relational algebra and teach it before. Sometimes people teach it after, and that puzzles me always. Because then you can't explain query optimization at all, first of all. And secondly, or even just like the concept of declarative versus imperative, right? I mean, it's actually more natural for people to write relational algebra programs, right? Because there's a sequence you impose. Do you teach relational calculus? Yeah, no, I gave up on that. Yeah.
Okay, do you also add relational algebra in the exam questions then? Yes?
Me too.
Yes. Oh, I was saying in addition to also nested SQL queries they are feared. Are they feared or are they sometimes overused? Have you seen this happening?
No, I think that the fear is that the aspect that prevent them to use them at all. So they don't use nested queries because they perceive that they are not able to use them correctly.
Did you have the same experience? I remember we observed quite the opposite. We observed the students in exam exercises, they would just overuse them when they didn't need to. And we thought that maybe this comes from what they know from procedural programming, where they just group everything into functions and say, I will write a query to get this result, and then I will use it for this other query. But did any of you observe this?
I had a couple who decided to do simple queries using correlated subqueries. and they would get the right answer, but the amount of work that query did was unbelievable. And I don't know why they did that. Just had the hammer, I guess.
I worked in industry before grad school. Have you guys were? I was actually like a SQL developer and then a DBA for a while. The kinds of queries people write, you can't believe. I would casually get like 2-page long SQL queries just that needed actually like a short paragraph. So yeah, in practice, lots of people who don't take databases and maybe they didn't teach them relational algebra. That's what you end up with. So actually a fun exercise might be to ask students to debug queries. I might try that next time.
To simplify.
Just like actually give them something of the kind that I've seen, one of these just absurd. Yeah, and see what they can do. Reading SQL is just impossible, as you know, right? I mean, it's just really, yeah.
That would be a great nifty assignment for 60. Sorry, here.
I was going to say we need to ask Julia to work with us on a follow-up to our ISPC study because we did it for novices. But if Julia has experience from industry that they also do it, then
oh, that is very nice. I would love to code. The worse the programmer, the longer the query.
Real SQL queries are abominable. So, and I think education can play a large role in actually addressing this societal problem.
But okay, you already talked about assessment, and I think that I know that in programming, what we have done very often just to simplify, make our lives easier, is we have created repositories of questions for students so that we don't have to reinvent the wheel. There have also been European Union funded projects in order to help with that, just to create repositories of exam questions, for example. And then you can ask from this repository, okay, you want to test these concepts, and then you get different exam questions that you can add to your exam. What do you do when you create every 3 times a year the exam for the databases course? So how do you come up with all those different exam questions every year?
A lot of hard work and teaching assistants.
So do you actually invent new questions every year?
I ask my son is 9. I tell him like, point to something and tell me about it. Because you always need to come up with, I had lots of cocktails and I don't remember. That wasn't my son. That was my in desperation, right? But yeah, just from real world, right? Just ask somebody, not you. Yeah. I don't know, toy cars.
Choose a random topic in Wikipedia. Yeah. Like birds, birding club, trucks, you know, just any.
Yeah, I went on a Disney and Marvel sort of adventure. So I went down the spiral of like all kinds of Disney shows and Marvel shows, and that pretty much filled the last 3 years of exams.
So how come it didn't this community just agree on having a repository of questions until now? The repository of, they cannot, if the thing is that what happens is that if everyone adds their questions to the repository, then there are thousands of questions. If they practice in answering thousands of questions, then it's okay.
The questions don't work that well if they've been given before and the exams are online, right? But I think once we get out of this pandemic thing, it would be great to share questions because it's a lot of work.
The simple exam is not hard, right? Just think of anything in the world. A database can model that, right? So.
But the multiple choice was harder? Did you also have multiple
No, I'm
choice?
saying it's not that hard to come out. These particular ones are not hard to come up with. Normalization kills me every time. That's the never works out.
Okay.
Yeah, but these are, I don't know, conference rooms, anything. Just the world is out.
Okay, let me see. There is one last thing that I wanted to discuss, and it has to do with context. So in the examples that you give to students, have you noticed that context matters at all? So are they more engaged when they are when the context of the database that you give as an example is, for example, something that is familiar to them.
I'm talking a lot, but like I don't like sports. I think many girls don't like sports. Please don't give us questions about baseball. I really find it annoying, just extra annoying when you get questions about baseball, and yeah. Don't do that. Also, most non-Americans don't understand the rules of baseball. Yeah.
Yes, that's a good point. Cricket?
just cricket. Yeah.
But do you still do the hello world of databases like the student teacher? Isn't it? The example databases in most books, the employee. This is what is still being done. And did anyone do anything more creative than that? And maybe has positive experiences from that?
I'm sorry, are we on 3? What is the question?
So it is, no, it is, I think it's outside this, it's on the context of databases. So on what the domain is that you, the domain of the example databases that you give your students to work with.
Okay, so I use a book that is MySQL based, and there is a sample database with MySQL, a little bit dated because it's movies, and it assumes that the movies are sold from actual physical stores. So I have to explain DVDs and things like that to the students. But then what I do is each term there's a project on a database that I get from the government or from an internet source. And then that database becomes the foundational database for exam questions for the following year. And they, on the final, they load it and they answer questions using it.
Oh, nice. That is quite creative, more creative than the employee shopping cart.
We've done honeybees, and we've done, oh my goodness, I forget what the, they love this one, salaries by discipline and by school, immediately after graduation, mid-career, and advanced career.
Yeah, that is relevant to them, yes. Okay, good. I think we are about time. Oh, yes, we are 3:30. It's time, I think, for our next break. So, yeah, thank you all for this discussion. So I think the break is for, I don't know, half an hour, 15 minutes, half an hour. Is it a 45-minute break? Okay, so we will be back in 45 minutes for the next paper session. Yes, for the final paper session.
Thanks to all.
And it's now recording, I think. All right,
Okay.
go ahead.
Great. Well, thank you very much. Thanks to the organizers for having me here virtually at the inaugural DataEd. This is very exciting. And I've enjoyed this afternoon's keynote, and especially the discussion that I was lurking and listening to, because a lot of what we were discussing actually feeds into this presentation. And this presentation is about how we at Marist College dealt with COVID and how I took that experience and my part of that experience and used it in my database systems class. So Marist College is in New York. You can see the leafy green trees behind me here in the lovely Hudson Valley. We're about 60 miles north of New York City, just up the river. And when COVID became our problem in late 2019, but in the summer of 2020, before we began our first full semester, it presented challenges for all of us, to say the least. I mean, it's complex, it's difficult, it's time consuming, and something we critically absolutely have to get right. But the good news is that I kind of turned it into a fun project and a motivating example for my coursework. And so my plan was to deal with COVID was we had to generate representative samples from our community so we could do testing. So we had to track testing invitations, we had to track test responses, test results. And this was all in the service of doing pooled surveillance testing, which I'll tell you about briefly in a moment. And then my additional goal was to make use of all this in our second year database systems class. It's a class required by our computer science and information technology majors. Cybersecurity students take it rather. They'd like to teach it, but I have too much fun teaching it, so I'm not giving it to them. So pretty much everyone takes this in their second year. But before I can tell you what we did, we have to look back from the summer of 2020 to the summer of 1941, because back then, two Army economists, Robert Dorfman and David Rosenblatt, worked out a way to test draft candidates or Army candidates who had been drafted for syphilis, because I guess if you had syphilis, you couldn't serve in the Army. And so they worked out this idea of pooled testing, wherein if you combine biomarkers, which is nothing more glamorous than just putting a bunch of different spit samples together in the same test tube and swirling it together, that you could test that sample. And if it came out negative, meaning no syphilis, or in our case, no COVID, then however many you combined, you can assert we're testing negative with just one test. So it's a way of minimizing tests. And as soon as I read about this, and this is in fact the strategy we used at Marist College, I thought, well, okay, clearly this is a binary tree. It's going to look like an index in a database. I thought about it also for my algorithms classes. And that was my inspiration for how we can use this as a tool to motivate some computer science stuff. And I actually used it in operating systems courses and in algorithms courses. But today, I'm going to tell you what I did in my database course. So in our database course, we use Postgres. Well, when I teach it, I use Postgres. I absolutely love Postgres for all kinds of reasons that I'm sure many of us share. And so I actually built this database. I built it for Marist College and we used it. And so when I was teaching this to my students, it wasn't an abstract because they had all been invited for testing and had to spit into their own test tubes as the result of this database and this code that I wrote. So it was all very real to them in a visceral way. And so I wanted to teach various topics in database and SQL and design topics and a little bit on stored procedures. So one of the first things I showed them when we were talking about database design was what the people table would look like. And it's I think, a pretty nice illustration. It's a strong entity. It's got a name as a plural noun. We've got a bunch of data in there that actually could be split into subtypes because we're taking data for both students and employees. And so there's an is-a relationship there. I could say a student is a person, an employee is a person. And of course, all successful software grows with the enterprise it serves. So we had to add some additional fields later so I could show them the ins and outs of alter table and those kind of things. So this was a nice example to talk about database design, some normalization issues, and specifically entity subtypes. Then, of course, the main part of this was teaching them SQL and queries and views and subqueries. So one of the first things I showed them was just this simple query up here, on-campus CS majors, computer science majors. And later in the semester, when we got to talking about views, I pointed out that, we could make a view of on-campus students defined here in the middle of this slide. And then just we could rewrite our query using that view to get the same output as we did from the first one. And that went over really well. At first, I convinced the students it was a little bit of magic, but then I showed them the system catalog. So we looked up through information schema and in PG catalog, I always show them both. I showed them where the view definitions are stored. And that was the way we got into talking about all the cool stuff that's in the system catalog. Then we could get into aggregates and subqueries. And I know subqueries generate some strong feelings from what we heard in the discussion. And so I showed them some examples of counting students, with group by is student, group by is employee. In this case, students who are also employees. And then I showed them an example where we were going to total the people that we counted by dorm building and floor, because that's actually how we clustered the students to invite them for testing. And so we get some subqueries in here along with some aggregates. And once they can understand this kind of thing and do it in their labs, then they're getting a pretty good feeling for SQL. I would say just about good enough to jump into joins. One of the things I like to do when talking about joins is show them some subqueries and then some joins that do the same thing to illustrate, how there's always more than one way to get to that particular answer. And so for showing them joins, we joined the people table and the dorms table together, because again, that's how we were choosing our representative samples to cluster the students. And nulls, it's always interesting to talk about nulls. And Postgres annoys me because it doesn't give you warnings if you use equal null, although you just get nothing, which is wrong, because we really need to use is null. And I wish Postgres could learn from SQL Server and give us a warning. You might note down here, there's a custom function, and I use that to get to segue from strictly SQL into some programming. And so this is a function that we used for generating the invoices so that order by would work nicely, so that Monday comes before Tuesday, before Wednesday, and so on and so forth. Once I showed them this function, then we could get into stored procedures. So this is a stored procedure that I wrote and that we used that would actually generate invoices every week for the representative samples by cluster. And in here, as I showed them this, I could talk about distinct selections, the use of limits, some more complex where clauses than we had seen before, and how they can apply what they've learned in their programming classes, like the structure of declaring the variables up top, nested loops, all that kind of stuff. Show them how that can be put together inside the database, stored in the system catalog, and so on. And then the last thing was sharing with them some of the queries, but none of the data, but some of the queries I used for looking at the results. So I was one of 3 people on campus who could actually see the test results. And I ran all kinds of queries for our administration and our health services people, most of which dealt with joining our data that I had generated and used for the invites with data back from the labs that were doing the pooled testing. And of course, lots of date math. So it's a nice illustration of the between operator. And again, we're doing aggregates here. And we can these queries actually could be used to calculate our infection rate, which was hugely important because we didn't want New York State to shut us down, which they never did. And so it was an annoying 2 semesters. COVID wasn't fun for anyone, but I was able to turn it into some good examples that went over pretty well in my database class. All of the stuff I just showed you is on GitHub at this link here in the center of your screen, COVID in the classroom. And so I welcome all of you to take it and mess with it. And if you when you improve it, please let me know so that I can make it even better the next time I use it. And we have 5 minutes for questions. Hit me.
Awesome. Thank you so much, Alan. You cannot see it, but we have a small crowd here in the room as well. Are there any questions? Oh, I see Alan, other Alan has raised his hand. Maybe you want to ask.
We're bookended by Alan's, which I like that the organizers did. Well, the alpha and the omega, us too.
Thanks very much for a really interesting example of making databases real. I was wondering, did you look at security issues with this example? Because I mean, you already mentioned that certain people could see stuff, certain people couldn't see stuff. I mean, there's a lot of potential there. I was wondering if you'd thought about how to teach those concepts in this setting.
That's a terrific question. The answer is not as much as I wanted to. So I talked a bit about how we might go about anonymizing data. So because, what the students want to know is, oh, well, what is the response rate or what is the positivity rate and so on. And I simply told them that, these are the structures, but I'm not going to, it would be a violation of all kinds of stuff, show them real data. And so I use that to talk a little bit about the PG crypto plugin to Postgres and some anonymization stuff, but frankly, not very much. That would be a good enhancement. Might require another week or two in the semester, but it certainly fits with this topic.
Thanks.
All right. Oh, I see a question here in the room.
Did you also talk about how to write the queries efficiently? So if the data size is large, then some things like maybe a correlated query would be slower.
Yeah, so I'm glad I left the screen sharing up. Yeah, so something like this query, we've got joins and group bys and order bys. We talked a bit about query optimization, and I do an entire double session, so 3 hours on indexes, on clustered indexes, on logical indexes, and clustered indexes gets us into performance characteristics that overlap with our algorithms class. So we can talk about binary search, big O of log to the base 2 of n, those kind of things. So the performance I talked about was mainly in the use of indexes, less so about query optimization. For example, we didn't take these and translate them into relational algebra and do any of that, although that would also be fun. Maybe it needs to be a 2-semester class. Now I think we're on to something.
Thank you.
Thanks for the question.
All right, I'll come back to the camera. So I also have a question, it's maybe not very technical, but I've noticed in the courses I assist in that students are really done with any examples and data that has to do with COVID. Did you notice any of this?
Oh, that's really fascinating. No, actually, so remember, so this was a year ago and a year and a half ago. So we were still deep in it. But I had just the opposite response. I have a student, and actually I ended up putting this on my report, my self-evaluation to my dean. So a student emailed me and said, thank you for doing this in class rather than just trying to pretend that everything was okay. I enjoyed really leaning into it. And so I took that as a positive thing. Now, if I go do this again next semester when things are much more normal, I don't know, but they were happy to acknowledge it, because this was half online, it was in person, the other half, we were all behind masks. And so we were leaning into it, and it seemed to go pretty well.
All right, yeah, I guess the timing does make a difference maybe. I have to see if you try it again this semester.
Yeah, well, I'll tell you next year.
All right, great. I think, yes, it's basically time for our next speaker. So Ellen, if you could stop sharing.
I will do that. Thank you, everybody.
Oh, and thank you again, Ellen, of course. Our next speaker is Sophia, yeah?
Yes. Let me share my
Sharing your screen, yes.
Share, and then play from the start. Are you able to see the entire screen? I'm not sure if the Zoom covered parts of it.
I think it works perfectly. It looks very good. All right, so Sophia is going to tell us about analyzing student SQL solutions. So please take it away.
Yep. So hello, everyone. I'm very happy and honored to be here today. My name is Sophia Yang, and I'm a PhD student at the University of Illinois at Urbana-Champaign. The paper I'll be presenting today is titled Analyzing Student SQL Solutions via Hierarchical Clustering and Sequence Alignment Scores. And I would like to acknowledge and thank my advisors, colleagues, and co-authors for their support with this work, Professor Herman and Professor Alawini, who was here earlier today. I would also like to thank the National Science Foundation grant for supporting this work. So to examine how students learn SQL, database instructors often manually analyze student submissions to a given SQL problem. However, given the importance of SQL and the scale size of database classes nowadays, it becomes very challenging for instructors to practically analyze that many submission attempts by students in order to see the areas that students are struggling with. Instructors can then, I guess, lose a lot of valuable insights that could be extracted by this existing data, especially with instructors who utilize auto-grading with their SQL assignments. So our research questions are then, first, how do students learn SQL and come up with their final solution to an SQL problem? And second, how can we empower database instructors to deliver SQL concepts more effectively, adapting to the diverse student population? So we build our research work upon the foundations of other researchers with a few of the related authors listed here. In terms of where we collect our data, we collect our data from the CS411 database systems course offered at the University of Illinois at Urbana-Champaign, which uses PrairieLearn for its SQL assignments. And PrairieLearn has auto-grading features, which gives us the opportunity to trace students' attempts at solving SQL problems. The figure on the right is a snapshot of what an SQL problem in PrairieLearn looks like, and some background about the course. So we see an average of just over 400 students and enrollments each semester with a week-long SQL homework assignment containing approximately 15 of these problems given to students with varying levels of difficulty. And then this course is mainly available to upper-level undergraduates and graduate students. So on the computation side, we use the global sequence alignment algorithm to compute an alignment score between each student submission for each of the given homework problems. And this is to reveal similarities between any of the students' earlier submissions and their later submissions to trace any changes in their approaches at tackling an SQL problem. So to improve the accuracy of this comparison, we tokenize the students' SQL submissions by their functional keywords using the SQL parse library. Typically, the sequence alignment algorithm compares two sequences from end to end and letter by letter. However, since some keywords can contain like more letters than others, but their weight should be technically equivalent amongst the other keywords, we defined our alignment dictionary with these keywords so that each of them would have the same weight towards the scoring matrix. The figure below is an example of two submission sequences being compared with a scoring matrix of +3 for matches and -1 for mismatches or gaps. We've worked with various types of sequence alignment algorithms, such as the local and fitting alignment algorithms, as well as various scoring matrices to optimize for extracting insights through our visualizations. And I guess we found the global sequence alignment algorithm with the given scoring matrices optimal for now. So one type of such visualization that I mentioned is like a line chart shown here. So this is a line chart displaying all of the alignment scores between each submission with the student's final submission. So for each student and each problem, we would have one of these line chart visualizations showcasing the student's progress at solving the SQL problem, with the major changes being shown in the large jumps and dips here, because those would basically showcase larger changes in their submission. Another type of visualization is the dendrogram created through hierarchical clustering. So here on the slide, I've shown the resulting dendrogram from clustering all of the students' initial submission on top, and the bottom visualization is all the students' final submission. From the differences between the two, we can see that the number of different approaches started out to be vast, as students think differently at first, and then later, as the students successfully solve the SQL problem, the number of approaches start converging. The diagram is also able to classify whose submissions are close to each other based on the alignment scores. So while each of the visualizations shown earlier might be insightful or helpful for instructors, there's definitely more work to do to close the gap and make this like a more usable tool. So in terms of future work, we plan to build upon what we have, but ultimately building it into a system or interactive tool for instructors with a few designated features. So these features might include recommendations for instructors by extracting and clustering the insights from the visualizations shown earlier. So more actionable items can be directly given to instructors without them having to dig through all of these visualizations. But these visualizations would be here for them ultimately when they need it. It could also include concept areas students need more support on that needs to be more targeted through lectures and instruction, or whether some submissions were exact copies of each other to enable plagiarism detection. Or maybe even a Sankey diagram that could showcase basically all of the clustering between the initial and final submissions, like the dendrogram that we saw, but all in one visualization. So any questions?
All right, thank you, Sophia. Are there any questions in the audience, online or in person? All right. So I have a question. You didn't mention it in your presentation, but I read in your paper that you made this formula for the alignment, where if there was a similarity, it was +3 points, and if there was a difference, it was -1 point. Is that correct? Can you
Yes.
elaborate maybe a little bit on that?
Yeah, so I guess, did you want me to elaborate more on why I chose those certain numbers, or?
Yes. Yeah.
Okay. Yeah. So I basically did a test using various types of these visualizations and creating these graphs to validate, I guess, which scoring matrices would work best. So I tried various scoring matrices, such as the classic +1, -1 for matches and mismatches, +3, -3, +5, -5, or you name it, I guess, various scoring matrices. And ultimately, the +3, -1 gave us the most clear visualizations without having too much noise in our data and giving the right amount of weights. I guess that could vary if we change this to some other application, or depending on what kind of visualizations we are creating. And it could also differ, I guess, if we use the same type of sequence alignment to other database languages, such as MongoDB or Neo4j. But specifically for SQL and for our visualization purposes, we did find that +3, -1 gave us just the right amount of insights with clear visualizations and not much noise.
All right, thank you. I see Ellen has a question.
Thanks very much. I was wondering, did you explore the sort of difference between syntactic variations and semantic ones? I mean, classic example, a from table 1, table 2, or from table 2, table 1 is not nearly as important as, a difference between X equals Y and X less than Y, even though in terms of the actual syntax, it's hard to tell that. Is there any way of getting at it semantically?
Yes. So with the SQL parse library, it does allow you to parse through the semantics. We just primarily went through the semantic ones, which are more keyword based, versus the syntactical ones. For the syntactical ones, I guess we just wouldn't parse it. We would give equal weight to all of the keywords and then just align the entire sequence without extracting any of the syntax, because we did extract the syntax before like any white space or comments. We did extract those before we performed the sequence alignment. But I guess if we did want to see all of the syntax, or even just the syntax alone, we could pull that using the SQL parse library and then putting it through this alignment algorithm.
Thank you.
Thank you.
Yes, we have another question in the room.
So when you have students whose solutions aren't aligned with the instructor solution, there's a couple of possibilities. One is they're just wrong, and the other is they're partially correct, but they're not done yet because they got sampled in the process of building something like this. So do you think the analysis you're doing could help you uncover the trajectories that students are taking through going from their initial attempt through the solution, or is it just kind of a right and wrong classification that you're doing?
So we are more interested in the trajectory, because actually there would be multiple correct solutions other than the instructor solution. So based on how PrairieLearn works, the instructor solution generates a large solution data set that we would compare the students' SQL query and their generated data set to see if the two data sets match. So I guess technically speaking, there could be many different correct solutions to a given problem. So I guess that's why we're more interested in the trajectory instead of the correct, right, and wrong. Because even when we're teaching SQL, there could be many other ways that we're not aware of, or many other different approaches that we could be using to simplify the process of writing a SQL query that we could be teaching. And this would be one of the efforts that we could use to uncover different approaches that students are using, and we think would be good to teach other students as well.
All right. So I think maybe a question that tags on to what Alan was asking about semantics. So it seems likely to me that it could be the case that there are two different approaches for the same student that lead to the same alignment score, but they are very different queries.
Yes.
Do you have any suggestions as to how you could distinguish between those? Because in your plots, it's not possible to see this, right?
So I guess to distinguish two very different approaches would be a higher gap in the sequence alignment score, because the difference, or a lower sequence alignment score, would indicate that there are a lot of mismatches or dissimilarities between the two. We also used local and fitting alignment sequence alignment algorithms to define and see if any of the earlier parts of the query belong to parts of the later queries, because then it wouldn't be an end-to-end comparison. It would be like a subsequence or substring comparison to the, like a part to whole comparison.
All right, thanks. Were there any more questions? I don't think so. Okay, so let's thank Sophia again.
Thank you. And thank you for the questions.
All right, thank you. And I think our next speaker is Joe Hellerstein. Is he here? Yes, there he is.
Oh.
Hello.
Hello. Okay, I'll get my slides going. Hopefully that's showing up correctly for everyone.
Yeah, that looks great.
Okay.
So Joe will talk about how they do data engineering education at Berkeley. Please take it away.
Thanks. So, excuse me. So Berkeley's been on a, I actually don't know what's going on here. Okay, this is fine. Berkeley's been on a trajectory of developing just an enormous data science program over the last about 7 years. This began with a course called Data-8 in 2015. Data-8 actually has had quite a bit of impact. I wasn't involved in it, so I'm not bragging about me in any way, but it's been adopted and adapted at dozens of other schools. It's there's a very popular MOOC and an online textbook. And this is a first course in data science, Python-based, very focused on people getting an empirical sense of data through using techniques like bootstrapping and histogramming to just experimentally see what's going on in their data and to understand the basic ideas behind statistics and probability. In 2016, though, a year later, we announced that we were going to actually have a division of data science, and we were going to start to build a campus presence around the topic. By 2018, we had a data science major at Berkeley. 2 years ago, we received the largest gift in Berkeley's history for a new building focused on computing, data science, and society. And in the last year, we've begun the process of having that Computing, Data Science, and Society organization, CDSS, become a college. And so what's going to happen is we'll have a college which is at the same level as the College of Engineering or the College of Letters and Sciences. That's for computing, data science, and society. So this is a very substantial deal at a major university because it's a huge campus. And what we're seeing is enormous numbers of students gravitating to data science as a profession and a major. So it's really been quite exciting to watch and be a part of. I've designed a couple of the classes and been involved in some of the politics, not too much of it. This is a typical data science class, Data-8 class at Berkeley. It's held in the concert hall. This past year, we graduated our first batch of data science students, 695 majors, 345 minors. This is a major that didn't exist 5 years ago. And then in the incoming class this past year, 3,000 students took Data-8. This is this picture you're seeing. So this is really happening at scale, and the large majority of these students are going into the tech industry here in the States. Many of them stay in California, which is sort of the center of things. And so the impact of this program is actually quite substantial on the industry. Now, the program's background, it was founded by faculty mostly in statistics and AI. There were really only a couple of us in applied computer science at the beginning, kind of putting our noses into things. And you can see the article they wrote about it for Harvard Data Science Review on the right. This is how they think about data science, interleaving computational and inferential thinking. I don't think that's how most of us trained in the database community would think about the work of what people do in industry with data. So it's interesting like how strongly this is rotated around inference and mathematics and statistics. Part of the reason for that, and I will take some blame for that, is I didn't really raise my hand much in the early days. I was the only Berkeley faculty member in databases at the time. And for any critique I might bring up, I didn't have the time to back it up with action. And I wasn't going to stand around criticizing people doing good work without being able to contribute myself. And so I kept a relatively low profile at the beginnings of this program. And basically what I'm talking about today is our efforts to retrofit now some more data engineering into this program, which is very welcomed by my colleagues. Meanwhile, while this program was going on, industry was still struggling with skill sets. You would read about the need for data engineering. And so, and I've stolen this from Aditya, there are these blog posts that he found. One of them says, you need 3 times as many data engineers in your organization as you need data scientists. Another blog post says you need 5 times as many data engineers as you need data scientists. Yet another one says 10 times. And then there's at least one that says, all of data science is basically data engineering. So you just basically need data engineers. So we were responding in some sense to what industry was asking for. And I think it's very pragmatic. I would think many people at a conference like SIGMOD would agree. And we need to step up to the educational opportunity. My colleagues in AI, of whom there are very many, so it's not fair, but there are many of them who are working hard on this pedagogy. And I think our community has lots to offer, and there's a lot of need for our skills. I'm happy to say that since the time this got started, we've been on a hiring spree of sorts with a really exciting group of young, diverse faculty who work in areas in databases and around databases. So I've got a lot more help now than I used to, which is super. And then a bunch of us have been fighting this fight in industry. So, I started a company called Trifacta, which was all about data engineering, data preparation, data cleaning. My colleague Jan Stojka started Databricks, which is a broad platform for working with data. Joey Gonzalez had Turi, which was a machine learning platform. Aditya just started a company around Python pandas called Ponder. So we've been talking to customers and seeing use cases in the field as well. So a lot of what we're doing is informed by our experience with real use cases in the world. And so we felt, in the last 2 years that the time had come for us to give back and contribute a class on this front. So Aditya was the first mover on this. He's actually faculty in our information school as well as the CS department. So he taught a master's level course in the iSchool 2 years ago. And then last year, he and I ganged up and ported it and adapted it to something more appropriate for Berkeley undergrads in computer science as well as data science. And we kept the MS students in there as well from the iSchool. So the first decision we had to make, and it's really the first decision that's made in a lot of shops in industry around data, is this going to be SQL centric, or is it going to be based on the sort of Java oriented big data stack of the last 10, 20 years? And it was easier for us, obviously, to port material from the database class in SQL, but we also felt it was the right choice. And here are some of the reasons. One is that our students typically get a lot of experience in Python and to some degree in Java. If they're computer science students, they get experience in Java as well. So they've seen imperative programming, and seeing declarative languages like SQL is a nice additional skill at this stage of their pedagogy. From an industry perspective, what we were seeing uniformly, except maybe in Aditya's company, which is Pandas centric, but the rest of us are seeing a lot of SQL out in the field. So Databricks has publicly said that their use cases are majority SQL, not Spark. And Trifacta also, which was basically built on the big data stack, ported very aggressively to SQL over the last years due to customer demand. And if you've been following the tech press, and there's just so much buzz around the new data stack, which is all SQL stuff. All right, and so the rise of companies like Snowflake and the SQL offerings from Databricks, and then of course the major vendors like Amazon, Microsoft, and Google have made SQL extremely relevant again. The last thing I'd point out is, you can teach a library like Spark or Pandas, but they don't port very nicely. Pandas, for example, has 600 API calls. They're all very fussy, and they're nothing like what you'd see in another language. SQL, at least at its core, is pretty similar across different environments. And so portability is a nice attraction as well. So I don't want to talk through the entire syllabus, but we did a bunch of SQL for data engineers, and I'll talk a bit about that. We spent some time talking about data models. What are they? our data science majors are rather mathematical, and they get a lot of math along the way, or at least stats. And we wanted to make sure they understood that, like, representing data is its own branch of mathematics, and it has some depth, and there's important, fateful, practical decisions made there as well. Aditya was really eager to cover a bunch of different data models. So he went and taught them MongoDB with semi-structured. He showed them spreadsheets. He looked at Neo4j with graphs. We looked at ontologies and BI. So we did a bunch of sort of data modeling in addition, but those were all sort of by example. The core data models we looked at in a little more detail. And then we spent quite a bit of time on data prep and data cleaning. And this is partly a bias based on my industry experience, but you hear over and over that that's what people spend their time doing in the field. And a nice thing about it is, especially in a SQL-oriented course, this guides what SQL you should teach. So they're not asking queries about employees and departments. They're doing things like, moving cells around in tables and filling in nulls with imputed values, and trying to do string matching for entity resolution. And we have to teach all that in SQL. And teaching the difference between flavors of outer join is actually less relevant. And the sort of things that we tend to teach first in the database class are less relevant. So when you think of teaching this stuff through the lens of data transformation, the data prep and data cleaning, you kind of come at things a little differently. So that was a sort of locus of idea generation for us building the class. Towards the back end of the class, we started looking at, of course, we did a little normalization in ER. We taught them about transactions enough so they know what they were. But then we started focusing on data pipelines and sort of testing and continuous integration, stuff about making data pipelines robust over time. And we leaned on the DBT tool to teach that. And I think that was pretty successful. We want to do more of that in the future. And we had some additional topics towards the end on approximation, on storage formats, on scaling, and on security and privacy. So this is a flavor of it. I want to spend a little time on what I meant by SQL for data engineering. So this is kind of the order of tasks that we did. And I'm realizing I don't have a clock in front of me, so I need to watch the time. And I don't know how to do that. That's interesting. I will go out of full screen to look at the time for a minute, just to pace myself. Okay, doing good. So this is a 15-minute slot, right? So just have about 5 more minutes left.
Yeah, you're good.
Okay, great. So in the SQL front, we start with the simple stuff, select, project, and then we teach aggregates right away, because this is kind of what you do with a data set. Typically in data science classes, you start with a single data set and you do Python on it. So we just wanted to get them comfortable with SQL doing what they would have done in Python and Pandas. And that's pretty much select, project, aggregate. And then the next thing you want to teach them is how to wrap up these aggregates in these little queries and functions, right? Or in some sort of modularity. So that's what common table expressions are. So we do that very, very early, probably earlier than in our traditional database class. And then we spend time on regular expressions. I mean, you could teach them in any language. We happen to be in a SQL environment, but string manipulation, especially with data transformation, is very common. And so this is a place where we wanted to spend some time, and so we did. And then extensibility, being able to write user-defined functions in Python, which they already know, and then plug them into their SQL queries. And emphasizing the idea of SQL as a compute framework, right? It's a sort of open box. You can add your code to it. It does things like scan tables and do filtering and do producing of new values from old values. And you can plug in whatever Python you like to do that. And to me, this was an important message for students who'd come from the Python world, that we're not taking away power from them. We're just giving them a different framework in which to do their work. The next thing that comes up that's hard is window queries. And this I don't think I've ever taught in my undergrad database class, but I needed it multiple times for data transformation use cases in this class. Data imputation is a simple one. If you want to fill down the values through the nulls in a column, for example, that's a window query. And if you want to do it more intelligently, like actually do some sort of a linear regression between points, it gets to be fancy window queries. So we had to go through window queries, and they're tricky. And then finally, of course, we did, of course, teach joins, but it was much less of a focus than it would have been in a relational database class. All of our lectures involved live demos. I think there was no lecture that didn't involve code or a GUI in action. We did, of course, teach concepts in math too. Our students in the data science major really do both. So they have learned a fair bit of statistics and math, but they really are tool oriented. So this is a list of all the tools that came up. So Jupyter Notebooks, obviously, spreadsheets, dbeaver is just a query tool. QuickDBD is an ER diagram tool that we found. Trifacta is a visual data cleaning tool. DBT is a SQL-oriented text-based programmer data cleaning tool. And we tried to emphasize that those are both valid sort of user experiences, and different people with different skill sets would prefer one over the other, and that they have benefits one over the other. And so we showed them both. And then on the data modeling front, we spent most of our time, like the previous speaker, in PostgreSQL. But we did do a homework in MongoDB and at least showed them Neo4j as well. So they got to see some other databases besides relational databases. And so, you know, in my ambitions, I have a whole mini lecture to give today, but of course that's not practical given the time. So I'm going to skip through the mini lecture and just kind of jump to takeaways, I guess, and do questions. So I encourage you to look at the paper for some of that material. The takeaways I would have is that data engineering is a really important topic to complement data science. And if your institute is offering data science classes, think about how what we know about data engineering can be mapped to their needs. The AI stat-centric curricula in most data science majors are, in my opinion, far too narrow and not serving the industry in the ways that those blog posts talked about. You can translate some things from your classical database class, but there really are pretty big changes we made in focus because data science is about data. They're much less interested in learning how a system works or how the computation of things works. They're interested in the data, and data comes, as you know, with weird shapes sometimes. Sometimes the content of the data is messed up, and often the data is very diverse. Those are the hard things in data engineering, or many of them, and that's not what we usually teach in SQL. And so this is really a lot around transformation-oriented tasks. And if you're teaching them SQL, it's to teach them how to find problems in the data and transform the data into another form. And then, of course, a piece of this is this robustness of pipelines. And to borrow or to steal a phrase from this Google paper, you can think of this as data science integrated over time is the way to think of data engineering. We have to pick one language or model to center on. We picked SQL. You could have picked Java, I think, and used things like Spark. We also, however, after that center, exposed a wide diversity of tools, as you saw, and with developer-centric and end-user-centric tools both. And we, Aditya and I, both like to emphasize the importance of visual tools. And so we really did make much of, trying to debunk the idea that real data scientists are hacking Python and Jupyter notebooks all day. No, business intelligence tools are really useful. Visual tools for data profiling and cleaning are really useful. Spreadsheets are really useful. Don't think that your excellence is based on how little you look at pictures, right? So we tried to get that across. I would say where I'd like to see the course grow at this point is better material on governance, trust, and responsible use. Julia's keynote was certainly inspiring, something I've been wanting to add to the class. And then we expressly didn't spend time on tooling for the machine learning lifecycle, in part because that space is evolving rapidly. We have 2 or 3 startup companies in our research group in that space. So it's just changing really quickly. But it would be good to address it over time and how it overlaps and differs from the other kinds of things we do. Okay, and with that, I'll stop.
All right, thank you, Alan. I'm sorry, Joe.
One of the non-Alans.
We have too many Allens in this session, I guess. I think we have time for one quick question. Fenia, yeah.
Oh, hi, I'm Fenia Ivaloglu. I really enjoyed your talk. It was really nice to see how this is taught at Berkeley. I was really wondering, how did you manage to scale it to 3,000 students? So how do you do assessment, for example, or if there are any projects involved?
Yeah, we always have projects, and they're usually programming projects that are auto-graded. Almost all our computer science classes are this big at Berkeley now. And so we've become quite good at scaling classes. I would say the key, and people have written about this, I could probably find you a pointer, but the key is, what is a scalable resource of teaching that matches the scaling of the students? And the answer to that was undergraduates. The only thing that scales with the number of undergraduates is more undergraduates. And so we have a long pipeline of undergraduate TAs who form a sub-community in our computer science department. And so for a typical class with 1,000, 2,000 students, you'll have as many as 100 TAs. It's a huge management task, but this course has become very structured over time. And the students take enormous responsibility for the material. They're amazing. And that cohort of students is a great pleasure. They're quite exceptional. But it is a lot of the day-to-day material, the teaching, the notes. They turn them into textbooks over the years. comes from undergrads who are really superb.
All right. Thank you again, Joe. Yes. No, that's a clapping emoji. Yes. Other Alan, you may take the floor if you want to share your screen.
Hi, thanks very much. I will just aim to do the screen share. Please let me know if you can see the title. Can you see it?
Yeah.
And
yeah.
advancing, great. Okay.
It is working. All right.
Thank you.
Yeah, go ahead.
Thanks, everyone. So my talk, in fact, connects a lot with some of the ideas or spirit behind Joe's talk, though at a very different part of the curriculum, and with, in many ways, a reverse focus. So the starting point is, we come from the database community, so our focus is on database management systems, but a lot of data science work still doesn't have their data in a data management unified platform through which all access occurs. There are still lots of projects, especially the sorts of not huge industry projects, but the projects being done by small teams of scientists in their research, where the data is kept in a bunch of files lying around. There are people who have their files just on their laptop. There are people who have files in the cloud. There are people who have files in an organizational shared server of some sort. And when you've got the data in files, you have, Jupyter notebooks and Python programs and spreadsheets, all sorts of things to access that data. And so the question I want to put is, what is the appropriate things to teach students so that they will be able to work effectively in projects that are of this sort? And the top level message here is that the concepts that we teach and have developed over the years in database management and database management education can still be applied, but you have to tweak the lens in a number of ways. So this is not sort of a new idea. Data management concepts are part of the standard ACM curriculum in data science. And it's agreed that students should learn this. Now, most of the curricula that I've seen teach data science students something about data management by funneling them into a standard database class. What Joe's described of a separate class on data engineering for the data science students still seems to be quite uncommon. And so if you've got a traditional class, it's usually centered on data in a relational database management system. Sometimes for the new needs, people start adding in coverage of a number of different platforms. But the data management still comes from this worldview that says we have a bottleneck through which the access goes, and that platform, the management platform, can provide a lot of the functionality that helps with the management of data. So the proposal I'm putting is to teach directly concepts of data management, the things that students need to try to do, essentially establishing the goals, which we have learnt about in the database education, and teaching students how to do that in a world where they don't have a platform that provides this functionality, this capability. Instead, they're going to have to use workarounds, do things either through administrative processes or particular tools they've written themselves. And so that's the sort of starting place for this. I'm just going to take a couple of minutes for some examples that we've used. So one concept which is really important when one's doing a database class is the idea of metadata. We believe that this is something that students need to think about a lot when they have data in files. You know, there is still metadata that needs to be kept and looked after. You need to know, you know, what the schema of your data is, what the representations are. You need to pay a lot of attention in the world where data is stuck in files to the provenance of that data. And so we sort of try to articulate to students that this information about their data sets is really important, and that they have a responsibility to try to manage that metadata, thinking about where to keep it, how to keep it aligned and up to date as the data changes and so on. And so essentially the concept comes from what you'd find in a DBMS class, but there's a lot more responsibility now on the data owners to do things properly, to be aware that they need to do it, and then to know some techniques for doing it. Second example is security. Again, you know, in a database management system, you have a lot of security mechanisms which are there in the platform. We teach, you know, views and granting permission and all of that sort of thing. When your data is in files stored around, you need to use what you can get. Now, very often that's file level permissions, you know, that are provided by the operating system. If your data is in the cloud, there is some more sophisticated sharing, but still at the file level provided by the cloud. When the data is stored on people's laptops, you really have issues because usually their data is shared by somebody sticking it in an email and passing it around. And so you've got a lot of issues of personal responsibility. Again, our focus is on having students understand the goals that they need to meet, and then learning a number of mechanisms or techniques or even mindsets that can help them. And so those are just two examples. So I've put this material into a class I developed and now taught for 4 years at the University of Sydney. It's one of 2 subjects students take in their first year as when they're beginning the data science major, but it's also taken by a lot of other students as well. We have, you know, up to around 800 students per year taking this. Now, I've got to stress, data management is only about 1/3 of this subject. In this subject, we also teach them Python programming, we teach them charting concepts and machine learning concepts and so on. And we very explicitly made the decision not to cover SQL or the use of a database management system as a platform in this subject. It is, of course, done in our curriculum in a later subject, specialized for the data science class. So we don't just send them to the standard computer science one. There are a number of papers that we've published on this in the computing education literature, and I'd urge you to have a look at those to get some more insights into our larger structure. I wanted to use the last couple of minutes here just to say what we've learned from doing this. So we certainly have been able to teach students some facts. You know, if you ask them a recall style question on the exam, you know, they know the terminology. What we've so far not succeeded with well is getting them to actually take up these practices in their own project work. So, you know, this class has a project done in stages where they acquire some data and do some reporting and analysis on that data, and then build some predictive models with that data. And as they're working through that, what we're seeing is that the things we teach them about the concepts of data management don't typically actually get put into practice. One example, you know, we put a huge stress on the importance of documenting metadata, and that's done very poorly. I mean, provenance, we've told them how important it is, but they don't typically record it very well. Integrity aspects of the data structures and schemas, they're usually very sloppy about documenting any of those things. So we're not saying we know how to do this. I'm saying it's important that we try to do this. This is what we have done so far. I encourage everybody to take these ideas and see what you can do in your own experiences. And so with that, I suggest take my last minute for an advertisement. So I'm one of the general co-chairs for VLDB, which will be in Sydney, in a wonderful place. Registration is now open. I've posted in the SIGMOD general Slack about that. We're hoping to have a number of activities where, groups with a common interest can get together, for example, over lunch, and the data educators would be a great thing to have as an interest group. So with that, I will perhaps take questions.
Thank you so much. Good advertisement opportunity. Are there any questions? I have one, actually. So you were talking about teaching students to report on metadata. And I was wondering, do you give them like templates to do this, or like a standard way, or?
No, so we have a standard set of things they need to talk about, but we don't say you have to do it in a particular way. So, I mean, one of the things is there's a lot of variety. I mean, sometimes you put it in the header of the file, sometimes you have a separate README file. So we don't enforce any standard structure. We say you have to say, where you got the data from in enough detail that somebody could actually go and check by getting the data again, whatever. We say you have to show any transformations or cleaning you did to the data and document that, so that, we put this in the data quality and reproducibility sort of story.
So do you think it would help for them to do it more consistently if there was more of a solid way to do it, or? Because that's my feeling.
Look, it's a possibility. I mean, my sense is that there isn't a standard way in industry, and and in these projects. Maybe it would help. I mean, I have not done well with getting them to actually do it. Even though, in our big project assignment, the first part on data gathering, there are, several points out of the semester just for, did you document your metadata? And they do quite badly on that.
All right. Yes, Joe has a question.
Yeah, it's a related question, which is, were there any tools that you adopted to try to encourage these behaviors? And if not, can you envision that maybe we as a community could be building such tools? What would they look like?
Okay, so look, thanks. We didn't do any tooling. It would be wonderful if there was something that we could do. I mean, maybe the first thing is to try with the simple template for describing metadata, and even if it's not used elsewhere, maybe we can start a trend, start putting that out in terms of just documenting what's going on. So yeah, look, I'd love to see more things that we could use.
There are, open source things. I won't go so far as to call them solutions for metadata tracking. There's a project called Open Lineage, and then there's a variety of metadata open source projects that have come out of the big tech companies that are, maybe worth looking at, Data Hub and the like. But I think they're kind of heavyweight. So
I mean,
in the
one of
SQL
the
environment,
things
it's a little better actually. So the DBT tool has actually been quite nice for teaching some of this stuff, and it comes a little bit for free to the student who uses it. Once they get started with it, some of these practices come along for the ride.
Okay, look, thanks. I will look into that, because we really, our focus is very much on, many of these students are not going to be professional data scientists. They're going to be physicists and biologists and public health and so on. And so we want to have stuff that they can take into their communities, and it has to be lightweight. But thank you. Yeah, we'll certainly look to that.
All right. And Joan also has a question.
Yes, Alan, I was wondering, what is the assignment you give them that leads them to go out and collect data and need to track its story?
Okay, so the project work across the semester is, in stages. So the first stage is that it's done in groups of about 4. So between the group, you have to decide on some question and type of data you're interested in. You then have to go out and find a data set relevant to that, get it in, clean it, or since many of the data sets that students find are in fact curated and clean already, you have to demonstrate that it is clean, at least. For higher grades, you need to find multiple data sets and do some integration across them. But the pass level is just one data set, get it into, get your hands on it and do this documentation of where you got it from and what it says. That's the first stage. The second stage is to do some basic reporting and charting of summaries of that data. So at that stage, we've taught them enough Python that they, and for the second stage, they have to do it in Python. The cleaning they could do just with a spreadsheet or whatever. But by the second stage, they have to work in Python to produce a couple of summaries and a couple of charts of something about the data. And then the third stage is they need to produce some predictive models. So again, it's done in a group of 4. So what we say is, you have to agree on something you would like to predict that's in the data. And then each member of the group goes and builds a predictive model for that. Many of them just choose, linear regression, but there are still lots of issues in terms of, doing some encoding when some of the attributes are, discrete and so on. And by that stage, they've learned scikit-learn. So they're not writing those bare hands. It's a few lines simply to take your data set and get a predictive model and see what it predicts. But the key thing there is that they have to evaluate the quality of the predictions by having a separate, training set and test set. And they should compare between the members of the group as to how well they have predicted.
Great, thanks. That helps a lot.
All right, let's thank Alan again. And now it's time for a break until the 1/4 when we start with our panel. And I think it's going to be very interesting. So please come back for that.
If you're speaking, I can't hear anything.
Can you hear us now? Joan?
Yes, now I can, thanks.
Okay. Well, let's get started. Right on the dot. So welcome back everyone to the last session and the last workshop on the last day of SIGMOD Pods. Last but not least of 2022. Thank you very much to the technical support engineer who's still here. And okay, so we have a very exciting close to today's talk. So we've had 2 really cool and very kind of insightful and inspiring keynote lectures. And we've had quite some discussion of a lot of technical topics, experience reports. And this has been primarily from the perspective of those of us working in the university. So we thought now for something completely different. So let's see what is happening on the other side of the fence, where our students are going when they leave us into the world. And so we're very thankful and very fortunate today that we're joined by Sarah Krasnik and Emilie Schario. I'll let them introduce themselves, but long story short, Sarah and Emilie have lots and varied experience in building and working with data engineering and data teams in general, and lots of different parts of industry. And so today the idea is to look at perspectives from industry on emerging roles in data. What are we doing well as educators and through our programs, and what are some gaps that Emilie and Sarah are seeing in practice through the work that they're doing. So we had the idea to do a few minutes of, say, provocation. So we'll each take a couple of minutes and raise some questions, say, highlight some issues, some topics for discussion. And the idea is that, well, at least the three of us will engage in a conversation, but overall, our idea was to engage the workshop participants. And since we're kind of small and cozy here, in Dutch you call it gezellig, I think we're about a dozen, including the folks online. I think we can make this an even more kind of cozy and open-ended discussion. So I think, in general, feel free to interrupt this. This shouldn't be a lecture and a one-way conversation or an exclusive conversation between us, but please provoke us and be provoked by what each of us is saying. So we'll just jump right in. I think Sarah's up first.
One thing I'll call out, if it's okay. I see the number in the chat going up, but if people want to just come off mute, that's probably going to be easier. So, Sarah, do you want to introduce yourself? Sure.
Hi, so my name is Sarah Krasnik. I have been in the kind of data industry for about just over 6 years now. I started in data science and kind of realized that while the kind of more research side and analysis side was interesting, I really enjoyed building systems. And so kind of navigated a little bit more into the analytics side and really found myself for most of the 6 years in data engineering. So led data engineering teams across a couple of different industries, but most recently finance and fintech. And what that entailed was my team was responsible for the kind of the data platform as a whole. So everything from ingesting data from external sources internally into the organization, the infrastructure that needed to support that, as well as kind of the transformation layer before we handed off data to other parts of the analytics team, as well as stakeholders in other business units. So what I would kind of like to touch on today is some gaps in education, at least for me, from my experience. First, there's a very big difference between static data sets and dynamic data sets. And what I mean by dynamic is data sets that change, that you just don't really know how they change because their change is out of your control. So oftentimes data teams, the data will come from the engineering team or some third-party vendor. And while the documentation or anything explaining what the data set is might say one thing, oftentimes that's just not true. And so it's really on the data team to catch those types of where the data doesn't really meet the expectations that you have of it. And there are a lot of different tools to help with that. And I think this is also very in line with some of what we heard in the previous talk as well. And the other thing that really comes to mind is kind of making decisions about not only what tools you use, but also the methods when you explore data and present it as well. In particular, I find myself talking about the 80-20 rule a lot of the time, where especially my background is mainly in startups. And so leading small teams were usually understaffed. There's a lot of work to do. And so you really have to evaluate what are the outcomes that you really need that will really move the needle, and what's kind of the fastest and most efficient way to get there. So how can you, so sometimes, right, if we talk in the data science sense or the modeling sense, sometimes a decision tree will just get the job done. And that's going to be simpler to explain to stakeholders. It's going to be simpler to implement, less internal resources in terms of people who need to work on it and develop it. And oftentimes that is just the trade-off. So the question here is really about how do you go about making those decisions, and where else do some of those decision-making frameworks apply?
There any immediate reactions to Sarah?
Okay. Well, my name is Emilie Schario. I live in Columbus, Georgia, a couple hours outside of Atlanta, if folks are familiar. I didn't do any academic training in data formally. My undergraduate degree is in American politics, though I focused on political methodology, which I didn't realize at the time is actually data analysis, setting up experiments, things like that. I wrote a thesis that used a lot of R, and that was my tiptoe into data. I've spent a career working and building data teams. So started off as an integration engineer, an ETL engineer, moved into an analytics engineering role. I was the first data analyst at a company called GitLab, which is now a public company. Watched the company grow from 250 to over 1,300 team members in 2.5 years. Most recently, I was director of data at Netlify, a web startup. And today I'm a data strategist in residence at Amplify Partners, a seed stage VC firm in the data tools, dev tools, and cloud infrastructure space. So a lot of the work that I do with our portfolio companies is helping them go 0 to 1 on both data infrastructure and getting started, but also building a culture around using and leveraging data for operational efficiencies. And so I've presented this diagram here when we talk about data in industry. You'll hear people say the modern data stack or their data infrastructure depends on which company has invested the most marketing buzzwords that week. But this is kind of what we're talking about. Data moves from a number of source systems. Often this is a combination of your application or production databases, third-party vendor tools into your data warehouse. And then once it's in your data warehouse, you transform it. So you'll notice here the ELT paradigm instead of the ETL paradigm. And then there are lots, what happens from there is kind of up to you, the way your organization organizes information, what your priorities are. Some companies choose to have a metrics layer and then use their data downstream of that. Usually that's organizations of a certain critical size. BI tools, which we've talked about a couple of times today, are very popular. And then there's also the operational data sync, or often called data activation, where we move data from our data warehouse back into third-party systems. And in one level, that can be things like if a user clicked a specific button in the app, I want to send them a very specific email campaign. So let's pipe that information into HubSpot for targeted messaging. But that could also be more advanced use cases where let's surface the top 10 books they're most likely to be interested in and pipe that into our production database systems. So that's kind of the modern data stack. I just wanted to make sure we're talking from the same ground floor there. And I won't go through this, but if you want a sense of what some of these tools look like to dig into, there's a list of some of the big ones here. Feel free to screenshot it, take a picture of it, whatever works. I'm happy to talk through any of them. Some are open source, some are not. This is certainly not a comprehensive list of categories. For example, data observability, which feels like the buzzword of the week, is not here. Event tracking. If you roll out a website, you want to know what pages people are visiting. That is not here. We've had an explosion of categories and tooling in the data space In the last 5 or 6 years, I'd really point to since Redshift, we see analytical tooling's just incredible. But if you're looking for where to get started, this is a good place to start. What I'll call out while I have the mic here is my email address is just my first name dot my last name, which was on George's first slide, @gmail.com. And you can email me at any time. That's all I got there.
Okay, thanks, Emilie. Are there any reactions at this point to Emily's
Just
ground level stuff? Okay, I have some questions, but for later. Okay, then I'll kind of wrap up. So I'm here in an odd position as the moderator and academic. So when I think from my perspective of how we engage and now through our programs engage with industry, a lot of what recently kind of provokes me are the kind of proliferation of data titles and data roles, and as you say, this kind of boom in the data space in the modern data stack. By and large, many of us are not even up to speed with what's happened in the past 5 or 6 years. So for us, it's kind of this new tsunami of new developments and advancements in industry that haven't propagated into, say, kind of our consciousness, let alone down into our teaching material. So one way of kind of organizing our thoughts here is we can think of roles as reacting to sort of societal and technical trends. Right? So if we think of, say, in the 90s and the early 2000s, we saw the rise of the role of the data engineer, kind of reacting to the web, advance of Moore's law. The trend there was really big data, and the need that was being satisfied was that of harnessing and just collecting this data, right? And so the technologies there were, let's say, kind of crystallized in tools, say, first generation big data tools, platforms, things like Hadoop and Spark. And now, based on this sort of foundation and then this need that's serviced by this role of a data engineer, we saw the next wave in the say the teens and then through to today, with the rise of the role of the data science that takes advantage now of these data collections that we're able to actually harness, right? So the context is big data and data engineering as a title and a role in organizations, but also the rise of, say, cheap compute, which made possible what we can say maybe is the AI revolution or the ML revolution, right? And there, the organizational need was to make value from this harnessed data, right? And the technologies there were, say, commodifying machine learning and solutions like TensorFlow and SciPy. And now if we look at what's happening in kind of starting kind of initial reaction to, say, the modern data stack and more recent advances, and now building on top of the data scientist role, and now the technical context is not only this ML revolution, but now also cloud computing. You mentioned also in the previous slide, Emilie, some of the technologies there. And the trend is, say, towards data-driven organizations and in general, digital transformation. And the organizational need now is the ability to rely on or have reliable data, high quality, clean, say, trustworthy data. And the technologies that, I mean, we can see emerging in this space are those which are supporting data cleaning, data wrangling, say, meaningful, beautiful data technologies. So things like knowledge graphs, data wrangling systems, data cataloging platforms. And for lack of a better term, some colleagues and I are giving a name, say, like knowledge engineer 2.0 or knowledge scientist, someone who's responsible for the semantics and the meaning of this data now that we're harnessing and drawing crazy value from. So this is one kind of simplified point of view, but then we see, if we look, even some of these titles you see, every year when I teach Databases 101, Daphne and we teach it together, I kind of look at, okay, where is SQL now? Because we teach SQL and you want to motivate, okay, how popular is it? What are the roles out there? What are the roles that are kind of emerging that actually need SQL, or the things that we teach in Databases 101? And you find sort of these now recognizable titles like data engineer, data scientist, more recently ML engineer. A new one for us, it hasn't even made its way into kind of our daily conversation much, especially in the bachelor's level, is that of the analytics engineer, and then more of these, and of course the classical data analyst, but re-emerging roles around knowledge, right? So the question is, as the university, we have kind of several functions to serve, and one is sort of preservation and conservation, and not buying into hype and trying to understand what are the underlying societal trends or what are the underlying scientific challenges. So it's always kind of a delicate balance between that and, you know, being able to train our students so that they can make impact in the world, or even in academia, right? Both, well, different discussion, but academia is also part of the real world. Anyways, so some questions here that pop into our minds are, like, did we prematurely overreact to this data scientist role? Was it a hype and we built all of these data science programs? Is it a thing? Like, we've created, every single one of us in our universities now have bachelor's, if not master's programs, and some of us have even like different flavors of master's programs in data science, right? In general, what do we need to pay attention, and also what do we need to ignore coming from practice in our curricula? What will and won't be of lasting value? So thinking maybe 10 plus years, what are the underlying principles that are emerging in these kind of successive waves of making value from data, and then the roles that facilitate this in organizations? And maybe just kind of to lead off with a first question, reacting to your slide, Emilie, you mentioned, maybe you can say something about this later, building data culture, right? So for this is for us in the data systems community, it's kind of a foreign concept of what data, what is this culture that you're talking about, and what does that mean for academic training of data scientists and computer scientists? Increasingly, I mean, one of the themes that has emerged in today's workshop, but also this whole week in SIGMOD pods, was the societal context of the work they were doing, right? Which is a new orientation for us. We're systems builders. We build things and we abstract away from the world, but increasingly we can't ignore this. And so this touch point to building, you know, effective data work in practice, effective data teams and organizations, we have to face what is data culture and how does that translate into not only education but also the technologies that we develop.
Oh,
okay.
we'll scoot over.
I probably won't do more talk.
Okay. So if I could actually go back a couple slides. When we notice the leftmost part, oh, there's a hand. Please come off mute, Alan.
Thanks very much. I actually wanted perhaps to just get some clarification of the term data engineer and sort of what its scope is, because both in what has just been described and in Joe's talk earlier, there was a focus, I would have said, on the person who manages the data and tries to make it available for everyone else, but with a strong semantic focus, a strong focus on understanding the meaning of the data. Whereas what I had understood people often mean is the person who supports the platform. Now, this is particularly important, I think, in the educational setting, because for the platform person, you need a lot of what George has described as the systems building worldview. You know, you need somebody who learns about the memory hierarchy and different performance characteristics and has a good sense of caching and what it can do. Whereas sort of the other side, where you're thinking a lot about the data cleaning and integration and so on, you probably don't need to put those students through a really good background in computer organization and distributed systems and stuff. And I'm just wondering, you know, is the term in fact overloaded? Is it that people typically, the same person does both of these? What's the current and evolving situation?
Good question. So part of my claim to fame, and at the risk of the people in the room starting to sharpen their pitchforks as I say this, I hate the phrase data science. I think it is a terrible descriptor. over the last 2 years, I've hired, I don't know, 40 people. So I've interviewed some 5 to 10x multiple of that. And probably about half of them come in with a data science job title. And the first question after like the niceties and here's how this is going to go is like, so data scientist, what do you do? And it's interesting because in this series of conversations, sometimes the answer is, I built this really cool recommendation system algorithm and deployed it and whatnot. And sometimes it's, I counted how many people placed orders yesterday. And it's not that these works aren't valuable, they're just fundamentally different ways of impacting the business. And so my proposal, and there's, I gave a talk at a popular industry conference called Coalesce. If you Google down with data science and then my first name, you should be able to find it pretty easily. But I propose that we stop using that title entirely. We stop using data science. We stop using data scientist. We shouldn't use terms that are ambiguous. And instead, we kind of center around the 4 terms that you have on your screen. So data engineers are responsible for moving data from outside of your ecosystem in. Analytics engineers work with data within your ecosystem. They're the ones who are trying to understand your business entities and making sure that the data is clean, transformed, ready for analysis. Data analysts are people who focus on driving business impact with that data. And then machine learning engineers is their own little hub in the world. As your team grows, you get more specializations. People get commas after these, right? Machine learning engineers, comma, clothes. Machine learning engineers, comma, shoes, if you work at Stitch Fix. Data analyst, comma, product. Data analyst, comma, finance, right? But the core of these is the same. And so if we go back to this slide, what I'm saying is that if I move the mouse, can people see it? Yeah, okay. So from here to the left, thank you. So from here to the left belongs to the data engineers. From here to about here, with like BI in a middle zone, belongs to your analytics engineers. And then everything to the right of that, which is focused on driving business impact, is your data analysts. And that's like a prototypical analytics setup. Does that answer your question, Alan?
So it provides some insight, but I mean, I guess the central thing, which I don't think I've really understood here, is who does the performance tuning and
your data
understanding
engineer
of platform?
Your data engineer.
But it's not just in getting the data in, it's with the data inside the system where you have to make sure that you're using the right tools and platforms and everything. I mean, I can see where you're coming from because that's driven by the business and its needs. But if we're educating students, many of them are going to go out with more technical orientations. So I'm just wondering whether that fits well in. I mean, the 4 descriptions you gave, I didn't see anywhere I would have said it's really about making sure that you understand your platforms and how to get good performance from them.
Yeah, and in my experience, those are consequences of focusing on the impact. And so what I mean by that is if you're loading 6 terabytes into Snowflake on a daily basis, it's your data engineers to know what the responsibility to know what the performance and the caching and the tuning that makes that 6 terabytes into Snowflake on a daily basis possible. And so infrastructure, permissions, those sorts of housekeeping, platformy responsibilities, I've always had fall to a data engineering team, but I'll pass it off to Sarah for more thoughts.
Yeah, I think it's a really great question because I think that everything that Emilie said about data science being confusing, I think that all of that actually applies to data engineering. And whenever I interview data engineers, I can get like a host, like 10 different responses of what they did, whether it is, oh, well, I actually shipped machine learning models versus I wrote a little bit of SQL and created a dashboard for the rest of my business. And both of those have been answers that I've gotten of asked people who are data engineers what they did. So to answer your question, also, Alan, is I think that it really depends. And I think there's also a lot of in-between space and a lot of platform responsibilities that are part of the data platform, that are part of the engineering platform, that are part of the analytics platform. And someone has to fill in those gaps. And I think that it just depends on, in my experience, like on the organization. So for example, something that we also haven't talked about is who actually validates that the raw data coming into your system is of quality, or who actually validates that it's coming from outside your system. So maybe the data engineer, but the analytics engineer is modeling it. So maybe they do, but there's kind of a give and take there as well.
Thanks.
So I find the breakdown into the roles and responsibilities really interesting. However, me as a professor, right, I try help lay foundation for a whole career. And the question, I think there's a challenge in getting people ready and employable. And at the same time, it's got to be foundational enough so that it lasts for a long time. Of course, there's going to be lifelong learning, but so I think the challenge with I think it's totally justified to teach them things that they might not immediately need, like caching and things like that, because they got to make a life out of it.
Yeah, and I guess I'll start here and pass the other way. My perspective, and whenever I've managed people, the thing that I try to teach them is when to ask questions and how to learn. So the tools will change, approaches will change as technology changes, but there are certain things like, how do you check the quality of your data? That has always been a question. That's always going to be a question. How do you make sure that the system that you're building scales? In some contexts, that could be caching. In other contexts, that could be something else to do with infrastructure. How do you present data? I think that every position that was mentioned on Emily's slide, in some point or another, has to have some sort of presentation skills. Either they're presenting within their team or outside of their team. And so I think from my perspective, a lot of it is what are the core concepts as opposed to the very technical, like this is how caching works.
Yeah, I just agree that you're making generalists. And early on in companies, that's what we hire. Almost always when we're hiring like the first data person, we're hiring though, if we go back to this slide, I like visual aids. Do you all like visual aids? Okay, cool. I hire analytics engineers. And the way I think about it, so I had the diagram of the stack. And if you think of data engineers to the left, analytics engineers in the middle, data analysts to the right, I actually say part of what I'm looking for is floor sweepers. People who, if they see something on the floor or the trash needs to be taken out, it doesn't matter, that's not in their job description, they're just going to do it. And so I think of this analytics engineering role as someone who has to be able to flex on either side of that boundary. It's not ideal. I want to give you the job description that captures the most of your work, but I'm also going to ask the CFO to take out the trash if there's trash in the trash can. And so we need to be able to have people who are generalists. And I think that's spot on. The fundamental skill set is the same. The tooling is what will change over the next 20 years.
Can I add another question? So what I haven't heard yet so far is statistics. Right. And that's always the big challenge. I think that at least in my undergrad education, it didn't play as much of a role, but I think today it's much more important. If you want to go into this direction, no?
So I have a framework. I'm actually publishing this on Monday. And if you want to give me your email, I'm happy to send it to you afterwards. But I have a framework for the types of work that your data team does for a company. They are, let's make sure I can name all 5 off the top of my head. They are data activation. So that's, if we go to this one, it's moving data into third-party systems. Metrics management, so aligning the business on the definition of revenue. Everyone knows what revenue is and what it means and what the goals are and things like that. And sometimes people use metric stores for that, but sometimes not. The third is proactive data discovery. So floating around in the data and finding insights about things that people aren't asking questions on. So surfacing behavioral patterns in the data. The fourth is experimentation, and that's where statistics comes in. So we'll hold that thought for just a second. And then the fifth is servicing the business and really being the interface between the data and the company where the tooling isn't there yet. Experimentation is the one domain where I see the most need for statistics. What we are seeing is that a number of tools are working to eliminate the need. A number of tools are working to make it easier, not necessarily eliminate, but make it easier to interpret statistical analyses. I have explained p-values to executives far too many times. And so using things like confidence intervals instead of having to explain statistical significance has really made it easier to get buy-in. I think it's a prerequisite, but what we're seeing is a lot of the tooling kind of puts that into the background. And I think that's actually a great thing. I want people to know and understand. I don't want the tooling to abstract those concepts away, but it also makes it possible for us to hire people who don't have the advanced statistical backgrounds by the tooling making it easier to open, to make it a wider community. But it's really in experimentation and some more advanced levels of analyses to really feel the need for statistics at all, I think.
Yeah, I'll just weigh in real quick. So I forgot to mention my academic background, and in undergrad, I was actually a math major, but I chose to do the pure math route. So number theory, very much my thing. Actually, statistics, very much not my thing, surprisingly. But what I kind of noticed is, especially with a mathematical background, what I learned and use, I would say almost every day, is asking myself, what assumptions am I making? So even in data science, I could pick up and learn all the statistical concepts that I needed for whether it's a particular model or modeling technique, but it was really understanding what are the assumptions and like, when will this not work, and almost putting a certain model or a certain approach kind of on its head. And I feel like there are kind of a lot of backgrounds that people can come from to really get to that end.
Actually, a very specific example that just popped into my head. So there's a tool called EPPO, EPPO. It's an experimentation platform. A number of like the big companies, Netflix, Airbnb, et cetera, when they run experiments, they've been able to use Cupid variance reduction to shorten their experiment time for a long time. But building that, the engineering infrastructure, the data infrastructure required for that to happen just requires a lot of bodies. And so EPPO is the first tool to make that commercially available. So now companies of all sizes don't need to have a team of 5 people building this internal tool to make Cupid available. Does that mean that some people are going to take advantage of Cupid who have no idea what's going on behind the scenes? Probably, but you have to trust a little bit of what the underlying statistical core is.
So Joe has a question.
Hi. Yeah. I don't know if it's a question. This might be one of those things where the end of it is, well, what's your question exactly? It's more of a comment from the audience.
We're here for comments too.
Cool. All right. Yeah, I've been around, for quite a while in industry as well as academia. And I feel like, we're spending a lot of time today with some prototypical box and arrow charts and with some titles for job descriptions. And in my experience, those change. They change every 3 to 5 years. And they're very much at the whim of which companies are promoting what, and companies come and go. So, I'm very resonant, and not just as an educator, but also as someone from industry, with the comment that was made previously that, these are not concepts. So, using, I don't know, 5tran to be on the very far left of this diagram is not a concept. It's not something we would teach at school. We might teach something like, what about security? There's a cross-cutting concern, data privacy. How do you preserve it across systems? We might teach a concept like, how do you profile data to assess whether it fits your expectations? And that would go across systems, and it would grow across this stack. And I think what I'd love to hear in this sort of industry people helping educators figure out kind of what matters is, what are the things that keep cropping up for you folks? Not sort of how do you segment the space, because that's going to change. Your answer to that will change. What are the sort of perennials of things that like people come in and we just keep having to teach them XYZ because they don't learn it in school, or they come in and it's really great when they've learned such and such a thing. Such and such a school has always made sure that they've baked that into their classes. Those would be super helpful to us as educators.
Yeah, for me, two very specific things come to mind. The first is, I guess they're kind of related, but the first is data quality. So just never making assumptions and always saying, it doesn't matter if someone tells me that, the no data is missing or this column doesn't have missing data, always double check. To me, once I think people get into industry and time goes by, that becomes innate. But to me, I haven't noticed that in a single person coming out of an undergraduate degree, for example, or a master's, in terms of having that kind of questioning of anything that comes their way. And I forgot what the second one was. So do you have one?
No, I wholeheartedly agree, Joe, for what it's worth. That's why when I talk about the work data teams do, I try to avoid it being a tool conversation and much more focused about how we drive business impact. So for example, experimentation is a way that you can tie the work you're doing to business results. And I think a common problem that I see in hiring is that, especially in people's first jobs, is they get so into the tech and tooling and my query was 10 times faster when I changed this parameter. I'm like, that's great. What is the business impact? And so not just the what you're doing, but talking about it in terms of the why you're doing it really changes how we have the conversation. Now, I've spent all week here hearing people talk about how great their query performance tuning is. So maybe that's not the takeaway for your class, but I saw the laughing emoji. And so maybe that's not the takeaway. I think you're right, though, in that I don't want to hire people who have experience with Fivetran, DBT, Snowflake, because 5 years from now, their experience is worthless. And there's a great blog post on the internet by a venture capitalist named Namdi. His website, I think, is whoisnamdi.com, where Namdi is spelled Nnamdi, I think. It was on the front page of Hacker News a couple of days ago. But he did an analysis of software engineers very recently. And he talks about how software engineering actually has a huge retention problem. And one of the reasons for that is because the technology is changing so much. By the time people are on their third or fourth set of technology, they're like, screw this, I'm going to take an easier job. One where my skills aren't outdated every 5 or 6 or 8 years. And so I don't want people coming out of school or any degree program with oh, these are the 10 technologies I know, and that's that. I want them to know, here's how I use data to drive an impact. And whether that impact is an operational efficiency where we launched a better product or a better feature, or we made the finance team more productive because we automated some manual invoicing process, or we now have a little bit more statistical rigor in our experiment analyses, so be it. There's a variety of ways, but it can also be that they are looking at gender parity in their politics research or whatever it might be, right? So I think that data in a lot of ways is just the means to driving the impact. And it's my favorite hammer, don't get me wrong, but we can't get so into the hammer that we forget what we're trying to do in the first place. Does that answer your question?
I thought it was a good conversation. Thank you.
Cool.
Other questions from the audience? Almost questions then.
Okay, so we've kind of mentioned say gaps. You've mentioned a couple of, so as a concept that of data quality, and as a skill, perhaps contextual reasoning or being aware of the why. Are there other kind of skills that you find lacking in recent graduates? So often when we design and redesign a bachelor's curricula, it's not only the content, but also say more, say professional skills, even basic things like being able to write clearly or to give presentations. Are there things in the skill space that you see a mismatch in recent graduates and the demands of the current roles in the data space?
I'm going to say again that I have two that come to mind, and we'll try not to forget the second. So the first thing that comes to mind is writing code and doing analysis that will happen more than once and understanding what that entails. So what I mean by that is if someone asks you a question, you have to go in a deep dive. So what you're, to Emily's point, like if you only have to do it once, okay, so your query takes 50 seconds when it maybe could take 10 seconds, but at the end of the day, if you're doing it once, it doesn't matter that much. But if you're building on top of that and you have a large team and there are multiple people contributing to something, it has to be concise, it has to be efficient. Otherwise, the cost to the business and the business value is just employees' time, and employees' time is not free. So that's kind of the first thing that I think is lacking. The second thing is, to your point, George, about data presentation and really being aware of who the audience is that you're presenting to, because oftentimes inside of the classroom, you're presenting to people with very similar backgrounds. They have all been through the course, or the professor who knows much more than the students do. But a lot of the times in industry, you're presenting to people outside of the data team who may not know what a p-value is, and you have to explain it to them, and you can't make that assumption. Or when you display a chart, you have to make sure that it is crystal clear and really try to understand, well, how could people misinterpret this? If even one thing comes to mind, it will probably be misinterpreted, is what I've learned. And so I think that is also lacking, where a lot of the time the presentations are, for example, any final project that I've done has always been write a 5-page paper or a long report. But sometimes the most impactful is give me one chart with a 1-line caption. That is generally what goes on a PowerPoint slide and is extremely, extremely hard to do well.
The best data viz is a sentence.
Okay, a couple of minutes. Any last questions? I have a question, but yes, please.
So I understand that you refer a lot then to like soft skills. So because if I understand correctly, you are referring to how they present and know their audience and what they will need, about taking ownership of their work and making it complete and not needing someone to swipe or behind them, and about understanding context, about asking queries.
Yeah.
So it's really, maybe the gaps that we are having is really on soft skills, not on technical skills so much.
Yeah, I can teach anyone to code. I can't teach them to show up to work on time. And I think some of the best data people I've ever worked with, hired in my whole career, are college dropouts, high school dropouts, right? The technical skills come with time and mastery and practice, and that can be maybe the theoretical piece they don't have, or they'll read a lot in their free time. But how do you interface with people? How do you drive impact to the business? Like, those things are so hard to teach. And I have no idea how to teach that other than letting people learn over time. But the soft skills are it's almost a misnomer. It's cliche to say, but it's a misnomer to imply that them being soft, it makes them any less valuable.
And I was just going to say that I totally agree with Emily in that it's learned with time. But if undergrads come out of school and they don't start at 0, they even start somewhere and having that exposure, then the clock just starts earlier.
A really tactical thing, I remember I had an amazing advisor for my research in my junior year of college, Professor Valenzuela. I loved him. He was amazing. Like, I still I still send this man a Christmas card. This is a decade later. And he was the first person to ever send me a Google Calendar invite. That's such a small thing. And I just take for granted that I'm going to send people Google Calendar invites and they're going to know that there's a Zoom in there, or that the invite is going to have the information, right? And maybe now with COVID, it's in all this time of remote work, it's different, but those sorts of things are just so fundamentally different in industry, and making sure those skills are bridging the gap. Like nobody says to you on orientation, like, okay, by the way, everyone uses Google Calendar. We start meetings on time and we end them 5 minutes early so people can make their next meeting on time. Like that's a gap that just nobody says. So.
Alan?
Yeah, thanks. So look, I think this soft skills discussion is crucial, and all the accreditation bodies put a lot of stress on that, but it's also something where we don't know how to do it well. The important thing is that we keep trying to focus it. The place where I think we can make the biggest shift, though, is on the technical side, not in terms of the specific tools, but as Joe said, what are the concepts? So, security's been mentioned, data quality has been mentioned. I actually think that a sort of a sense of scale, which has been mentioned, is one which is very hard to teach and requires a lot of time to do it, but is something that an academic program can really work on. I guess what I'd like to
data volume scale.
Sorry?
Do you mean scale in like working with big data?
I mean, in the more general thing, things that work in the small don't necessarily work in the large. So the scale of the data, the scale of the team, just an awareness that you have to do things differently when the scale of an issue shifts. And I mean, that can be a theme which one gets across a curriculum, from an algorithms class to a computer organization class and lots of other places. I do think that it's really important to try to articulate some of these core ways of thinking, which are not just generic. I mean, as you say, a history graduate can learn to give presentations and probably will, as well as a computing graduate. But there's a bunch of stuff which is at the heart of the computing worldview or the data worldview. And I think it's important to try and pull that apart, work out what it is ourselves, and then be explicit to our students that that's what we're trying to get them.
Alan, I think there was actually a really great portion of the talk that you gave that I caught, which is best practices being very hard to teach. And I think
Sorry, I've just lost the sound.
Yeah, me too.
You good now?
Yep.
Okay, great. So I'll start over because I started with a compliment, which is Alan. You mentioned at the end of your last talk about best practices, and I think there I can totally imagine how hard they are to teach, but they are extremely important. And one thing that came to mind now is certain things around, like, when does security matter? Security matters when you are working on something large with a team that you're exposing to the internet. If you're just on your own local computer and everything is local and it's not exposed, it doesn't matter. And so there are certain concepts of, like, what does it mean to build a system that is exposed and work on a team? Security is a good one. Another one is, even if you think about database permissions, right? There's a difference between having one database user that everyone uses to log in, or having multiple database users per person. And one way is more secure than the other. And so there are certain things that come up in industry where there are little things that I find that personally I just picked up from, as Emily said earlier, time and working with colleagues. But I think compiling a list of those could be extremely impactful.
Right. Well, I mean, hopefully we can perhaps do it through the Slack channel for this. That would be wonderful for us in teaching.
Okay, thanks. This is a very nice discussion. I think we need to wrap it up. I see we're a little bit over. And so let's thank Emilie and Sarah. Thank you very much. Thanks for this very nice conversation, and we can continue on the DataEd Slack. So if I can have everyone's attention just for a single minute, I'd like to do a closing. I'll just share a single slide here. So kind of should work. All right, one slide summary of today. So just some takeaways. There are many really cool and stimulating discussions and ideas that popped up today, but just a few to note. So first, centering data from the first year to increase engagement and social awareness, extremely powerful perspective. In general, there's a rich diversity of ongoing work and open challenges in the data systems education space. So we're looking forward to your new results and submissions to DataEd 2023. In teaching responsible data systems, so responsible data science is not just a technical challenge, right? And also we see this echoed in our discussion just now. What the world should be like is not up to a mechanism, right? It's not up to the model. Our conversation in the afternoon, so there is some agreement and there's also some disagreement on what are the essential topics. What are the concepts that we should teach around data in our our undergraduate programs, and also when and how to go about teaching them. There's a lot of work. There's a much richer and conversation that remains to be had here, and then work around that to move it into our programs. And then finally, a takeaway from this really nice conversation that we just had with Sarah and Emilie. One is, so non-technical skills are especially critical in contemporary data work, and they're especially difficult to teach, as many of you, for example, Alan, have pointed out. So thank you very much for this very nice first DataEd. Just two reminders. So let's keep the conversation going on Slack. That's why we set up a separate Slack for this activity. And as a reminder, we will write a workshop reflection. And so please reach out if you'd like to contribute. We, of course, at a minimum, acknowledge everyone who participated today. But if you want to also join the effort, please just let us know. And so thank you. And let's thank ourselves for excellent first DataEd 2022. And thank you everyone online in all the different time zones. And so with this, I'm going to close the Zoom call, which I think is a formal conclusion of the workshop. Thank you, Alan. Thank you everyone for your support. Okay, bye-bye. Thank you for organizing all that.
Yeah, thank you.
I really like the